Welcome to our course on the Spring MVC framework. Throughout this course, we're going to teach you to use Spring MVC to develop better web applications in Java. Spring MVC is the topic for our course, and it is a Java Model View Controller framework. So we know that MVC, or Model View Controller, is a pattern that is often applied when building applications. In this case, Spring MVC has developed a framework that helps us structure the architecture of our web applications. The framework is built on top of Spring, which allows us to keep the different components within the web application very flexible and loosely coupled. You'll find that the framework really adheres to the separation of concerns principle and divides the different layers up of a web application. We'll discuss more about the MVC framework and the benefits of Spring MVC later in the course. But for now, you just need to know that really Spring MVC will change your perspective on web application development. I remember before Spring MVC, I always felt like there was something missing when I looked at custom-built Java web applications that strictly just used JSP and servlets. There really was no consistency, there was really no architecture to these applications that I saw, and I always felt like there was this piece that should make things easier and make things a lot more clean and kind of perform that separation of concerns. The biggest criticism of early Java web applications is that everything went into the JSP, all your logic, your authentication. And once I was introduced to Spring MVC, now I think it's about the only way to build web applications. Just because the framework provides such great assistance and tooling and reusable support for developing web applications. The course is going to teach you a lot of things that revolve around the framework. I just highlighted 3 of the main principles here. One is we're going to teach you how to configure the framework. So Spring MVC, like Spring, has some configurations that need to be put in place, and the different beans you use often allow you to customize different pieces of the framework and make them perform in different manners. So I'll teach you those configurations, and then we'll look at the key framework components. The key framework components are things like controllers, view resolvers, views, handler interceptors. There's also request mappings, and there's data bindings, and there's a lot of components that we need to take a look at, and they all really make up the request processing lifecycle within Spring MVC. And really, that's what it's all about: taking in a request from a user and sending back a response. But Spring MVC is so great because it takes a lot of the steps that normally occur in that process and it makes them easier by delivering components that are ready for our use that are able to do things such as data binding or resolving our views. You'll see more about how the framework makes things easier as we work through the course. So let's talk about the prerequisites for this course. If you've ever developed a web application, you know it's not a simple task. There's a lot of different technologies that go into the stack of a web application. For example, if it's a Java web application, you're working with Java and you have the Servlet API. So that's something you need to understand prior to coming into this course. You also know then you build out your client side, so you're going to be using HTML, JavaScript, and XML. Those web technologies then sit on top of a Spring framework, so Spring MVC. And a foundational level piece of Spring MVC is Spring Core. So you should also have some familiarity with Spring Core. I'm not going to touch on some of the basic topics within Spring. I'm going to stay focused on Spring MVC and that web piece of the framework. There are plenty of resources out there, especially by O'Reilly, that can help you build your skills in these technologies and then be able to take this course and really get the most from it. And finally, I'd like to talk about our course project. So as we work through the different lessons within the course, we're going to be using a very simple project just to illustrate different demonstrations that showcase different features of the framework. And when we do this, we're going to be working with a project that is built around two domain objects. One is a project and the other is a resource. So a resource would be something like a staff member or maybe a computer or some other resource that we need to complete a project. The project is not complete by any means that we're going to use throughout this course. It's not something you would then deploy into production and start managing your projects and your resources. With the complexity that's involved in a web application, I had to sometimes really force the issue to demonstrate different principles within Spring MVC. However, the great thing about that is it's really obvious what we're trying to achieve because I have taken some liberties with the project, and that makes it very important for you to update the working files for each lesson. There are things that kind of fall outside of the Spring MVC scope that I need to build into the project in order to demonstrate the different principles that we're going to be covering in each lesson. So make sure you update your working files for each lesson that we cover. I'm excited for this course, and I'm ready to get started. Welcome to the Introduction to Spring MVC chapter. This chapter is the gateway to advancing your skills with Spring MVC. The lessons in this chapter will lay the foundation for you to understand and work with the framework. Let's talk in more detail about the goals for this chapter. Before we dive into Spring MVC, we're going to take a look at the actual model view controller pattern and discuss why it's used, talk about the components within the pattern, and look at the benefits. We'll view some sample projects that really illustrate why the model view controller pattern is one of the best approaches to building web applications. From there, we're going to discuss how Spring applies the model view controller pattern within Spring MVC. We'll review features within Spring MVC such as request processing and data binding. After that, we're going to get hands-on and we're going to start installing the software that we'll need to work through the course. First, we will install the JDK and then we'll move on to install the Spring Tool Suite, which will be our IDE that we'll be using throughout the course. For our capstone chapter, we'll be walking through a hands-on demonstration with Spring MVC, and this is going to give us a glance of some of the major framework components that we discussed. This chapter is designed to help you cross the bridge from a complete beginner to a hands-on student in upcoming chapters. Pay close attention to the lessons, and you will be building Spring MVC applications in no time. The concept of Model View Controller builds the foundation for the Spring MVC framework. Since Model View Controller is so important to Spring MVC, let's take some time to discuss its core concepts, why it exists, and how it benefits developers. The term Model View Controller means many things to different people because the concept is not concrete. Some believe MVC is a pattern. Others believe it is an approach to system architecture. Some say it is a principle, while others believe it's just a technique. However you decide to label it, MVC boils down to the idea that we separate our systems into three main parts: the model, the view, and the controller. Let's discuss each of these parts. The model represents the entities or objects that make up our application and are used to store information. For example, a financial system may contain objects representing an account or a transaction. When building the model, some developers will create entities that mirror the underlying database tables. Some developers may disagree with this approach, and that goes back to how MVC is quite subjective. The next part of MVC is the view. Views are easy to understand because we see them all the time when using software. It's that graphical representation of the system that contains information from the model. Views simply represent the user interface that we interact with inside of an application. They build the presentation layer that we use to display information to the end users from the model. The controller is found between the model and view. It plays the important role of performing all of the application's logic, essentially making the system work. The controller is used to execute the actions we can perform within our system. It also facilitates communication between the model and the view. The controller is really the brains of any application that we build. For example, the view layer may pass some data to the controller regarding a transaction in our financial system. Upon receiving this information, the controller can validate the data, perform the transaction, and store the transaction data using entities from the model. It then can take the updated model and display it on the view. Whether you regard MVC as a pattern, a principle, or architecture, it simply means that we will construct our application by dividing it into a model, a view, and a controller to separate these concerns. MVC advocates that we keep these three layers separate and do our best not to intermingle or couple them. This provides us with many benefits when we construct our applications. In this lesson, we'll take an up-close look at the model view controller pattern using two simple Java projects. While inspecting these projects, we'll gain a better understanding of the drivers for using MVC and some of the benefits of the pattern. Both projects that we look at perform the same function. The user is asked for their ID, and when presented, it simply greets them with hello, and then their name. So with that application, I think we're ready for a startup. Let's take a look at these two projects to learn more about MVC. The first project we're going to take a look at is the pre-model view controller project. As its name implies, it does not use any of the concepts of MVC. So this is what you may see in some old Java applications. We're primarily going to look at the hello.jsp file. The other file, form.jsp, is simply the form that will submit to this JSP. And once the execution heads over to this project, you'll see a number of things happen. First, notice everything is inside of this JSP. So we're going to intermingle a number of concerns within this JSP file. The first thing you should see as well is we kick off with a scriptlet. And this causes a lot of the problems of the past. The scriptlet allows us to include logic that really has nothing to do with our view. So here you can see in this block of code, we are connecting to a database so that we can execute a query that will select the person based upon the ID that we are receiving as a request parameter. Once we execute the query, we grab the first name and we add it as an attribute to the request. We then, finally, within actual view logic, reference that attribute so that we can display it on the page. So what's the problem here? Well, as we said, everything is intermingled. All the concerns of our application are found in one file. And this is where you will hear the term ball of mud or spaghetti code thrown around. And it's definitely an indicator of poor code quality. This code is hard to read because we're mixing several technologies. You really need to imagine this on a larger scale. If this were a huge system and not just this simple example, this would be almost impossible for a developer to navigate and read the code in order to understand the flow of execution through our project. So enough on this project. I think we hit some of the deficiencies there. Let's take a look at a simple example that does adhere to MVC. So we're going to look at this project. It performs the same function as the last one. And pretty much it has our two JSP files, the form, hello.jsp, and then you're going to see that we've added classes. So we have the person and person DAO classes. as well as a Hello World servlet. And here's where we're going to start. This servlet serves as our controller. When the form submits its request, it's going to come to this servlet, and the servlet is going to retrieve the person ID parameter. It's then going to use that parameter to query the database for a person with the person DAO's find person method. If we take a quick peek at that class, you can see that it encapsulates all of our logic for data persistence. And you also see that it's leveraging this person object, which really is an object within our model because it's where we are storing the information for our system. Now, returning to the servlet, you'll also see that once it receives that person object from the model, it adds it as an attribute in our request, and then it forwards execution over to the view. So you can see it's forwarding to hello.jsp. So within our servlet or our controller, we are performing some application logic, and we're also facilitating that communication between the model and the view. Now, an important thing to recognize here is while the controller is interacting with the model and view, it's not a component of either of them. It's not embedded within them. It is a separate, distinct entity. And that's what we're talking about when we want to separate the layers of our application according to the MVC paradigm. You'll also notice we're pulling back the person object, and we're using that person object, which represents our model. That object could be used in other portions of the system, so we're getting reusability. Now let's head over to our view. So if we take a look at hello.jsp, you'll notice the first thing, it's very simple. All of the code within our JSP is focused on presentation. It's all about how we're going to present the information that we have stored within our model. It's clean, it's not cluttered. It doesn't have those other concerns embedded within it that are going to distract us as developers. The main takeaway from this is that MVC is going to separate the concerns of our application. So here we have our view, we also have our controller, and our model. And when we structure applications like this, it decreases the coupling between those layers. And that builds code that's easier to maintain. It's also extremely predictable because we have a pattern that we can use to build out all the areas of our system, no matter how large it grows. So it's very scalable. And it also allows us to reuse code. And finally, to the best part, Spring MVC is even better. What we just looked at is a very antiquated approach to MVC. What Spring MVC does to make it so much better is it enhances the execution flow we just discussed by adding helpful components that ensure we as developers get a great design every time, and it makes development much easier. We'll learn more about this as we continue throughout the course. In this lesson, we'll discuss Spring MVC and cover its major features that allow developers to build better web applications. Spring MVC is a web framework that uses a Spring-based approach to building web applications that adhere to the MVC pattern, so you get all of the benefits of Spring and the model view controller pattern. Spring MVC is built on top of Spring's IOC container. The IOC container supports dependency injection, which is found in Spring's core. Dependency injection allows us to loosely couple the components within an application. Because Spring MVC is built on top of the IOC container, it integrates well with other Spring projects such as Spring Data or Spring Security. Also found within Spring MVC is a variety of components that facilitate how we process requests and serve responses to those requests. We're going to talk a little bit more about request processing in detail. Every web application's primary concern is to service requests. It receives a request and provides a response. In our case, we're talking about HTTP requests that are going to enter Spring MVC's front controller. These requests can be sent by a browser or maybe some other service. When the front controller receives a request, its primary job is to decide which of the Spring MVC controllers should handle this request. Now, it has a variety of strategies that it uses to determine which controller to select. The most common is to inspect the URL and then match it to an annotation found on a controller. Once it has selected the appropriate controller, it forwards processing of the request to the controller. The controller then executes the application logic, and this can be pretty much anything. Maybe the controller will invoke a service method that uses a repository to write information to a relational database. It doesn't matter. Once the controller's application logic has finished, it needs to do two things. It needs to provide the front controller with a model, and it also needs to tell the front controller which view to select. So once the front controller has the view name, it retrieves the view that should be used to process this request. It also passes the view the model, which contains all of the data that we need the view to present in the response. Once the view has been constructed, the front controller then responds to the request with the view. So as you can see, Spring MVC's request processing lifecycle provides a standardized approach to processing requests. This approach can be implemented throughout all the components that make up a system, and that creates a very uniform system. Another advantage of the request processing lifecycle is that it allows us to introduce custom components that will alter the behavior of the lifecycle. These custom components can do things such as manipulate the model. They can change how the front controller selects a controller. It can change how the front controller selects a view, or it can customize data binding. We're going to talk about data binding next. Data binding is a very convenient feature within Spring MVC. Basically, when the request comes in, it can contain HTTP parameters, and those parameters are name-value pairs that hold information related to the data that's being passed back to the server. So on the left side of your screen, you see a screenshot from Chrome's developer tools that shows the parameters that are associated with the request I was inspecting. We see it has the first name, last name, and age parameters. In this case, first name would be the parameter name, and Kevin would be the value associated with that parameter. So here's where data binding comes into play. It is able to take the parameter name and match it to a field name on a class, or a POJO. Once it matches the parameter name and the field name, it takes the value of the parameter with the matching name, and it places it within the field that has the matching field name. So it's a way to transpose information from the request parameters to fields on a class. One of the advantages of Spring MVC's data binding is that it's able to accommodate multiple data types and perform type conversions when necessary. It supports collections, arrays, and other custom data types. In general, it prevents us from fishing these parameters and their values out of the request, which is often error-prone. Sometimes we can assign the wrong value to the wrong field, or we can misspell a parameter name, and that causes all sorts of problems for developers. It's all taken care of with Spring MVC's data binding. Next, we're going to quickly introduce several other features found within Spring MVC. So within Spring MVC, there is support for validation and error handling. So the framework provides a standardized approach to validating user input, and then when an issue or validation is flagged, it provides a standardized approach for alerting the user of that error. Spring MVC also provides support for file uploads. The components within the framework greatly reduce the amount of work that is necessary to allow our end users to upload a file. Spring MVC's tag library also provides us with some very helpful tags that are able to support data binding and building out form backing objects, which we'll discuss later in the course. And then finally, another great feature of Spring MVC is its view resolution capabilities. It's able to provide multiple view formats based upon the end user's preference. So it's capable of rendering our model and its information in Excel, PDF, and JSON. As we work through the course, you're going to become masters of each of these features so that you can build well-architected web applications using Spring MVC. In this lesson, we're going to download and install the Java Development Kit, or JDK. The JDK includes tools for developing and compiling applications written for Java. Additionally, it also includes the Java Runtime Environment, or JRE, that is used to run applications. We're also going to need this software package to run the IDE that we'll be using to build our Spring MVC projects. So to get started, simply navigate to Google within your favorite browser and search for Java Development Kit. You'll see that the first link provides us with the option to download the Java SE Development Kit. So we're going to navigate to this part of Oracle's website. You'll see that we are currently on Java 8, update 152, and that's the one I'm going to be using. If your version number is off by an update or two, that's not a problem. Now, you'll need to pick the appropriate installation for your operating system. I'm still on a Windows 64-bit machine, so I just click on that download link after accepting the agreement. Now, you'll see that I have already downloaded JDK 8 Update 152, and that's just to save us some time so you don't have to sit through a download. So I'm going to cancel my download. You should proceed with yours. Now we're going to navigate to that installer, and if you double click it, it's going to ask for permission to install the update, and you want to grant the installer those permissions. At this point, the installer is going to start to unpack, and pretty soon we'll be prompted with an installation wizard. You're going to simply click Next. I'm going to allow the JDK to be installed to its default directory. So here you can see it's going to be installed under the Program Files directory on my C drive. And I'll just click Next. And at that point, it's going to start the installation process. If the installer prompts you to confirm the installation directory, simply click on Next, and this will begin the installation of the JRE now. If everything has installed successfully, you should receive a message informing you of that. Simply click Close, and that completes the installation of the JDK and the JRE. We are now set up to run Java applications and to use our IDE on your workstation. In this lesson, we're going to download and install the Spring Tool Suite. Spring Tool Suite, or STS, is an Eclipse-based IDE that has been customized specifically for building Spring applications. We'll be using it to build our Spring MVC projects throughout the course. To get started with the download, simply type Spring Tool Suite into Google, and then the first link you see is the spring.io/tools link, and this takes you directly to the Spring Tool Suite page on the Spring website. If you scroll down, you'll see the option to see all versions, and from here you can select the version of the software that is appropriate for your operating system. In my case, I'll be selecting the Windows 64-bit, and it will prompt me to download a zip file containing the installer. Now, I've already downloaded this file just to save us some time, so I can navigate to my desktop where I will find that zip file, and then I simply use an extraction tool to extract the tool to my desktop, and there we can see the folders getting built. So once the software has been extracted, open the folder, and within it, you're going to find the STS bundle folder. And inside of that, you're going to find 3 directories, one for legal, another for the Pivotal TC server. This is a Tomcat-based server that you can run applications on. And then you're going to find the Spring Tool Suite directory. Inside of that directory is going to be sts.exe. If you click on that, it's going to open Spring Tool Suite. Now, the first time we open it, we're going to have to specify a workspace directory. If you're familiar with Eclipse, you know that you have to provide a directory to house your workspace, which is going to contain all of your projects. For the course, I'm going to recommend that you simply create a workspace directory on your desktop. So click on Browse, and then scroll up to your desktop, and then hit Make New Folder, and type Workspace. And just click on that workspace folder, and hit OK. I would also recommend that you check the Use this as the default, so you do not have to make this selection every time you open the tool. Once completed, just hit Launch, and we're going to begin to open STS for the first time. Once the tool opens, you're going to be greeted with a dashboard. From this point, you're able to use the IDE to build Spring MVC projects. In this lesson, we'll demonstrate and inspect a simple project to learn more about the major components necessary to build an application with Spring MVC. To get started, let's take a look at our demonstration. It's a simple web application. As with tradition, it's Hello World. Now, you're going to see there's a lot more behind this simple application. Let's take a look at the project. Within the project, you're going to see roughly 3 classes that allow us to provide the Hello World capability with Spring MVC. There is also a JSP file that we have placed within our source main web app webinf view directory, and that JSP is message.jsp. We're going to start out by looking at the app initializer class because it's really where it all starts. You can see that App Initializer implements Spring MVC's Web Application Initializer class. The Web Application Initializer is a Spring interface that allows us to configure web applications programmatically. The Application Initializer serves as the initial entry point into our Spring MVC project's configuration. You'll notice that it contains the onStartup method, which we have overridden. Within this method, we're doing several things. First, we are building out an application context or an IOC container. We then register the appconfig.class. And if we take a look, this is a configuration class that's found within our project. Once we have that application context built, we pass it to the DispatcherServlet's constructor, and this builds out a DispatcherServlet. Starting with Servlet 3.0, we are able to programmatically register servlets, and Spring's Web Application Initializer allows us to take advantage of that feature. So here you see that we are dynamically registering the dispatcher servlet. The dispatcher servlet implements the front controller pattern. It delegates requests for processing to other framework components such as view resolvers or controllers. It's a simple, plain Java servlet, and we need to map it according to the specification, and here you see us doing that programmatically. Another class worth inspecting at this point is the AppConfig class. We mentioned there is some configuration contained in that class that is important to Spring MVC. First, you'll notice that this class is annotated with the Enable Web MVC annotation. This annotation is going to provide us with some infrastructure beans that will support request processing. After that, you'll notice that we have provided the component scan annotation. And this is primarily so that we can scan the com.o'reilly.mvc package and pick up our controllers. So here you'll see the simple controller would get picked up by the component scanning, and that controller would be registered within our IOC container and available for request processing. Finally, within the AppConfig class, you're going to see that we establish a view resolver. And this is a component that translates a view name into a view that we actually use for presentation. So basically the code we're looking at within this bean is going to take a view name and then go find the appropriate JSP using these prefixes. So here you see that we prefix a view name with webinf view, and then we suffix it with .jsp. And if we follow that sort of naming convention, that leads us to the webinf view and then message.jsp file. So once this configuration is established, let's talk about what happens when a request enters our application. So the request is going to come in to the dispatcher servlet that we have established, and the dispatcher servlet is going to look for an appropriate controller to map the request to. It's going to inspect the URL. And if you take a look at simple controller, you'll notice that it has a request mapping for the /message part of the path. And it will take that request, and the dispatcher servlet will forward execution to this method because of the mapping that we have established. The hello world method will be invoked on the simple controller class, and we're going to add a simple attribute to the model named message, and it's going to have the value of hello world. Then our handler method is going to return the string message. And that's where the internal resource view resolver comes into place. It takes the string message, it prefixes it with webinf view, and then suffixes it with .jsp, and that leads us to the message.jsp file, which gets returned in response to this request. Now you'll notice it's very simple. We just have our h1 tag, and within it we are displaying the message attribute from the model, and that is hello world. And that's how we wound up seeing our very simple application. So in this lesson, we got our first glimpse of a Spring MVC project. We discussed some of the major components and how they interact in order to build a web application. Now, there's many more features to Spring MVC than this, and it really allows us to build robust web applications. We're going to see and learn more about them in upcoming lessons. In this chapter, we'll focus on configuring Spring MVC with Spring's Java-based configuration. Throughout the years, Spring has established several approaches for configuring the framework. These include XML, annotations, Java, and Spring Boot. Currently, Java configuration and Boot are the two most popular approaches for building MVC projects. This chapter focuses solely on Java configuration. Let's take a peek at what you'll be learning. First, we'll take a look at the history of Spring configuration so that we can identify and discern between the available configuration options. Next, we'll launch into a sequence of lessons designed to build a Spring MVC application starting from a blank project. Starting from square one will give you the expertise required to fix configuration issues when things get challenging. We'll structure a new MVC project using STS and Maven. Additionally, we'll walk through the logging configuration for your project so that you can get verbose output regarding the execution of your application for troubleshooting purposes. After establishing the project foundation, we will learn how to bootstrap Spring MVC within a Servlet 3.0 container. I will demonstrate how to register Spring MVC components such as the DispatcherServlet, configuration classes, and controllers using techniques like component scanning. Additionally, you will learn to work with application contexts, eventually establishing a root application context that sits on top of a context hierarchy used by Spring MVC to provide beans. Finally, to wrap up the chapter, we'll discuss how to configure a view resolver which allows the dispatcher servlet to create views in response to requests it receives. By the end of this chapter, you'll be a master at configuring a Spring MVC project using Java. In this lesson, we'll review the history of configuring Spring projects. This will give us a better understanding of the progression of the framework and our options for configuring Spring MVC. Once we walk through the history, we'll then take an in-depth look at each configuration option. To help us understand the history behind Spring, we're going to use this simple timeline. It started in 2002 when Rod Johnson wrote a book, Expert One-on-One J2EE Design and Development. This book talked about some of the underlying issues with EJB and Java EE. The book recommended a better approach to development using a concept called dependency injection. Now, in 2004, that's when the Spring framework came to life with the release of version 1.0. The framework highlighted many of the concepts that were advocated for in Rod Johnson's book. The initial release of Spring version 1.0 used XML configuration to build out the beans within the IOC container. Now after this, the release of JDK 1.5 included support for annotations, and in 2007 we saw Spring adopt annotation-based configuration. Now you could not configure your entire project using annotations, so it was often a hybrid model between XML and annotations. A third configuration option was introduced in 2009 with the release of Spring version 3. This version introduced the option to configure projects using Java, and this was made possible due to the release of Servlet 3.0. With the release of Servlet 3.0, the web.xml file was no longer necessary, and this allowed for configuration of Spring projects entirely within Java. In 2014, we saw the release of both Spring version 4.0 and Spring Boot. Spring Boot was really a game changer in how we configured Spring. Instead of us explicitly defining much of our configuration, it was predetermined for the developer, and the developer mainly customized the configuration when appropriate. In 2017, most recently, we've seen the release of Spring version 5, and that's contained support for Servlet 4.0 and also the reactive stack. Now that we have an overview of the history of Spring configuration, let's talk in more detail about our configuration options. XML was the initial configuration option for Spring. Using XML, it was common to import the XSD, and then we would get access to a variety of tags that could be used to configure our Spring IOC container. When it came to MVC applications, we'd often define the initial configuration within the web.xml, and that was to bootstrap the IOC container and get it started with our web application. If you took a look at the XML configuration for a Spring project, you'd find it's rather lengthy, but the one good thing about it is that it did separate the configuration and the code. So you always had this one spot to go find your configuration, and then your source code was separate. Now, with the introduction of annotations, configuration moved towards a more hybrid approach. So you would have some of your configuration in XML, and then the remainder of your configuration would use annotations. Now, the great thing about annotations is they are very readable, and they were easy to put in place. They relied heavily upon Spring's component scanning. So component scanning would look through packages in a Spring project and identify particular annotations such as things like component, controller, or service that would require a bean to be created. This would cause that bean to be registered in the IOC container, so annotations worked hand in hand with that component scanning feature. Now, the one thing about annotations is they put the annotation right in line with the code. So here you see an example. We have class level annotations that are being applied to this class. They're also applied at the field and method levels within our classes. So you do have configuration side by side with code. That concept gets taken even further when we talk about Java-based configuration. So if you take a look at the snippet on the right, we're actually using methods to declare beans. And you'll also see that we are using annotations in this approach in the fact that we have annotated the method with the bean annotation. And what happens is these methods return an object, and then that object gets registered in the Spring IOC container as a bean. And that makes it available for things like autowiring. Now, one of the benefits of the Java-based approach to configuration is the fact that it's strongly typed. So each of these methods has a return type, and that enforces typed safety. As I mentioned before, Java-based configuration was made possible by Servlet 3.0. Servlet 3.0 introduced features that no longer required the web.xml file. It allowed us to register servlets, such as our dispatcher servlet, using Java code, and that was the basis that springboarded into Java-based configuration. Moving on to Spring Boot, the main goal of Spring Boot was to get Spring developers started faster. Often Spring developers would struggle with the configuration of their project. So the idea of convention over configuration was introduced. And this is the idea that Spring Boot is going to be very opinionated. It's going to apply some common configuration for infrastructure beans that are heavily used within Spring. So things like establishing the beans necessary to support the use of Hibernate. Spring Boot is going to make educated guesses about how to configure your transaction manager or your entity manager factory bean. It will apply these default configurations that you accept or customize as the developer, and it gives you these advances in speed for establishing your project. The other thing that it does well is it manages the dependencies within our project. So if we're using Maven to configure our project will specify its dependencies or other libraries it needs to use, and it also specifies a version of that dependency. Now, the great thing about Spring Boot is it knows what version of a dependency works with another dependency's version, and it applies that by default. So as developers, we're not figuring out which version goes with which can be very frustrating if you've encountered that. And then the final thing to mention about Spring Boot is that it really favors embedded servlet containers. So it abandons the idea of building a war and deploying it to a standalone servlet container. Instead, we're including something like the embedded Tomcat jar And then we are actually packaging the servlet container with our application and using something like a main method to start up that embedded servlet container. So within the course, we're going to focus primarily on Java-based configuration and configuration with Spring Boot. As we work through, you will learn how to leverage all of the Spring MVC features using these two configuration options. In this lesson, we'll build the foundation of a Spring MVC project from the ground up. This will give you an in-depth understanding of how a project is structured and the technologies used to build a Spring MVC project. So to get started, within STS, we're going to open the new dialog by pressing Ctrl-N and typing Dynamic Web Project. Once we have this selected, we're going to hit Next, and then we're going to give a name to our project. So let's call this Spring MVC Foundation. Once we have provided a name for our project, we're going to hit Next, and from here, we'll hit Next one more time, and now we need to specify a content directory. According to Maven standards, the web content for a Maven project is found in source/main/web app. Once we have this in place, we can go ahead and hit Finish. And we don't need to open a Java EE perspective, so you can hit No. You'll see that a new project is built, and within the project, we have the source main web app directory. Now, currently that's on our build path, so we're going to right-click, go to build path, and hit Exclude, and we'll need to do this for each level within the hierarchy. And finally, we remove it from the build path. Now we're going to create a new source folder. So once again, open the new dialog by pressing Ctrl-N, and then type source folder. Once you have source folder selected, hit Next, and within this dialog, we need to provide a folder name. So it's going to be source main Java according to the Maven standard layout. And once we have this in place, we can go ahead and click on Finish. From here, we're going to convert our project into a Maven project. So if we right-click on the project name, we can go to Configure, and then Convert to Maven Project. At this point, we need to provide a group ID and an artifact ID for the new project. So for the group ID, I'm going to use com.o'reilly.mvc, and we'll leave the artifact ID as spring-maven-foundation. These will form the coordinates for the new artifact that we're creating. With this in place, we're going to go ahead and hit Finish, and you'll see that we now have a pom.xml file. If you're familiar with Maven, you'll know that its robust dependency management system will allow us to pull in the necessary dependencies for our project. The dependencies we need will be within the org.springframework group ID. And once we enter that group ID, we are able to search through the available dependencies. We're going to need Spring-context support, and then we're also going to add another dependency within that same group ID, and that is the Spring-web MVC dependency. So here we see that dependency. We can go ahead and hit OK. Once we have saved our pom.xml file, we can go ahead and build out the web application initializer. So this is the class that is going to be detected by the Spring-context-support dependency, some of the libraries within there, and it will cause our container to be bootstrapped for the web application. So we're going to use the new dialog to create a class. We're going to place this class within the com.o'reilly.mvc package, and we can name this class app initializer, and we need this class to extend the Web Application Initializer interface. So with that interface implemented, we are able to override the onStartup method, and we're simply going to print the console hello world. So this would be a bare bones setup for a Spring MVC project. We don't have some of the appropriate infrastructure beans in place, but we do have the ability at this point to begin bootstrapping our project. We can test our configuration by right-clicking on the project and going to Run As, and then Run on Server. We'll go ahead and hit Finish, and now if we inspect our console, we should see the Pivotal TC server initialize, and we get our console output. This indicates that within our project, we have successfully established a web application initializer. In this lesson, we'll learn how to configure logging for a Spring MVC project. By configuring logging, we will receive more detailed information about the execution of our application. We can use this additional information for troubleshooting purposes when we encounter bugs. To begin putting logging in place, we'll need to add two dependencies to our pom.xml file. To do that, we're going to expand our project within the Package Explorer and open the POM. Within the POM, we're going to navigate to the Dependencies tab and then hit the Add button. The first dependency that we will add is the popular logging implementation provided by Apache, which is Log4j. If we look through the dependencies, you'll see there is a dependency provided that group ID is Log4j and its artifact ID is Log4j. Go ahead and select this dependency, and you'll notice it's registered as a bundle. We need to modify that, so to do that, we click on the Properties button, and then use the Type drop-down to select the jar option. Once this is in place, we can hit OK to save our changes. Now it's time to add our second dependency, SLF4j, which is the simple logging facade for Java. SLF4j provides an abstraction for logging frameworks. We can find this dependency within the org.slf4j group ID, and if we scroll down, we will find the slf4j-log4j12 dependency, and what we need to do here is expand that dependency, and we don't want to select an alpha or a beta version. Let's take a more solid release, so we're going to grab this 1.7.25 release, and we'll hit OK. At this point, we can save our pom.xml file, and now we are going to build a log4j.properties file in order to specify the configuration that will govern the behavior of the logging framework. So we place this configuration file within the source main resources source folder. And we need to create that folder. So we're going to open the new dialog by pressing Ctrl-N, and then we simply type source folder. And once we find it, we hit Next, and then we provide the name of our folder, Source Main Resources. Once we're satisfied with the name, we can hit Finish, and now we're going to once again open the new dialog, and this time we're going to select File, and then hit Next, and we will name our file log4j.properties. And this is the file expected by log4j that will contain properties which control the behavior of the logging framework. Now, I have copied out some very plain configuration. The gist of this configuration is that it will write our logging messages to standard out, so we will see them appear in the console thanks to the console appender. Now you'll notice currently it's specifying info. We're going to switch this up to debug so we can see more verbose information from our application. So with this configuration in place, we'll now see more detailed output about the execution of our application. In this lesson, we'll use Java-based configuration to register and configure the Spring MVC Dispatcher Servlet. The Dispatcher Servlet is the entry point for the front controller pattern. It is responsible for routing requests to the appropriate controller within our application. To get started with configuration of the Dispatcher Servlet, we need to work within our Web Application Initializer. You'll find the App Initializer class within our project, and you'll see that it implements the Web Application Initializer interface. This interface is detected by the Servlet 3.0 container, and it will cause the onStartup method to be invoked. Now, currently, we are simply printing a message to the console within this method. That's not going to cut it, and we're going to have to provide some additional configuration to do two things. First, we need to bootstrap our IOC container, and second, we need to register our Dispatcher Servlet with the servlet context. So let's start out by bootstrapping our IOC container. To do that, we use an application context, which basically represents the IOC container and allows us to register beans and configuration with it. We are going to use the annotation config web application context. This is a special type of application context that allows us to use annotations on our classes to configure the IOC container. I'm going to name this application context the Dispatcher context, and using the new operator and the constructor, we'll be able to create an instance of this object. Once the object is created, we can invoke its register method to register a configuration class. So I'm going to create a new class named WebConfig, and we'll build that within Eclipse, and we'll talk about the configuration of that class in a little bit. At this point, though, we have established our application context, and we can move on to the Dispatcher Servlet. The Dispatcher Servlet can be instantiated with its constructor, and it accepts an overloaded form that allows us to supply an application context as an argument. So we're going to use that form of the constructor, and there you see we're passing in our dispatcher context to the constructor. Using Servlet 3.0 features, we can now dynamically register the servlet. So to do that, we use the Servlet Registration object and the dynamic object within it. We're going to name the dynamic object Registration, and we're going to use that object to perform registration of the servlet. So to do that, we need to invoke the addServlet method on the servlet context. This method accepts two parameters, the first being the name of the servlet, which we will name Dispatcher, and then second is the servlet itself, so we can pass in the Dispatcher Servlet. Once we have done that, we can invoke the addMapping method on the registration object, and this allows us to supply the path that the servlet's mapped to. In this case, we are mapping to /, which will cause our Dispatcher Servlet to handle all requests that do not have an explicit mapping. The final piece of registration for the servlet is to set the load on startup to 1. And by invoking this method and passing 1, it will cause our dispatcher servlet to be the first servlet registered within this application. So now let's turn our attention to this web config class. This is going to be a configuration class, and we're going to add the enable web MVC annotation to this class. This is an important annotation within Spring MVC. It allows us to register a number of Spring MVC infrastructure beans that are going to support application concerns like request mapping. Underneath the enable web MVC annotation, we're going to add the component scan annotation, and we're going to instruct Spring to scan the com.o'reilly.mvc package. So what will happen is the Spring IOC container will look within this package for classes with annotations like the component annotation, the service annotation, and in our case, the controller annotation. When it discovers those annotations on a class, it's going to turn them into a bean within the Spring IOC container. And that leads us to the next object that we're going to create. We'll do that by using the new dialog, and we simply want to create a class, and this class is going to be named main controller. Now I bet you can guess that this is going to be a controller class. So in order to create a controller, we need to annotate the class with the controller annotation. So this is the annotation that the IOC container will pick up and cause the main controller class to become a bean. We also need to add the request mapping annotation. And this annotation provides information to the dispatcher servlet that is used to map requests to a particular handler method on a controller. The dispatcher servlet will inspect the URL on the request and look for a matching URL or path within those registered with the dispatcher servlet. Once it finds a match, it then forwards execution to the handler method on the controller. So we're going to map this controller to the /main path, and then within this controller, we're going to create a new method that returns a string, and we'll simply call this method message. Within the body of this method, we're going to return hello world. We'll keep it simple. Now, in order to have requests mapped to this handler method, we need to add the request mapping annotation. And we're simply going to map to /. So any request that comes into the dispatcher servlet for /main / are going to cause this handler method to be invoked. And what we want to happen is for hello world to be returned as the body of the response. So to do that, we can add the response body annotation, which will get discussed at a later point in the course. So having all of this in place will establish a simple Spring MVC application that's going to respond with hello world when the /main /URL is contacted. So let's save everything, and now we're going to navigate to the Package Explorer, and we'll simply right-click on our project, go to Run As, and then select Run on Server. We'll need to select the Pivotal TC server as our server to run on, and we just hit Finish, and let's watch the console now. And in a minute, we're going to see some output. So there, thanks to our logging configuration, we're getting more verbose output from our Pivotal TC server. And we see there it instantiated. And we're going to grab this URL, head over to the browser, and then use the /main path to contact our Spring MVC application and invoke our handler method which is going to return hello world. This is technically your first working Spring MVC application. We are going to learn more about how to leverage the additional features found within Spring MVC as we move along, but this project serves as your foundation and your first example. In this lesson, we'll learn how to use an expedited approach for configuring the Spring MVC dispatcher servlet. This approach uses a class provided by Spring known as the abstract annotation config dispatcher servlet initializer. This class will allow us to easily register a dispatcher servlet within the servlet context simply by extending it. Let's get started. We're going to navigate to our Package Explorer, and within the com.o'reilly.mvc package, we're going to build a new class. We're going to name this class our dispatcher initializer. So here's the important part. We need to make sure this class extends Spring MVC's abstract annotation config dispatcher servlet initializer. So to do that, we select a superclass, and we're going to select the abstract annotation config dispatcher servlet initializer. There you can see the class that we need to extend, and once we have that specified as our superclass, we can just go ahead and hit finish. Now, if we take a look at this class, you'll notice there are 3 methods that need to be overridden from the base class. So the first is to get root config classes. We'll talk about the purpose of this method in a future lesson. What we will do is adjust the get servlet config classes method. So this method should return an array of classes that are our configuration classes for the IOC container. We're going to construct a new array of classes, and then we're going to do the instantiation of that array directly after its declaration and instantiation. We're going to grab our web config class since it contains the Spring MVC configuration for our project. Once we put that in place, it's the same as registering it with an application context. So when our application starts and Spring MVC bootstraps the IOC container, thanks to the abstract annotation config dispatcher servlet initializer, it's going to invoke this method and know that it needs to register this configuration class in the IOC container. Now, you may ask, what about the dispatcher servlet? Where are we actually performing the registration? Well, that's handled behind the scenes within the base class. All we need to do is provide the servlet mappings for the dispatcher servlet. So this is a string array. So we're just going to create a new string array. And once again, we're going to provide the implementation of that string array directly in line here. So we just need to provide a simple string that contains the path that we would like to map the dispatcher servlet to. And that's all it takes. At this point, we are able to start our application as long as we remove our app initializer. So what we have done is replaced this configuration with this configuration. That is much simpler. So I'm going to go ahead and delete the app initializer, and then I'm going to launch our application. So I'll just right-click on the project, and then go to Run As and Run on Server, and then hit Finish. And we'll go take a look at the console as the server loads our new Spring MVC application. There we see the dispatcher servlet has been configured, and pretty soon we should see the startup of the application. So if we grab this URL, we can head over to a browser and we'll enter that URL in the address bar, and then we're going to add the /main/path, and this will allow us to reach our controller and receive the hello world method. So in this lesson, we took a look at an approach that allows us to configure the dispatcher servlet more quickly using the abstract annotation config dispatcher servlet initializer. When building applications, a best practice is to segment the application by concern. So for instance, the services that support an application should be separated from the objects that support the application's web tier. In a nutshell, loose coupling between different application concerns creates flexible and robust applications. To support this, Spring MVC can build hierarchies between application contexts. Let's take a look at the abstract annotation config dispatcher servlet initializer to learn more about this. So if we inspect our dispatcher initializer class, we see that it does extend the abstract annotation config dispatcher servlet initializer. Within the body of this class, it provides us with the getRootConfig classes method. This method is used to establish root application context. What that means is that it's an application context specifically for global beans and services that may be shared across the applications in multiple dispatcher servlets. You can think of the root application context as holding the non-web infrastructure. All of the web infrastructure would be contained in the application context associated with the dispatcher servlet. The dispatcher servlet's application context contains beans specific to that particular dispatcher. That allows us to have multiple dispatchers with different configurations. We're going to establish this root application context. We see that our method requires a new class array, and we're going to provide a class within that array that will be named rootconfig.class. So I'm going to go ahead and create that class within Eclipse, and we're going to annotate this class with the component scan annotation, and then I'm going to instruct the component scanning to occur within the com.o'reilly.mvc.services package. You'll realize that if we take a look at our package structure, we do not have a services package. So let's create that package. So open the new dialog and then select package. And then we're simply going to create the new services package. While we're doing this, we're also going to create a new package named controllers. And I bet you can guess what that will hold. It's going to hold our controllers. So let's move our controller to the newly created package. At this point, we can adjust our web config to only scan the controllers package. Remember, this configuration is specific to our dispatcher servlet's application context. Now, returning to the Package Explorer, we're going to create a new service. So we just build a new class, and we're going to name this class Greeting Service. And I'll go ahead and hit Finish. Because we have component scanning configured to scan this package, we can simply add the service annotation to our class, and it will automatically be detected and registered as a bean within the root application context. Now, the next thing we're going to do is declare a method that returns a type of string, and its name will be greet. And then very simply, we're going to return hello world from this new method. So we've established a greeting service that will become a bean within the root application context thanks to component scanning. Now, what we can do is we can head over to the main controller, and instead of returning this string literal, we can Autowire in our new greeting service. And remember, this is coming from a different application context other than the one associated with our dispatcher servlet that has actually created our controller. So once we put that greeting service in place, all we need to do is invoke the greet method on that service, and that will be fired when our controller has its handler method executed due to the dispatcher servlet matching a path to this controller's request mapping. So with all that in place, I'm first going to go ahead and clean the project, and then I'm going to run the application on the Pivotal TC server. And there we see the IOC container being built. Our dispatcher servlet was configured. And let's just take a minute to look at our console. If we look, we can see the different contexts being created. Here we can see root config was picked up. Here's what I was searching for. If we take a look at this line, you can see it's refreshing the web application context for the dispatcher servlet as it starts up, and then it specifies that the parent is our root application context. So there you can see the actual hierarchy. So if we return, we can grab this URL. We'll hop over to Chrome and contact our main endpoint. And there we can see that we were able to invoke that handler method on the controller, and that used the greeting service from the root application context. So in this lesson, we saw how to establish hierarchies between application contexts when building out our Spring MVC application. In this lesson, we'll learn how to configure Spring MVC's dispatcher servlet to resolve views. To do this, we register a view resolver. Registered view resolvers are used by the dispatcher servlet to identify the appropriate view, such as a JSP, that corresponds to a view name provided by the controller. Let's configure a simple view resolver to see it in action. We're going to begin our discussion within the dispatcher initializer. Within the body of this class, we establish a root application context as well as an application context associated with our dispatcher servlet. Now, because a view resolver is a web component, we need to register it with the application context for our dispatcher servlet. To do that, we declare it as a bean within the web config class that we've established. So navigating to that class, I'm going to create a new method inside of webconfig that returns an internal resource view resolver. We'll name this method view resolver and then declare the body of the class. Now I'm going to annotate this class with the bean annotation, and that will cause it to register an internal resource view resolver bean with the dispatcher servlet's application context. But we need to create that bean or that object. So we're going to declare a new object that is of type internal resource view resolver. This object is used to access files within the webinf directory. This is important because content within the webinf directory is not directly accessible. I can't construct a URL in a browser that reaches into the webinf directory and pulls out a JSP file. However, the internal resource view resolver can expose that content for our dispatcher servlet when it's rendering a view. So that's the purpose of this object, and we're going to declare it as a bean. We'll name this object view resolver bean, and then we can simply instantiate it with the new operator and the constructor. Now, the way this object works, it needs to take a prefix that it prepends to a view name the controller provides to the dispatcher servlet. So we need to set that prefix. And we do that by using the setPrefix method on the object. And we're going to set the prefix as webinf. So we're reaching inside of our webinf directory. And then we're going to create a new directory inside of webinf named views. So once the dispatcher servlet gets the view name from the controller, it's going to prepend this prefix. So it'll look something like this. And then what will happen is a suffix will get added after this view name. And that's how the internal resource view resolver locates the appropriate view to be served in response to a request. So with the prefix in place, we need to establish the suffix that will be used. In this case, it's going to be .jsp. And then finally, all we need to do is return the object of type internal resource view resolver. We have the view resolver configured. Now we need to put the views in place. So let's navigate to our package explorer, and we need to locate the webinf directory under source main web app. Inside of this directory, we need to build out a new directory. So we create a new folder, and we need to name this directory views because that's what was configured within the internal resource view resolver. Now inside of the views folder, we are going to add a JSP file, and we'll simply name this JSP file hello. And then I'm just going to hit finish to build out our JSP, and we'll give it a title. We'll say it's the Hello World application. And then inside of the body of this view, we're going to declare a heading. And this heading is going to reference an attribute found in our model named message. So we use JSP-EL to grab that attribute from the model. With this declared, the next thing we need to do is modify our controller a bit. So currently, we're using the greeting service to return a string directly as the body of our response. We need to modify that. So we remove the response body annotation, and we're going to add the model as a parameter to this handler method. And then what we can do is add an attribute to the model, and we'll name it message. So that corresponds with that snippet of JSP-EL that we placed within the view. And then we're just going to grab this line of code that invokes the greet method on our greeting service. And now within this handler method, we need to return a view name. So if we take a look, we declared our view as hello.jsp. So we need to return the name hello, and that's our view name. And that is what will be returned by the controller to the dispatcher servlet. That's going to consult our internal resource view resolver. So it's going to basically append hello after our prefix, and then it's going to add the suffix, and that's how we're going to identify the appropriate view. And if we follow that path, you'll see that it leads us to our hello.jsp file, which will be rendered as the view in response to the request received. So with all that in place, we can go ahead and run our application, and we'll run it on the Pivotal TC server. So there we see the IOC containers being built. Soon we'll see our dispatcher servlet get configured. So there our application has launched. We will just grab this URL and then head over to the browser and add the main path. And here we can see that we render our view. In this lesson, we'll learn how to rapidly configure a Spring MVC project using Spring Boot. The Spring Boot project takes an opinionated view of the Spring platform by applying default configurations. These configurations are based upon our Maven project's pom.xml file and an inspection of our project source code and libraries. When boot detects particular code or annotations or particular libraries, it knows to apply default configuration. Let's take a look at what we'll cover in this chapter. First, we'll review the basics. I'll show you the bare minimal configuration required for Spring Boot and walk you through some of the details of how Spring Boot works. From there, we'll see how to override the default configuration applied by boot. We'll also learn how to configure a template engine for rendering views. In fact, we'll put Thymeleaf in place. Finally, we'll wrap up the chapter by learning how to build a war with Spring Boot. By default, Spring Boot prefers to use an embedded servlet container, but that is not always possible in our environments. So knowing how to build a war using Spring Boot is very important. After you complete this chapter, you will be able to get up and running with Spring MVC very quickly by configuring an application using Spring Boot. In this lesson, we will learn how to configure a Spring MVC application using Spring Boot. Spring Boot adheres to the principle of convention over configuration. This allows us to rapidly stand up a Spring MVC project with minimal configuration. The first thing we're going to do is navigate to the menu and select File, New, Spring Starter Project. We're going to name the project Spring-MVC-Boot. And then we want to make sure that our project is using the com.o'reilly.mvc package. The dialog you see just allows us to select information about how we would like Spring Boot to configure our project. You see that we're going to be using Maven, and the major difference is that we're going to be packaging as a jar file instead of a war. We'll talk about that more later. With these options in place, hit Next. From here, we are able to select the technologies from the Spring ecosystem that we'll be using. In our case, we're going to be using the web package. So we want to select web, and then we can hit Next. And here we will see the URL that Spring Tool Suite is going to contact in order to get our base project, which will be a Spring Boot project. If we hit Finish, the project will begin to build within our IDE, and once it is built, we can take a look. The first place we're going to inspect is the pom.xml file. If we explore the pom, you'll notice that it has been pre-built for us. And a very important part of this pom is the parent pom. So we are relying upon a parent pom provided by Spring Boot. We'll take a look at that in a minute. You should also note that we are including the Spring Boot Starter Web dependency. So let's go take a look at these other dependencies. We're going to start out by looking at the Spring Boot jar file within Maven, and we're actually going to look at Spring Boot Starter. And within this jar, we're going to find another pom. That's how Spring Boot configures a lot of these dependencies. It's by linking all of these pom files. If we inspect the dependencies within this pom, you'll notice that Spring Boot Starter is relying upon the auto configure dependency. So if we go check out that file within our Maven dependencies, within Spring Boot auto configure, there is another pom file within the Maven directory, and that pom is actually going to list many different dependencies that we could use with Spring. And that's how Spring Boot is smart enough to manage all of our dependencies, and it knows the particular versions of a dependency that should be used to build a project. And then finally, let's go look at the Spring Boot Starter Web jar. And within this jar, we're going to find yet another pom And this is going to specify the dependencies that we need when building out a Spring Boot starter web project. So here is where it's going to include the Spring Web MVC dependency, as well as you see it's pulling in Hibernate. It's also pulling in Tomcat. That's where the embedded servlet container is going to come from. The point here is that behind the scenes, Spring Boot is managing all of these dependencies. It's doing a lot of auto configuration for you. And that's why we, as the developer, are able to skip all of this when we use Spring Boot. So that's enough with the POMs. Let's now talk about some Java code. So if we take a look at the package structure built by Spring Boot, it creates the Spring MVC Boot application class. The first thing to notice about this class is that it contains a main method. So this is basically the starting point for the Spring Boot application. And the embedded Tomcat server is going to be initiated by this main method. So when we're working in Spring Boot, the preference is to use an embedded server. So instead of building a WAR and deploying it to a standalone Tomcat server, we are actually packaging in the servlet container within the application libraries and initiating it and instantializing it programmatically. Another important part of this class is the Spring Boot application annotation, and this really stands as a proxy for several other annotations that do some very important things. So if we take a look within the definition of that annotation, you'll notice that it contains the Spring Boot configuration annotation, and this is going to define the configuration annotation. So it's basically just allowing us to register beans within any class that is annotated with the Spring Boot application annotation. So when we have that configuration annotation on a class, we're able to declare beans within it. They get registered in the IOC container. Next is the enable auto configuration annotation, and this is a very loaded annotation. It tells Spring Boot to start adding beans based upon different libraries it finds on the class path, other beans it may find. Basically, it tells Spring Boot to inspect the application. If you find some for library or feature that you are aware of, perform as much auto configuration as possible, and this is adhering to convention over configuration. A very good example with an MVC application is when Spring Boot detects the Spring-Web MVC dependency on the class path, it is going to automatically register a dispatcher servlet. You're not going to see a dispatcher servlet registered anywhere, and that's because Spring Boot is taking care of it behind the scenes. And then the final annotation here we're familiar with, it's the component scan annotation. So by default, Spring Boot is just telling Spring to go out and component scan everything. As I mentioned, Spring Boot application is a very loaded annotation. There's a lot behind it, but it's very powerful for developers because it provides us with so much auto configuration. It takes a lot of work off of our hands. So with all this in place, all we need to do as the developer to get up and running with a Spring MVC application under the Spring Boot approach is to create a controller. So let's create our main controller. We'll just quickly walk through it. So we add the controller annotation. We also need to add a request mapping. And once again, we'll map to /main. We'll import those two annotations and get those types. And then I'm just going to create a new method named greeting that returns a string, and it's going to return hello world. And then we need to add response body to this, as well as request mapping, and we'll map to the /. So we put our controller in place. Now we can head to our Spring MVC Boot application class. And from here, we can run as a Java application. Here you can see Spring Boot kicking off in the console. There's some nice ASCII art there to kick things off. And then we see it has loaded. And now what we can do is navigate to the browser, and on localhost port 8080, we contact that main path and we get hello world. So we talked through quite a bit about the internals of Spring Boot. That should give you a solid understanding of what the project is providing us behind the scenes. And then clearly through our demonstration, it is very simple to get up and running with Spring Boot in regards to a Spring MVC application. In this lesson, we're going to walk through one of our configuration options for Spring Boot. The most common and convenient way to override the default configuration provided by Spring Boot is to use the application.properties file. This file can be found within our source main resources directory. The application.properties file is an externalized file that can be placed on the class path to specify customized configurations for Spring Boot and our Spring MVC project. This allows us to modify the behavior of our application when we need to deviate from the settings that are chosen by Spring Boot by default. So if we take a look at the application.properties file, one of the things you'll notice is that it has IntelliSense. So it's very easy to see the available properties that we can use to configure Spring Boot. This is just a simple properties file, and we use a dot notation to specify different nodes within the property that we're going to be setting. So if we look within the spring.mvc node, you'll see all of the configuration options available for Spring MVC within Spring Boot. Some of the most heavily used properties for Spring MVC include the ability to specify when the dispatcher servlet loads using the load on startup property. Also, many applications will specify a static path pattern, and this is a path or directory that will contain static files such as CSS and JS that we do not want the dispatcher servlet to handle requests for. We simply just want to serve up that static content. You'll also see the spring.mvc.view.prefix option and spring.mvc.view.suffix option, which are used for forming the view name that would be resolved by a view resolver. So these are all options within the application.properties file that you have for configuring Spring MVC. Now, when working with web applications, there's some other properties that can be very useful. So server.port is often very important. If we have multiple applications running, sometimes we have to avoid a port conflict. So we can do something like set our port to 9090, and that would avoid a conflict with 8080. The other thing that we can do is we can set the context path. So this is the path found directly after the domain name in a URL. We're going to set our context path to simple, and that will cause our URL to access the application to include /simple. Another thing that we can do within the application.properties file is we can set the logging level. So if we access the logging node, there is also then a level node, and we can set the root logger, or any package for that matter, to any level we would like. In this case, we're going to select debug. So before we start our application, let's do one final review of our configuration changes. We're going to be accessing the application on port 9090, and then the context path is going to be /simple. So let's remove that /, that's trailing. And then we are going to use the debugging level for our root logger. So let's save our application. And now I'm going to navigate to my Spring MVC boot application class. And this is what we're going to fire off to start the application. And we can monitor the console And you'll notice we're seeing a lot more output since we have changed our logger level to debug. There it looks like it has started. So let's navigate to a browser. And within the browser, we're going to hit localhost. And this is important. It's on 9090 this time. And then we need to specify the context path as simple. And then we're going to hit our controller that's mapped to the /main path. And when we do that, we receive hello world. So we were able to make these adjustments to our application by overriding Spring Boot's default configuration. Spring Boot provides configuration following its convention over configuration approach. Sometimes that default configuration doesn't work for us, and the application.properties file is an extremely effective and efficient way to override that default configuration. In this lesson, we'll learn how to configure Thymeleaf with Spring MVC to display application views. Thymeleaf is a Java-based template engine that features deep integration with Spring MVC. Currently, our Spring MVC project has not configured any template engines, so we would be unable to render any views. Additionally, there are several caveats to using traditional JSPs with Spring Boot. This makes Thymeleaf an excellent choice. So in order to configure Thymeleaf within our application, we need to add the Spring Boot Starter Thymeleaf dependency within our pom.xml file. So I'm going to open our pom and then click on Add to add a new dependency. And then we're going to enter the group ID org.springframework.boot. Once the dependencies load, we're going to see many of the Spring Boot dependencies that contain starter POMs. And if we scroll down through these dependencies, there the starters begin, and we're going to find a starter for Thymeleaf. So we select that and add it to our application, and we save our pom.xml file. We can now go ahead and close the POM now that Thymeleaf libraries will be included within our Maven dependencies. The next thing that we need to do is go within the source main resources directory, and you'll notice a templates directory underneath source main resources. By default, this is where Spring Boot will auto-configure templates to be placed. So we're going to create a new Thymeleaf template using the new dialog, and it's a simple HTML file. So we're just going to make an HTML file, and we'll name it hello.html. And then within this HTML file, remove the meta tag, and we'll change the title to Spring MVC Application. And then we're going to add an h1 tag and simply put hello world. Now that we have the template established, we can modify the main controller in order to direct the request processing to our hello.html template. And the way we do that is by specifying the template name, and instead of returning response body, we're just going to return that string that will represent the hello template. So we give the view name, the dispatcher goes and finds our hello template and renders that in response to the request. This is all configured by default by Spring Boot. One other thing we're going to do is we're going to navigate to the application.properties file, and we'll reset some of these settings. So we're going to remove the logging, we'll switch back to port 8080, and that will simplify our testing. So now that we have performed all this configuration, we are ready to run our demonstration. So right-click on our application and hit Run as Java Application, and we'll watch our console start up. We can see our app is up, so let's head over to a browser. And we're going to look at localhost on port 8080/main, and there we receive our Thymeleaf template. So in this lesson, we learned how to configure Spring MVC using Spring Boot so that we can display Thymeleaf templates. That way we can have views within our application. In this lesson, we're going to talk about how to configure Spring Boot so that we can package a WAR file instead of the default executable jar. We'll learn how to configure our application to be packaged as an executable jar so that it can be ran within a main method or deployed to a servlet container. This all starts in the pom.xml file. So if we navigate right to the source, that's where we're going to make our changes. The first one is pretty obvious. We need to modify the packaging from jar to WAR. And the next thing we'll need to do is specify one of our dependencies as provided. So I'm simply going to copy the Spring Boot Starter Web dependency, and then I'm going to change Starter Web to Tomcat, and then below that I'm going to mark the scope of the dependency as provided. And this will just indicate that we do not need to include any of the libraries associated with the Spring Boot Starter Tomcat dependency because we expect them to be provided. This is going to allow our packaged application to run as a WAR on a standalone Tomcat server. With the changes to the pom.xml in place, we can now navigate to our Spring MVC Boot application class. This is the root class that contains our main method, and the changes here are pretty simple. So all we need to do within this class is extend the Spring Boot Servlet Initializer class. So I'm going to use IntelliSense to make sure I spell that correctly. And there you can see we've extended the Spring Boot Servlet Initializer. Let's talk a little bit about this class. It's going to look familiar. You'll notice that it implements the Web Application Initializer class. And this is the class that has the hooks into the Servlet 3.0 container, and we've used it in the past to configure the dispatcher servlet. With this change in place on our Spring Boot application, the final change that we need to make is to add an execution environment. So we're going to go to Window Preferences, and then within our options, we want to expand Java, and then we expand Installed JREs, and then select Execution Environments. And we want to be sure to select Java 8, and then we can pick the JRE 1.8.0_152 that we installed before. So with that selected, let's run our application. So we're just going to run it as a Java app, and this is how you would run it during development when you're just doing your local testing. And you can see it started fairly quickly. So I'm going to shut down the app, and at this point, we are now going to package the application as a WAR. There I see that our class name actually got a little mangled. So let's modify that back to the original Spring Boot Servlet Initializer. There we go. And now to package the application, we right-click on the pom.xml file, and then we're going to run as, and then a Maven build. And for our goals, we'll specify that we'd like to package. And then I'm just going to hit run, and we can watch the application get packaged into a WAR. So there we see our tests kicked off, and we should soon see some information about our WAR file. It says it's building the WAR, and you can see that it put it within our workspace directory in the Spring MVC boot-war directory underneath the target directory. So if we navigate to our target directory within our project, you're going to see our WAR that was built. And this could be deployed to a standalone servlet container. In this chapter, we'll discuss the details of processing requests with Spring MVC. This is probably the most important chapter within the course. because you will see the configurations, annotations, and problems that solve about 80% of our request processing needs. And request processing is the primary purpose of Spring MVC. You will remember that a controller is what handles the processing for requests received by the dispatcher servlet. The dispatcher servlet receives the request, inspects the URL, and then decides which controller handler method should process the request. So step 1 is creating a controller. This is done by annotating a class with the controller annotation so that it is detected by component scanning and registered with the dispatcher servlet. When using Spring Boot, our packages are automatically scanned by default. This default configuration is provided by the Spring Boot application annotation. The annotation causes the controller within our example to be turned into a bean and registered with the dispatcher with no configuration on our part other than the controller annotation. So now that we have a controller, it's time to map requests to the controller methods using the request mapping annotation. This annotation is applied at the type and method levels to construct a path the dispatcher servlet uses to locate the appropriate handler method for a request. When applied at the type level, the annotation simply maps a path segment to a controller. We then need to provide the remaining portion of the path on a handler method to build the complete mapping. The request mapping for the path /example on the example controller and the request mapping for the path /add on the add method are concatenated to form the mapping /example /add. This is registered with the dispatcher when our application starts. Now, imagine we receive a request for the URL /example /add. Upon receiving the request, the dispatcher searches its registered request mappings, locates /example /add, which is associated with our example controller's add method, and then it decides to invoke that add method, forwarding execution to the controller handler method. Spring MVC also provides some very nice features for controllers to assist with request processing. One of those is using the model. The model allows us to share information between the controller and the view. So looking at the example, we are able to establish an attribute in the model by the name of MSG. That attribute is passed to our example.jsp file or the view for display. The model is basically a map of key value pairs known as attributes. Spring MVC makes the model attributes available within the request objects as attributes so we can easily reference them within our views. So you'll see within the span tag, we are using JSPEL to reference the MSG attribute. Moving on, when building web applications, it is common to separate applications into several layers. Often we'll build a data persistence layer, a service layer, and a web layer. When using Spring MVC to build an application, it is pretty common to auto-wire services into our controllers. Within Spring MVC, and especially Spring Boot, this is a breeze. We simply annotate the service with the component or service annotation so that it gets registered as a bean, and then we use the auto-wired annotation to inject it into the controller. Another useful feature of Spring MVC is the ability to pass variables within the URL of a request. Using a URI template, we are able to define a segment of the URL that contains a variable we can extract. The path variable annotation then allows us to assign the value found in a template placeholder to a method argument. So for example, when a request is received for /example /test /22, our request mapping is configured to bind the value of the test ID placeholder from the URL, which in this case is 22. So 22 is assigned to our method argument test ID of type long. Now, another great thing is that using this approach, we're able to bind all sorts of simple data types. So here we're using a long, it could be an int or a date, and those are automatically converted. And if the data types get more complex, we can provide definitions for converting them to Spring MVC. In addition to path variables, Spring MVC's controller methods accept many other argument types. In fact, there are roughly 30 types that can be passed into a controller method. The framework is very flexible about what can be passed in. For example, we can extract a parameter value using the request param annotation. In our example, you will notice that our query string contains the action parameter with the value test assigned to it. By using the request param annotation, we are able to bind the value of the action parameter to the string argument within our method signature. If you look at the second method, you will see that we can even pass in the HTTP servlet request and HTTP servlet response objects. These are just a few of the arguments that we have available to us as options to pass into these controller handler methods. Finally, we'll discuss basic data binding within this chapter. When a request is received by a server, the request often contains parameters which are basically name-value pairs. So in our example, our server has received a request containing the name parameter, which has a value of Kevin Bowersocks. Let's assume that our example controller's save method is handling this request. Notice the method contains the example argument of type example that is annotated with the model attribute annotation. Inspecting the example type on the right, we see that the class defines a field with the name that has accessors defined. So we have get and set methods for the name field. Now let's talk about what happens. When Spring MVC receives this request, the name of the parameters in the request are compared with the names of the field on the example class. If the parameter name matches the field name, the value of the parameter is bound to the field. So in this case, the value of the name parameter is assigned to the name field in the example class. And this really beats fishing out parameters from the HTTP servlet requests. So data binding is an extremely valuable part of Spring MVC. In this chapter, we're going to teach you all of these concepts using a sample project. The sample project is very rudimentary. It's a project management application that will meet our demonstration purposes. After you have completed these demonstrations, you will have the basic knowledge required to handle about 80% of the use cases you will encounter with Spring MVC. In this lesson, we will introduce and do a quick walkthrough of our sample project that we'll be using throughout the Spring MVC course. This sample project will allow us to test Spring MVC features and to demonstrate Spring MVC concepts. To get more acquainted, let's do a closer inspection. Here you see the project, and you can see that it exposes the /home endpoint. That's going to cause this page to be rendered, and on this page you simply see a menu bar, and within that menu bar are two drop-downs, one being for projects and another for resources. Both of these menu options have add and find menu items that you can use to work with the appropriate entities. We will fill out these menus with different demonstrations as we work through the course. Let's talk a little bit about how this is constructed. So we know that we are exposing the home endpoint, and that is allowing us to access a home view through the dispatcher servlet. Now, if we take a look at the application.properties file for our project, you'll notice that an internal resource view resolver has been configured within Spring Boot to route to webinf views, and then it's using a JSP extension. Let's go find that directory within our project. So if we look within source, main web app, you're going to find the webinf directory and then views, and then you're going to notice some JSPs. Here we can find our home.jsp file, and we have configured boot to work with JSPs. Let's talk a little bit about how we do that before we inspect the home.jsp file.
So within our POM, we need to add two dependencies. The first being the JSTL dependency. So here you can see that dependency was added. And then we also added the Tomcat embedded Jasper artifact. And with those dependencies, we are able to leverage JSP inside of a Spring Boot project. Now let's return over to our home.jsp file. And this is the page that we were looking at within the browser. You'll notice that it does include a JSP fragment, and that's where we are actually getting our menu in the header.jsp fragment. Additionally, within this page, we're pulling in some external libraries. So we're pulling in Bootstrap for some styling, and then we're also pulling in jQuery so that we can leverage its advanced JavaScript capabilities. Let's go take a look at header.jsp to see our menu. So this is going to be included on most pages so that we have our menu. And you'll see that we're able to construct links to the various portions of our applications via the menu. So we have within an unordered list a set of list items that link to other parts of the application. Here's the home link. Here is the menu corresponding for projects. And then we also have another menu corresponding for resources. And we're able to add hyperlinks to the various endpoints that we would like to invoke within our Spring MVC project. So this walkthrough should give you a good understanding of the structure of our application. It's just a little bit different that we're using JSPs within Boot, and then we have this fragment that is providing our menu within our JSP files. So we'll continue to expand upon this sample project as we work through the course.
In this lesson, we will take an in-depth look at Spring MVC controllers by walking through a demonstration that will add a controller to our sample project. During the demonstration, I'll give you a detailed explanation of how controllers fit into Spring MVC's request processing lifecycle. To get started, let's take a look at our application, and we're going to start within the header.jsp file. This file contains our application's menu. And when we look within the projects dropdown, we see the Add menu item. This menu item allows us to send a request for the /project/add URL. Currently, our dispatcher servlet is not set up to handle this URL. It doesn't have a controller in place that can execute the application logic that is tied to this particular URL. Now remember that controllers can do things such as persist data, update a model, they can perform other application logic, or they can do something as simple as render a view. And in our case, that's what we need our controller to do. We need it to render a view for the /project/add URL. And we can find that view tucked within our project. So we're going to take a look at the webinf views directory to find project_add.jsp. And this is the view we'd like to display for our URL. And it's pretty simple. It just displays a project form that would allow a user to add a new project within our application. So let's start setting up the controller. So we're going to navigate to the source main Java directory. And then within that directory, we're going to create a new class within the com.o'reilly.mvc.controllers package. So I'll build a new class, and I'm going to name it Project Controller. And now since Spring 2.5, we've been able to configure our controllers primarily using annotations, and that's the most popular approach. And the annotation at the root of it all is the controller annotation. Let's talk about what this does. It's really a stereotype annotation that indicates to Spring that this is a controller and it needs to be declared as a bean within the IOC container.
Once it's declared in the IOC container, it's registered with our dispatcher servlet. And this makes our controller available to handle requests coming into our Spring MVC application. It is a potential candidate to handle any request that is received. The way this gets detected under Spring Boot is through component scanning. By default, if we don't change any configuration, Spring Boot is going to scan all the packages within our application. And that's going to cause this controller annotation to be detected on our project controller class, and that's how we wind up with a controller registered with the dispatcher servlet. Now, what we need on this controller is a method to handle any particular request that might come in. We call this a handler method. So that handler method, we're going to make it public. It's going to return a string, which will be the view name, and we're going to name it add project, and then we're simply going to return the name of the view that we would like displayed in response to this request. That's going to be our project underscore add view. And thanks to our configuration with the view resolver, it's going to wind up displaying the project underscore add.jsp file, because it's going to get prefixed with webemp views and then suffixed with .jsp, and it's going to cause this view to be located within our project. Now our dispatcher has a controller method or a handler method, and it's also registered with the dispatcher servlet. We need to now map requests to this controller. And the way we do that is by using the request mapping annotation. Let's talk a little bit about this. This annotation works because of the default annotation handler mapping. And that's a strategy that the dispatcher servlet has been configured to use in order to take a request and map it to a particular handler method within one of our controllers. And this strategy is based upon the URL. So we're able to use the request mapping annotation to specify portions of a path that we would like to have associated with a controller. And then the dispatcher is able to look at the path for a particular request associated with the URL and find matches as it looks through all the request mappings. So in this case, we're going to map the /project path to this controller. Now, the request mapping can also be applied at the method level as opposed to the type level. So here we are applying the annotation at the type level, and then we're going to make it more granular by applying the annotation at the request mapping level. And here we're going to specify that we would like /add to be mapped to this controller handler method. And what this is going to result in is that when the dispatcher servlet receives a request that looks like /project/add, it's going to wind up invoking our add project method on the project controller, thanks to these two mappings that we have established. So with that in place, let's restart our application. Here we see the console kick off, and now we can navigate to a browser, and we'll first hit the home link, and then we're going to go to projects and then add, and you'll notice that our form displays because we were able to render the view from our controller. In this lesson, we're going to take a deeper look at the request mapping annotation within Spring MVC. We'll learn how to configure the annotation to provide us with finer-grained control of our request mappings. We are aware that the request mapping annotation can be used to map a segment of a URL path to particular controller methods. For example, we have used the request mapping annotation to map /project/add to the add project controller method. Now, if we take a closer look at the request mapping annotation, you will see that the path is actually specified using the value elements. And you'll also see there are additional elements on the request mapping annotation that can allow us to further refine our request mapping and make it more granular. We're going to take a look at the method elements, and this allows us to specify the type of request we would like our controller handler method to service. So we're going to configure the add project method to only service GET requests. And to help us with our debugging of this, we're going to add some console output. So I'm going to say invoking add project. And then what I'm going to do is make a copy of this method. And then I'll need to change the name of the new method. I'm going to call it save project. And then I will change the console output as well so that we can discern between these two methods. Right now, the dispatcher servlet, if it received a request for /project/add and it were a GET request, it would not know which of these methods to invoke. So we want to switch our save project method over to posts. So the add project method will only handle gets, and the save project method will only handle posts. So the application is set up to fire these gets and posts. If we look at our menu, you'll see that the project add menu item is able to fire off the get against /project/add. And then if we go look at the project form, you'll see the form is configured to fire off a post against /project and /add. So let's go ahead and restart our application. And then what we're going to do is navigate to our home page. And from there, I'm going to hit the add project menu item. That should kick off the get. So there we can see that we handled the get request for /project/add using the add project method. Now I'm going to post the form, and you'll see that we'll use the save project method. So the dispatcher servlet was able to decide which of those handler methods to use to service the request based upon the additional information we provided in the request mapping. Now what we're going to do is build out another example, and this example is going to be based upon the value of a parameter. So let's set up a new method, and I'm going to call this the multi-year project method, and we're going to adjust the console output to say multi-year. And now we're going to go inspect our project form. Within this form, you're going to see that we have a select control that has a parameter of type, and we're able to specify single or multi. What we're going to do is set up a request mapping to handle when the type parameter is equal to multi. In that situation, we want to invoke this particular controller handler method. While we're here, I'm also going to point out that we do have this special parameter, and this parameter will come into place a little bit later. Just know that it's associated with the checkbox. So let's go back to our project controller and establish another element on this request mapping, and it's going to be the params element. This element accepts a string array, so we're able to provide a string within our array, and first we specify the name of the parameter, and then we specify the value. We only want to invoke this method when it is a post for /project/add, and it contains a type parameter that is equal to multi. Otherwise, we're going to invoke our regular save project method. But when that condition is met, we will invoke the multi-year project method. So let's restart our application, and then we'll head over to the browser, and I'll just head back to home. And then we're going to navigate to the projects form. And now we're going to specify a multi-year project. And if we submit this, you're going to see that we invoked the multi-year project method. And that's thanks to the additional mapping information we provided to the dispatcher servlet. Okay, let's set up our final test. And the final test is going to be based upon the presence of a parameter, so just whether it exists or not. So let's change the name of our method to the special project method. We're going to adjust our console output, and then we're going to adjust the params element to include another parameter. And in this case, if the special parameter is detected, so just if it is present within the request being serviced, then we will invoke the special project controller handler method. So we should then get this console output. So let's go ahead, restart our application, navigate to the browser, and we're going to come back into the form just to reset it. And we need to remember it needs to be a multi-year project that is special. And when we post that form, you will see that we have invoked the special project handler method. And you can see we can get very granular with how we define these request mappings. And that allows us to provide the dispatcher servlet with some very complicated instructions as far as how it should go about mapping these requests to our handler methods. And it really illustrates the power of Spring's handler mappings. In this lesson, we will learn to use Spring MVC's model to pass information for presentation in our view layer. Within an MVC framework, the model is used to collect and represent important system objects or entities. This keeps the model separated from the view so that we can reuse these entities throughout the application. To get started, we're going to navigate within our project to the project class found within the data.entities package. This object represents a project, and the fields within it contain important information regarding the project. So you can see we can define the project's name, its description, a sponsor, as well as other information, and all of these fields are exposed via accessors. What we're going to do is build a project object, and then we're going to put that object into the model so that it can be displayed on our home.jsp view, which has been adjusted to display the project name, the sponsor, and the description. So the model object is going to pass in the project to home.jsp, and the view is going to take that object and then render it for presentation. So in order to make that happen, we need to adjust our controller first. Within our greeting controller method, we're going to add the model as a parameter to the method. And this will allow us to work with the model within the body of the method. Now, in order to work with the model, we actually need an object to pass into it. So we're going to build out a new project object using the new operator and the constructor, and then we're going to set some information on that project object. So the first thing we're going to set is the name of the project, and we'll just call it our first project. And then we'll specify the sponsor for the project, and we'll say this project is sponsored by NASA. And then I'm going to set a description of the project. So we'll say this is a simple project sponsored by NASA. And there we've built our project, and now it's time to add that object to our model. So to do that, we invoke the addAttribute method on the model object. If we take a look at this method, you'll see it functions very much like the put method on a map. So you supply a key and a value. In this case, the key is the name of the model attribute. So we're going to call this our current project. And then the value will be the project that we built. So there we can see we were able to add a current project attribute to the model, and we were able to assign the value of that attribute to our project object. So here's the great thing about Spring MVC. It takes every model attribute and makes it a request attribute that we can access on our view layer using JSP-EL. When the view is rendered, it's going to be passed this model that we've constructed. And let's head over to our view so that we can access it. So here's where we will use the JSP expression language to reference the current project attribute of the model, and then we can reach in and grab the value in the different fields. So we had the name field. We also want to reference the sponsor field, and then finally the description field. Okay, so with that in place, let's go ahead. We'll restart our project. There we can see it kick off in the console. And now if we navigate to the home page, you're going to see that we display our project and the information about it. So we built that model object, added an attribute, and then referenced that attribute within the model within our view. When building Spring MVC projects, it is very common for controllers to invoke methods on services within our web application. In this lesson, we'll see how to auto-wire services into our controllers so that they can be used to perform the business logic of our application. First, let's talk about what we're trying to achieve in this lesson. If we take a look at our project, we'll see that there is the Find menu item within the project's menu. Currently, selecting this menu item doesn't do anything. But what we would like to do is have this menu item navigate to a JSP that we've created. So if we take a look within our Package Explorer, you will find the projects.jsp file. And if we take a close look at this JSP, you'll see that it contains a table, and we're going to set up our application to display all of the projects within the system in this table. In order to do that, we need to retrieve a list of projects. And within the com.o'reilly.mvc.services package, we've created the project service. The project service is capable of returning a list of projects using its find all method. So here we are mocking a service that's going to return a list of projects that are created within the constructor. Now, in order for us to use the project service, it needs to be registered as a bean within the IOC container. Thanks to Spring Boot's component scanning, which is established by default, we can simply annotate this class with the component annotation. Now that the class is annotated with component, it will be component scanned and declared as a bean within the IOC container. So that allows us within our project controller to auto-wire this project service. So I'm going to create a new public field of type project service, and then I'll name this field project service. And when the Spring IOC container sees this auto-wiring, it will inject the project service into our controller. Now, the next thing we're going to do is declare a handler method that will return the project's view. So we create a new public method that returns a string, and I'm simply going to call this method find, and I am going to pass the model into this method as a parameter. Now, we return a string, which is the view name, and in this case, it will be projects, so that we can display the projects.jsp file. Returning to the controller, we're going to add the request mapping to this handler method so that it can be invoked when the dispatcher servlet is processing requests. We're going to map to /find. And if we take a look within our header.jsp file, you'll notice that within the menu, the find option underneath the projects menu has been set up to contact the /project/find URL. And that's going to cause our controller method to be invoked. The final thing that we're going to do is we're going to invoke the findAll method on the service and place the list of projects within our model. So to do that, we're going to invoke the addAttribute method on the model. First, we supply the attribute's name, which we're going to name projects, and then we're able to use our project service to find all projects. Now we have set up our project controller to return the view and to place the list of projects into the model. We just need to make some final modifications to the projects.jsp file. Within the file, you'll notice that we have registered JSTL, and this is going to allow us to use the JSTL for each tag in order to iterate through the projects in our list. So what I'm going to do is use the C prefix and then use the for each tag. I need to specify the items, and to do that I can use JSPEL to reference the projects attribute within the model, and then we need to specify a variable name for each individual project. So here we have set up the for each tag, and now we can reference that project that we're building in with each iteration of the for each tag. And we can use JSPEL to reference fields on that object. So I'm just going to replace the project name, also the project sponsor, and then finally the description. So that completes the work within our projects.jsp file. Let's make sure that we save everything, and then we can restart our project. So there we see Spring Boot restarting. And now we'll head to the browser. We're going to navigate to the home page to make sure our application is started. And then I'm going to navigate to the projects page. And here we see that our projects are displayed on our user interface. URI templates are a frequently used Spring MVC capability that allows us to pass data to our controllers via a URL. A URI template specifies a variable within the path of the URL sent to the dispatcher for request processing. We can then access this variable within our controller handler method. You might be familiar with URI templates when looking at things like RESTful URLs. You commonly see this pattern used in many REST APIs. If you inspect a URL using a URI template, you will often notice the ID of an entity specified like a variable. So you may see something like /user/12345. 12345 would be the user ID being passed back to the controller. Let's take a closer look by working through an example. So if we navigate to our project and we select the Find option within the menu, you'll see that we list our projects within this table. What we're going to do is hyperlink the project name so that we can navigate to a project.jsp page, and this project
project.jsp page will serve as a view that displays some detailed information about the project. Now, when we navigate using that hyperlink, we're going to construct a hyperlink that passes back a variable via the URL using a URI template. So let's navigate to the projects.jsp page, and here's where we're going to find our table. Currently, you'll notice that we are displaying the project name as well as the sponsor in the description. We're going to hyperlink the project name using an anchor tag. So I'm going to create an anchor tag, and we will wrap the project name, and then we're going to specify the href attribute on the anchor tag. And to do that, we're going to use the Spring URL tag to construct a URL that points to /project/ and then we're going to use JSPEL here to include the ID of the project, and that will get returned back via the URL that we've constructed. So our URL will look something like this, let's say for project 1. And that's the URL that's going to be sent back to the dispatcher for routing. So what we need to do now is set up a controller handler method in order to process this request. So I'm going to open our project controller, and within this controller, we're going to declare a new method that returns a type of string. We're going to name this method findProject. We will pass in the model to the project. We're also going to pass in a long, and we're going to name this long project ID. Now, within the body of this method, we're going to return project in order to display the project view that we created. Now, the other thing that we'll need to do is add an attribute to the model. So we'll use the addAttribute method, and we're going to name this attribute project, and then we're going to leverage the project service, and you'll see a find method on the service that allows us to specify the ID of a project that we would like to have returned. So we've declared the controller handler method. We now need to add the request mapping annotation. So we can add the annotation and construct its path. The path is simply going to be project ID in curly braces. And this is going to cause a mapping to be created for /project, and then it's going to be /, and then we're going to have our URI template here. And that's going to allow us to grab the project ID that is passed in by the URL. Really, this is all we need at this point. But to make things a little bit more verbose, we're going to add the path variable annotation. The path variable annotation actually allows us, so I'm going to pull it in, to specify a name for the path variable. So if our parameter name did not match the path variable name, so for instance, let's say this was the project ID value, it would not match the name of our URI template, and we can match them up by explicitly specifying which path variable within the URI template we would like to assign the value of to our method argument. We're just going to keep them in line so that we don't need to explicitly name our path variable, and it will be a little bit more verbose. With the path variable in place, we will grab the project ID from the URL and assign its value to our method argument. That's going to be passed into the service that's going to return the project that gets inserted into the model. And then if we take a look at our project.jsp page, you will see that we are using the project object in the model to display these different fields on the view. So with this in place, let's save everything in our project, and then we are going to restart our application. Now we're going to navigate to our application, and first we're going to go home, then we're going to navigate to the Find page. You will now see the URLs, and if you see at the bottom of the screen, it says /project/1. If I click on that, it's then going to take me to the detailed page for this project. And that was made possible because we were able to construct this URL that contained the ID of our entity, and then we were able to use the URI template to pull that path variable out so that it could be used within our controller method. The controller handler methods within Spring MVC have very flexible signatures. For example, if we take a look at some of the methods on our project controller, you'll see that we are simply able to declare a parameter. So here, for example, in our find method, we just declare the model parameter, and it will get supplied as an argument when the handler method is invoked. If we take a look at the find project method, you'll see that we can pass in both the model and a long that corresponds with the project ID. And we did that using the path variable. There are many more arguments that can be passed into our controller handler methods. So if we take a look at the Spring MVC documentation, you'll find a list of these different arguments that can be supplied into the controller methods. You'll also see some annotations that can be used with the method arguments. So here you can see the HTTP session can be supplied. You'll also see that you can pass in things like the request body, an HTTP entity. You'll also be able to use things like the model attribute. And then you'll also be able to use things like the HTTP servlet request, the HTTP servlet response. So let's walk through a few demonstrations so that you can see this in action. We're going to modify the add project method, and we're going to supply the HTTP session as a parameter to this method, and then we'll work with the session to set an attribute. And we're simply going to name this attribute token, and we'll set its value to 1, 2, 3, 4, 5. And that's all we're going to do within the add project method. Now we're going to add some arguments to the save project method. The first argument we're going to add is the HTTP servlet request. And this is just like passing in the request to a servlet. And then we're also going to add the session to this method. So we'll select those types. And now what we can do is within the body of the save project method, we're going to add some console output. So the first thing I'm going to do is I'm going to grab the request and pull a parameter out of the request. And that parameter is going to be the name parameter that we're going to supply as we save our project. And then the next thing we're going to do is we're going to write out the token attribute that we placed in the session to our console. Here you can see we're going to grab the form to add a project. And when we do that, we enter token into the session with the value of 1, 2, 3, 4, 5. And then we're going to post the form. And when we do that, we are going to write the value of the name parameter to the console. And then we're also going to write the value of the token attribute found on the session to the console as well. So let's go ahead. We'll restart our project. And once it's restarted, we can navigate to our project manager application. and we're going to come into the form. And at that point, we should see that we've invoked the add project method, and we would now find our token within the session. And then when we add a project, so let's just say we're going to call this our fitness project, and we post this form, you'll see that we are able to print out the name because we passed in the HTTP servlet request and accessed the name parameter. And then you'll also see we pulled the attribute out of the session and we're able to write that to the console. The next thing we're going to do is take a look at using the request param annotation to annotate one of our method arguments. So we're going to remove the HTTP servlet request, and we're going to replace it with the request param annotation, and we're simply going to specify we'd like to access the name parameter within the request. And then we are going to supply an argument of type string that has the name of name. And then we can simply print that out to the console. So let's talk a little bit about the request param annotation. It allows us to pull a parameter out of the request and assign its value to an argument within our method signature. So we can go ahead here and restart our application. We can then come back in to the app. So I'm just going to go home, and then I'm going to go to projects add, and here we're going to add a new name for our project. So let's say using the @request param annotation, and if we submit that, you'll see in our console output we were able to map that request parameter, so that name value pair being passed back with the request, to our method argument using the request param annotation. Now let's talk about another neat feature of Spring MVC and its ability to work with arguments in our handler methods. It's able to type the parameters coming back from the request. So in this case, you'll notice I've switched the argument type to a type of long. And if we restart the application, you'll see that if I now navigate to add projects and I supply a numeric value for the name, that Spring MVC is able to convert that numeric to the type long, and then it's able to work with that object using the long type within the body of the method. This is thanks to some type converters that are built into Spring MVC that are able to inspect the argument type and then perform the proper conversions when it needs to from the request parameters. In this lesson, we are going to talk about one of my favorite features of Spring MVC, and that's data binding. Data binding really simplifies how we handle form processing and other input from the user. To get started, let's first navigate to our application and talk a little bit about the Add Projects page. This page is going to allow us to specify the information about a project, and then we are able to submit that information via a request back to our server. Now, within that request are going to be name value pairs for each of these fields. So you'll have a name associated with the request parameter and then a value assigned to that request parameter. What will ultimately happen is, after all the processing by our great dispatcher servlet, execution is going to get forwarded to the project controller, and eventually the save project method will be invoked. Now, in order to simplify things, I'm going to remove some of these other methods just to make things easier to read. So I'm going to remove the multi-year project and the special project. And then I'm also going to clean up some of the console output within save project. So let's talk about the role of the save project method. What we'd ultimately like to happen is for the save project method to read all of the parameters in the request and then use the information within those parameters to build a project object. So let's change our method signature to include a project object because that's ultimately what we want to build. Now, we could do this by reading the parameters from the request using the getParameter method and then setting the value on the setters of the project. But here's where data binding really comes into play and makes things much simpler and less error prone. In order to leverage the benefits of data binding, we use the ModelAttribute on our request argument. This is indicating that it should inspect the parameters coming in with the request from our form. So let's take a look at our form, and within it, you can see the name attribute on our different controls, and these are going to create the parameters, and it's going to be used as the name for our parameter. So here you can see we have a type parameter. You can also see that we have a sponsor parameter. So those will be the parameters coming in. They'll have values associated with them. And then they're going to be mapped to the project object. So where we saw the name parameter, Spring MVC is going to read that parameter name, then inspect the project class and find the field with the corresponding name. So once it matches the parameter name and the field name, it will then assign the value of the parameter to the field. And that's how the data binding occurs. What we can do in order to see this in action is within one of our setter methods, let's just put some console output. So we can say this setter is invoked by Spring MVC. And the other thing that we can do is add a toString method. So within the class, I'm just going to right click, and then we can go to source and then generate toString. And this is going to open a dialog box that we can use to build a toString method to output the fields within our class. So once we have that toString method established for debugging, we'll navigate over to our controller, and then we're simply going to print the project out to our console. So with all this in place, let's go ahead and we can relaunch our application, then launch our main method. There we see Spring Boot kicking off our project. Now let's go home to make sure the project has been launched, and then we can go to our form to add. So let's just call this a simple project. We will say it's single year. Our sponsor will be O'Reilly. They've authorized $1,000 and 1,000 hours. We'll give it a simple description, and we'll say it is a special project. Then I'm just going to go ahead and submit the form. And now if we take a look at our console output, you'll see that Spring MVC was invoking the setter, and then we were able to bind all of the request parameters and their values to build our project object. Now, one thing you'll notice is that the description is null. You'll also see that authorized hours is null. So we have some issues with how our data binding is established. If we take a look at our form, what you'll see is that some of the parameter names do not match exactly with what is on the project. So here is the authorized underscore funds parameter name. And if we go inspect the project and we find authorized funds, you'll see there's no underscore. So that's going to cause a mismatch between the parameter name and the field name, and we have to correct that in order for it to work. So let's fix that. We see authorized hours also has an issue. And then here for description, you'll notice that we have not even specified a
name attribute, and that would cause no parameter to be passed back. Okay, now that we made those changes, let's once again restart our project. And this time you'll see that we will have values in those fields we were missing. So I'm going to navigate to the project's add form, and then once it loads, we'll create another simple project. It will be single year. Our sponsor once again will be O'Reilly, and they're giving us $1,000, 1,000 hours. And this is another simple description. And then we'll say it's special, and we'll save it. And this time, if we look at our console and the output, you'll see that we have picked up the description, we've picked up the authorized hours and the authorized funds. So we resolved discrepancies between our parameter names and our field names.
In this chapter, we're going to look at some of the most common Spring MVC tags within two of Spring MVC's tag libraries. So Spring MVC has two tag libraries. One is just a general Spring tag library, and the other helps us build forms. So each of these tag libraries helps us create our view and helps us to integrate our view with the Spring framework. So let's take a look at some of our chapter objectives. So the first thing, we just want to introduce some of the most common Spring MVC tags. So we're going to be looking at building URLs and a lot of form components. And our goal is to understand how these tags fit into Spring MVC. Now, as we work with the form component tags, you're going to see how these tags support data binding. So it's really important that we understand the relationship between the form taglib and data binding, because we will use this throughout the course as we build our forms and we create our controller methods that are going to handle input from the forms. So in order to accomplish that, we're going to experiment and play with some of the most common form tags. So we'll have the form tag itself. We're also going to be working with inputs, selects, radio boxes, checkboxes, and text areas. So we will see how all of these tags work within a JSP to help facilitate the development of a view that integrates with Spring MVC.
Java Server Pages, or JSP, is one of the most popular view technologies used with Spring MVC. To help you implement views and perform data binding using Java Server Pages, Spring MVC has provided you with a tag library. In this lesson, we will learn how to include the tag library and use its URL tag. The URL tag can be used to build flexible URLs within our JSP pages. Within the application, you'll see the Resources menu. There's an Add option within this menu, and that takes us to a form that will allow us to submit a new resource to be created. So let's just walk through that quick, and we can submit one. Now, not much happened, but if we take a look back on the server, we see that we had some console output. And that's how this section of the application is currently built out. It's a work in progress. But here we see the resource_add.jsp page, and this is that form that was displayed. You'll notice that the form has an action attribute, and it's set to /resource/save. Now, when we send a request, in this case a post, to that URL, it will cause our application to invoke the save method on the resource controller. That controller handler method is what prints out the output to our console. When we build applications, it's pretty common to set a context root. Let's talk a little bit about that. The context root is the first path segment that is found after the domain in the URL. So for example, if we added /app after localhost 8080, that would be our context root. The context root is used by the servlet container to decide which application a request should be delegated to. There can be multiple applications running on one servlet container,
And the context root is what determines which application would serve a request in that situation. So what we're going to do is navigate to our application, and we're going to open the application.properties file. This is how we can set a context root within our Spring Boot configuration. And it's simply using the context path property on the server node. So it's just server.context-path, and then we're going to change our application to run on /app. Now let's restart our application. And once it restarts, we're going to navigate back to the browser. And then we're going to navigate to /home. And you'll notice that when we submit our form, we now get a 404. And the reason for that is because if we look at our form and the action, it is using this hard-coded /resource/save. It does not include the context root. What we can do is use the URL tag provided by Spring MVC's tag library. Before we do that, we need to include the tag library. So to do that, we go to the top of the page, and then we will add the tag library and set the URI. And when setting the URI, just hit Control space between the two quotations, and this will give you all of the options you can choose from. In our case, we want www.springframework.org/tags. The next thing we'll need to do is set a prefix for all of the tags found within this library. In this case, we're just going to set our prefix as Spring. Now, what this allows us to do is create a URL using the Spring URL tag. If we look at the tags within the Spring MVC tag library, we can use the URL tag. And we just need to specify the value, and that's going to be the URL that we'd like to contact. So here you can see that I've provided /resource/save as our URL, and then I'm just going to copy that and paste it within the action attribute of our form tag. Now, I'm also going to leave this tag on the page so that when we run the application, you can see what I'm talking about, how the URL is constructed. So now let's go ahead and restart the application, and we're going to navigate within the browser to /app/home/, and from there we can go into the resources add page, and here you can see the URL that was constructed. So that's just for example purposes, but you can see that the context root was prefixed to the path that we assigned to the action of the form. So now if we add a resource, you'll see that we do indeed invoke the controller handler method mapped to /resource/save. And that's thanks to the Spring URL tag that we used from the Spring MVC tag library. Now, if we take a closer look at this tag, you'll see that it allows us to do several things. You can manually specify the context. You can also escape HTML or escape JavaScript depending upon your needs. So there's some flexibility there. In this lesson, we will learn how to use the form tag found within the Spring MVC tag library. In order to learn more about this tag, we're going to walk through a demonstration that will swap out the HTML form tag found on the resource_add.jsp page with the form tag found within Spring MVC's tag library. So in order to get started with this, we need to add another directive to the top of our page. So I'm going to open the directive, and it's going to be for another tag library. and we'll specify that tag library by the URI. So just hit Control Space and then navigate to the bottom of our options, and you'll see the www.springframework.org/tags/form URI. That's the one we want to select, and then we're going to add a prefix for the tag library named form. So all of our tags will be prefixed with form. So now if we navigate back to the form tag, we can begin to replace it. So I'm simply going to create the form tag using the form prefix, and you'll see the form tag within our form prefix. Now, what we can do is just drop the closing form tag down to the bottom of our form. And once we're down there, we're going to remove the closing HTML form tag, and then we can navigate back to the opening form tag and remove that as well. Now we're simply using the Spring MVC tag library's form tag. If we take a look, you'll see that it has very similar methods to the HTML form tag. So it wants us to specify a method, and you will also see the action attribute. Now, when specifying the action attribute, we want to use the flexible URL that is created by using the Spring URL tag. It may seem very intuitive just to copy that tag and place it within the action attribute of our form tag. This is disallowed because you're not allowed to nest these tags. So what we need to do is we need to assign the Spring URL to a variable. And we can do that by using the var attribute found on the URL tag. So I'm simply going to switch the URL tag to use the var attribute, and I will specify the value of the variable as form URL. And then what we can do is use JSPEL to reference this variable, and that will cause the URL to be placed within the action of our form tag, and it will contain the context root. Now we're going to talk about another attribute that we can specify on the form tag. So you will see the model attribute, and the model attribute is used to specify a backing or command object. And what this really is an object that we are going to link with this form so that when we submit the form, the backing object will have its fields populated with the parameters found on this form. Now, in order to make this work, we need to provide that model attribute when our resource_add.jsp page is rendered. So if we take a look at the resource controller, we see the add method, and this is the controller handler method that is going to be invoked when we would like to display our resource form. So we will receive a request for /resource/add. That is going to cause the dispatcher to invoke this method, and then we provide the resource_add view name, which causes our JSP to be rendered. Now, what we have yet to do is place an attribute in the model that will serve as the command backing object for our form tag. That object is going to be of type resource. So you can see that we have a resource class, which has several fields that correspond to the data we're going to collect. And we're going to use that as our backing object so that the form data gets either populated by this object, or we use the data from the form to populate this object via a subsequent call. In order to do that, all we need to do is add an attribute to the model, and I'm going to name that attribute resource. And then I'm just going to use the new operator and the constructor to create a new resource object. Then let's grab this resource and we can head over to our model attribute. And from here, we can specify that the model attribute that's backing the form is the resource object. Now that the resource is in place as the model attribute for data binding, let's save our resource_add.jsp file, and then we're going to relaunch our application, and we can begin to navigate over to the browser. And at first we'll go home, and then we'll head back into the form, and we'll just run a simple test to make sure we are still mapping to our controller handler method. So I just hit the submit button, and there we do see that we invoked the save method on our resource controller. So this proves that within our form tag, we are mapping to the appropriate action. In this lesson, we'll use the input tag from the Spring MVC form tag library to create a text box that can leverage Spring MVC's data binding. So if we take a look at our resource_add.jsp file, you'll notice that we have several controls within our form. One of them being the HTML input tag, which will cause a text box control to be displayed on the form. We're going to work to replace this with the Spring MVC form tag library's input tag. Now, we need to make sure the tag library is in place, so check that the directive's there, and I can see it is because I'm getting some autocomplete here when I supply the form prefix. There you see the input tag, and we can put that in place, and you'll notice that it immediately asks for a path. The path is going to be the field from the model attribute that we would like to data bind to. So in this case, we're going to be data binding to the name field on the resource object. So here, looking at this Pojo, we see the name field, and we simply take the name of that field and supply it within the value of our path argument. And that will cause data binding to occur when the form is displayed and when the form is submitted. Now, if we further inspect this tag, you'll see that it provides us with several other attributes. Here is the CSS class attribute, which allows us to add CSS classes to the input tag. Since we're using Bootstrap, I'm going to just mimic what we have in place for the HTML input tag. So I supply the form-control class, and then the other thing I'm going to do is set the ID attribute. So you should probably notice that the tag library's input tag is really just mimicking a lot of the attributes that we find on the HTML tag for the input control. So let's just set the ID to resource-name, and at this point we can go ahead and remove the HTML input because we have replaced it with the Spring MVC form tag library's input tag. While we're here, let's just take a moment and we can inspect some of the other attributes that are available. So there you see you can escape HTML, set a max length, there's on click, on double click, on focus, a bunch of event handlers that you'd find on normal HTML tags. So really it's just mimicking or copying a lot of those attributes that we find on the HTML tag. We only need to set these 3 currently. Now that we have the form set up for data binding, we need to make some adjustments within our controller. So I'm going to navigate to the resource controller, And here, in order to receive the data from the form and bind it to a model attribute, we're going to have to change our controller handler method. So we know that the save method is invoked when the dispatcher servlet receives a request with the URL /resource/save, and that's exactly what the action of our form is set to. So once this method is invoked, we're going to begin to populate that resource object, which is set as our model attribute. So we add a resource argument to our save method signature, and we set the type of that argument to resource. And then what we do is we annotate that method argument with the model attribute annotation. And this will establish data binding from the data that we receive when the form is posted. Now, if we take a look at the resource class, you'll notice that its toString method has been implemented. So I can just grab that resource and pass it to the system.out.println method, and we will be able to see the fields on that object and their values. So we have everything in place. Let's go ahead and we will restart the application. And once we see it start up, we're going to navigate to our browser, and then we're going to visit the resource form. And within here, I'm just going to add a new resource. So let's say a printer. And this time when I hit the submit button, if we take a look at our console, you'll notice that we have now data bound our name field on the resource class. And that was all made possible thanks to the input tag found on the Spring MVC form tag library. In this lesson, we will learn how to use the select tag on the Spring form tag library. We often use select tags to display a drop-down list of options on a JSP page. For example, within our resource form, you will find the type field. The type field uses a drop-down by specifying the select tag within HTML and then including options within that select tag that we can choose from when providing a value. This is great because it constrains the choices the user has. However, we are simply specifying these options in a static way within the HTML page. Ideally, we would like to pull this information from the server and have it data bound to a model attribute. So we're going to leverage the form tag library and the select tag within it to achieve that. When we specify the select tag, the first attribute that we need to provide is the path. And since the model attribute is of type resource, we can go inspect that class and you'll see that there is a field of type string that corresponds with the component we're going to place on our form. So we just take that field name, which is type, and we place it within the path attribute, and that will establish the data binding. Now, the next thing we need to look at within this tag, and it's very important, is the items attribute. This attribute will determine which options are displayed within the dropdown for selection by the user. Now, as I mentioned, we want to provide these options from the server side. So we need to navigate to our resource controller, and we're going to make some modifications to the add method on our controller. What we'll do is declare a new list of type string, and I'm going to name this list options. And this list will contain the options that we're going to display within our dropdown. So once we've declared the options variable, we can instantiate a new list using the new operator and we're going to make it a linked list, and then we'll use the diamond operator to specify the generic type, and then we're going to use the arrays class and the asList method to build our list, and we can simply provide a string array that will contain the items found on our list. So here I can just provide different strings. If we take a look at the form, we see there's material, other, staff, and technical equipment. So let's add those: material, staff, other, and equipment. So we can go ahead and put those in place, and we have our list of options that will be displayed within our dropdown. The final thing we need to do is add these options to the model as an attribute, and I'm going to name this attribute type options, and then we simply pass in the list of options as the value for that attribute. Now with this in place, let's copy the name of the attribute, and then we can navigate to the resource form, and we can use JSPEL to reference that list. And then the final thing we're going to do is add the CSS class so we get the bootstrapped styling. So that was the select picker class, and with that in place, we can go ahead and remove the HTML select tag because we are ready to use the Spring form tag library and its select tag to specify our options. So at this point, I'm going to restart the application, and then I can navigate to a browser, and we'll head into the resources form, and we can begin to build a new resource. So let's say projector is the resource that we would like to have, and we'll say it's a piece of equipment. We then go ahead and submit the form, and if we take a look at our console output, you'll now see that the type of the resource has been specified as equipment, and that's because we were able to use the Spring form tag library and its select tag to display the dropdown with the list of options that were provided by the controller, adding them to the model. In this lesson, we'll learn how to use the checkboxes and radio buttons tag within the Spring form tag library. These tags allow us to add checkboxes and radio buttons that are data bound to a model attribute provided by Spring. So within this demonstration, what we're going to do is use two of our form fields, the unit of measure, and another one that we're going to create named indicators. And we're going to provide the value of these fields either using radio buttons or checkboxes. So for the unit of measure, we're going to use radio buttons, and for the indicators, we're going to use checkboxes. So if we take a look at the resource controller, you'll notice that we've added lists of strings that are going to provide the values associated with our radio buttons or our checkboxes. So here we've defined the unit of measure values, hours, piece, and tons, which are able to specify the measurement of the resource that we would like. You'll also notice that we have provided a list of indicators, which might be special information about a particular resource. So maybe we need lead time, or there's a special rate, or some sort of approvals required. We've built these two lists, and then we've placed them into the model. The radio buttons are under the radio options attribute on the model, and the checkboxes are under the check options attribute on the model. And then what we've also done is within our resources class, we've added a field of type string array and it is named indicators. So this is going to hold the selections from the checkboxes. That's why we're using a string array, because a checkbox setup allows you to specify multiple values. And then we have a single string field for the unit of measure where we will store that selection from the radio buttons, which only allow you to select one option. So now that we've walked through this, let's start building out these controls on our form. So we're going to start with the unit of measure, and you'll remember this was going to use the radio buttons tag. Now the first thing we need to do is specify the path, and the path indicates the field we will data bind to on our model attribute. Now because we are using the resource class as our model attribute, we're going to go in and grab the unit of measure field and place that within the path attribute. The next thing we need to do is specify the items, and these are going to be the radio buttons that are displayed for selection on our form. So we can reference the radio options attribute, which corresponds with our list of options, because that's what we'd like to display within our form. You'll notice I'm using JSPEL there. So at this point, the radio buttons are in place, and we can remove the text box on our form and proceed to providing our checkbox for the indicators. So you can probably guess we look at the form prefix and select the checkboxes tag. And just like the radio buttons, we need to supply the items and a path. Let's start with the path that we'll data bind to. So we navigate to the resource class and grab the indicators field and place that within the path. And then for the items, we can return to the resource controller and grab the check options. Now, once we return to the form, we can specify the check options and reference that model attribute via JSPEL, and that will cause them to be displayed as checkboxes that we can select on the user interface. So at this point, we have established our form, so I'm going to go ahead and save the resource_add.jsp file. The next thing we'll do is restart our application, and we can watch in the console window as it restarts, and then we can navigate to our browser and enter our form. And now on the form, let's specify our resource as consulting, and we measure consulting using hours. So we'll specify that as our unit of measure, and then we're going to indicate there's a special rate for the consulting. Now, if we submit the form, we can then go ahead and take a look at our console, and you'll notice that we have built a resource that is named consulting, that has an indicator as a special rate, and we're using hours as a unit of measure. In this lesson, we'll learn how to use the Textarea tag within the Spring MVC form tag library. A text area allows us to input multiple lines of text instead of the single line provided by the input tag. So to get started, we're going to work within our resource class, and we're going to add a new field of type string that we will call notes. Once we add the notes field, we're going to go ahead and add accessor methods to our class. So this can be done quickly by holding Alt, Shift, pressing S, and then hitting R within the IDE. This will open the Generate Getters and Setters dialog box, and then we can specify that we would like to add accessors for the notes field. And there we see they have been added to our class. And then what we'll do is we will go ahead and override our toString method. So if we just right click and then go to source and then generate toString, it's going to ask if we would like to override our existing toString method, and we'll go ahead and say yes. And we will include every field in the toString method, and once we hit OK, it will generate the new code for the toString method. So now that we have the field that we would like to data bind to located on our class, and that's the notes field, we can start adding our text area control within our resource underscore add.jsp page. So what I'm going to do is navigate to the bottom of our form and just copy one of the form groups. And then I'm going to switch everything over to notes. So instead of indicators, we're going to have notes. And then I'm simply going to go ahead and remove the checkboxes tag. And within the form prefix, we will find the text area tag. And now we're going to specify some of the attributes on this tag. So we know the path is the field we'd like to data bind to on our model attribute. So we set that to notes. And then we can add a class. So we're going to add the form-control CSS class. So we'll go ahead and add that attribute. And then the final attribute we'll set is the rows attribute. And this specifies how many rows will be within the text area. So you can see that we have set the CSS class. We have also set the path, and we've set the rows attribute. With that in place, we're ready to restart our application and run our demonstration. So here we can see Spring Boot restarting. And now if we go to a browser and navigate to Resources, Add on our menu, we can add a new resource. So let's say this is a developer. They are staff. They cost $1,000. We pay them by the hour. So this is a very well-paid developer. And they are paid a special rate. I would hope so at that price. And then we're going to add some notes. This developer is amazing. And then we're going to go ahead and submit the form. Now, if we take a look within our console, you will notice that we have data bound all of the fields on our resource, including the notes field, which was provided by the text area that we have established on our form using the text area tag within the Spring MVC form tag library. Throughout this chapter, we're going to look at more complex situations involving controllers. We're going to see additional annotations that really expand the benefits that controllers provide to us. We'll also take a look at more in-depth data binding situations and talk about how you can perform data binding to things such as lists or composite objects. So within this chapter, we have a few objectives. As we mentioned, we're going to look at complex data binding. So we're going to map the name-value pairs that are sent over in the requests, or the parameters, to different fields on our objects. But now we're looking at mapping to more complex objects than just a simple single object with some very simple fields on it, such as strings or ints. Now we're going to be looking at fields that are types of collections, or maybe that are more complex types that have their own fields. Next, we'll take a look at the model attribute annotation, and we'll see how that can change how we store attributes on the model. The annotation provides us with an alternative method for placing objects within our model, and we'll discuss how there's kind of a dual use for the model attribute annotation. It has one context where it's involved in data binding, and another where it's simply involved in storing objects within the model that's going to be passed to our view. We'll also take a look at session attributes. So when we're working in a web application, it's often necessary to persist data between requests. You may have some object that you're working on in each page or in maybe each step of a wizard, and you need to store that object in some for conversational storage between those requests, because we know with a request scope, an object would only be created for that request and then discarded after the request. Well, session attributes allow us to bridge that gap between requests. And then finally, we're going to look at using the request and response body annotations. These are all about, first, the response body directly outputting to the response body of a message via the controller. Normally, we will display our response by rendering a JSP file and having it rendered into HTML, and then that's what we send to the client. Well, when using the response body annotation, we actually just return that response directly from our controller handler method. And then kind of in the same realm is the request body annotation. And what this does is it allows the data coming in on an HTTP request within the body to be mapped to one of our controller handler method's arguments, and then allows us to perform some manipulation on that argument. This is going to be an exciting chapter. We're really going to learn how to use controllers to our advantage and learn a lot of the annotations that help us when we're developing web applications so that we can make our controllers perform the way we would like them to behave. In this lesson, we'll take a look at a more advanced form of data binding. That form of data binding is data binding composite objects. It's pretty simple when the fields of our form line up with simple types such as strings and ints on our model attribute. So as you see here, the project form has a name field, a type field, a sponsor field, and so on. These are simple types, and there is a one-to-one mapping between the request parameters and the fields on the project class. But what if things were more complex? For example, what if our sponsor field were of type sponsor instead of string? If we take a look at our project class, you will see that we have adjusted the class in order to make the sponsor field be of type sponsor. And now if we look at the sponsor class, you'll notice that it has fields of its own. So we have a name field, a phone field, and an email field. So within the project class, we are using composition with the sponsor field and the sponsor class, and we need to be able to data bind to the fields on the sponsor class from our form. So what we're going to do is modify our form in order to include each of the sponsor fields. Now, if you take a look at the project_add.jsp page, you will notice that we have added the form tag library, and I have modified the form to use the form tag as well as the input and select tags. So everything's been converted over to the Spring form tag library except for the sponsor field. Going back to our form, you'll notice that the model attribute has been set to project. And if we take a quick look at the project controller, you will notice that we are now adding a project object to the model so that we can perform data binding on our form. Now let's return to the form and start making our updates. So instead of having the HTML input tag strictly for sponsor, we're going to modify the markup in order to use the form tag library. So we'll simply prefix the input tag with form, so we're using the tag library, and then we're going to change the name of the field to sponsor name, and I will also change the ID of the field to sponsor name, and we'll change the label, and then we also need to adjust the CSS class attribute, and we also need to supply the path attribute. And what we do when we data bind to a composite or nested object is we just provide the name of the field on the project class, So let's navigate to the project class. We see the sponsor field. So let's just grab that field name. And then if we navigate to the sponsor class, here we see the different fields, and the field name will actually look like this for the path. So we'll have sponsor.name. So I'm just going to copy that and then place our field name back to its original name. And then on the form, we're going to put our new path. And then finally, we can go ahead and remove the type attribute because it will no longer need to be of type text. Now that we have one of the sponsor fields established, I'm just going to highlight the field, and I'll start with the div form group. If you hold Alt and Control and press down, it will duplicate the markup within the editor. And then we can begin to create the other fields. So the next field we want to create is phone. So we'll have the sponsor-phone. We'll change the name of the label. We can change the ID. And then we can also change the path. So we are data binding to the sponsor.phone field. And then the final field that we need to data bind to is the email field. So we're going to make the same updates as far as changing our markup and then changing these attributes on the form input tag from the tag library. So here we're switching everything over to email. And once this is in place, we are now able to data bind to a composite object. Let's test things out. So we're going to restart the server, and then we can navigate to our project's add menu item. And once our server is started up, it will render the form. And let's create a simple project. We're going to say it's a single year project. Our sponsor is NASA, and the sponsor phone number, we'll just make something up here. And then we'll say the email is nasa@nasa.gov. And then we can change authorized funds. We'll say they're giving us $1,000 and 1,000 hours to work on this project. We'll enter a short description. We can then submit. So if we now navigate to our console, you'll notice that we were able to print out the information from our composite object, the sponsor, to our console. So let me line things up here. And there we can see the email for the sponsor, the phone for the sponsor, and the sponsor's name. In this lesson, we are going to take a look at data binding lists. So we've seen data binding to composite objects and to simple classes that have simple fields such as strings or booleans, those quasi-primitive types of fields that don't have any fields of their own. We've seen those examples, and now we're going to take a look at another complex case, which is data binding to a list. In our demonstration, what we'll be doing is adding 3 point of contact fields to our project form. So these are people associated with the project we can contact about it. In order to store the information regarding these points of contact, we're going to modify our project class. So what I'm going to do is within the project class, I'm going to create a new list of type string that I'll name points of contact. And then what we'll do is import the list type. And at the bottom of our class, we're going to generate the accessor methods. So we'll have a getter and a setter for this new list. And then we're going to regenerate our toString method. So I can simply generate that method once again with all of the fields. And now if we were to invoke the toString method on the project, it would include our list of points of contact. With those changes to our project, we're now able to switch over to our project form and add the points of contact fields to our form. To make this easy, I'm just going to grab the sponsor email and I'm going to duplicate the field and move it towards the bottom just above the special field. And then what we can do is change the label to point of contact 1, and we'll change the ID of our input to POC1, and then the same thing will occur for the for attribute on the label. And from there, I'm not going to touch anything else. I'll just go ahead and duplicate this form group twice, and I'll change all of the 1s to 2s because we're going to have a second, and then finally a third POC. And now we have these 3 fields established. What we do not have is data binding established to these fields because we haven't specified a path. So all I need to do is supply the name of the list in each one of the path attributes for this group, and then I need to provide an index. So just like an array, I'm going to start with a 0-based index. It's important to start with 0, and then provide the values 0, 1, and 2 for the indexes of the path. That will cause each of these fields to have their values inserted into that list. And that's thanks to this notation we can use on the path. So with that in place, let's talk a little bit about what is going to occur. So our form is going to get submitted, and that's going to cause within our project controller the save project method to be invoked. And because the save project method accepts a project argument that is annotated with the model attribute annotation, Spring MVC is going to start data binding all of the fields of the project. And it's going to inspect the request parameters, and based upon that parameter name, it will data bind to the appropriate field on the project object. And that includes our list that uses the index syntax. Once the project is data bound, it's going to be output to the console, and we can then inspect all of the output when the toString method is invoked. So from here, let's go ahead and we can start our application. So I'll just right click, run as Java application, and we should see our console take off. There we see Spring Boot launching the app, and we'll start heading over to the browser, and we'll head to the project's add form, and let's make sure that our points of contact were added. Okay, so let's just create a simple project, sponsor name, phone, email, give ourselves some funding, some hours. We can also select a single year. We'll say this is a simple description, and then I'm just going to put POC1, POC2, POC3. This is all test data. We'll go ahead and submit from there. And now let's go check our console output and pay close attention to our list. So we can see that we were successful in data binding that field that is of type list on our project. In this lesson, we are going to have a more detailed discussion of the model attribute annotation. Within Spring MVC, the model attribute annotation has 2 contexts. The first one we've already seen. It's the model attribute annotation that we use on method arguments. So here we see within our save method, we have annotated the resource argument with the model attribute annotation. When we place the model attribute annotation on a method argument, we are saying that we should retrieve this argument from the model. Spring will look into the model to see if there is a class of type resource to supply as the argument to this method when it's invoked. If we cannot find the attribute within the model, Spring will instantiate a new resource using the new operator and the constructor. Then Spring will begin matching the parameters on the request to the fields on the class, data binding the object. This prevents us from having to set all of the fields on our object with request parameters. We've seen this in action already. What we need to look at now is the other use of the model attribute annotation. So the other context in which we use the model attribute annotation is to annotate a method on a controller. So let's go ahead and build a new method that returns a list of type string, and I'm going to name this method getChecks, and once it's established, I'm going to return null in the body of the method, and then I'm going to go ahead and annotate this method with the model attribute annotation. When we use the model attribute annotation on a method like this, it's used to indicate that this method will place an object within the model as an attribute. So whatever object is returned by the method will be placed into the model. We can specify the model attribute name by setting the value element on the model attribute annotation. So in this case, I'm going to set the value element to check options. And you'll notice that we have the check options available to us within the body of our add method. And this is exactly what we would like to return from our method. So I'm just going to grab the instantiation of this list, and I'm going to place it after the return statement within our getChecks method. So what will happen is that when our add method is invoked, it's going to cause the getChecks method to be invoked. And this is all going to be handled by the DispatcherServlet. And when the getCheck methods is invoked before the add method gets invoked, it's going to place this list into the model under the model attribute check options. The reason we're doing this is because on our resource form, we have specified that check options is a model attribute that we can use to supply these checkboxes. So what we're going to do now is we're going to duplicate this method twice, so we have 3 of them, and then we're going to change the method name. So we're going to call the next one getRadios, and then our next one we'll call getTypes. So those will be our method names. And then we're going to replace the code that places these model attributes into the model with these methods that will place the model attributes into the model. So for the getTypes method, we're going to set the value to type options, and then we're going to grab the list that gets instantiated, and we can pull that down within the body of the getTypes method. So we'll simply replace our other list, and now we'll do the same thing for the radios. So I'm going to grab the list of values that we use to build our radio buttons, and I will supply that list within the getRadios method. And then I'm going to change our model attribute name to radio options. So at this point, we can go in and actually remove the code that is adding these 3 lists to our model. And then finally, we can even provide a method annotated with model attribute to supply our form backing object or our command object to the model. So let's create a new method that returns a type of resource, and we'll name it getResource. And then within the body of this method, we simply return a new resource that we instantiate with a new operator in the constructor. And then we add the model attribute annotation to this method. And then we can supply the name of the model attribute. And by default, if we don't specify an element, it will be the value element of the annotation that is used. So there we're creating a new attribute in the model named resource, and we're declaring that it will be assigned the new resource object. So we can go ahead and remove that out of our add method. So you can see how it simplifies our controller method by moving all of the additions to the model outside of the body of our controller method. So these methods will be invoked prior to the add method. So let's add a little bit of console output. So let's say we are adding an attribute to the model. And then what we can do within the add method is add some console output, and we can say invoking the add method. So with all this in place, we are ready to run our application. So let's go ahead and I'll restart the application. Let's now head to the browser and go to Resources Add. And if we take a look at our console output, there you can see that we invoked the getResource method where we added the resource to the model, and then we invoked our add method. And if we also look at our form, you will see that we do in fact have the options specified for our radio buttons, for our checkboxes, and also for our dropdown. In this lesson, we are going to learn how to use the session attribute annotation in order to store our model attributes between requests. Up until this point, we've only been looking at processing a single request. However, if you build web applications, you know that often we need to have data persist between requests. To do that, we would normally store the data within the session in the Servlet API. When using Spring MVC, we use the SessionAttributes annotation instead of the HTTP session. Let's walk through a demonstration in order to see the SessionAttributes annotation in action. First, we need to talk about how normal request processing works. Within our resource controller, we're able to display the form by invoking the /resource/add method. That displays our form, and then when we save the form, we invoke /resource/save, and that is going to invoke the save method. Before both of those methods would get invoked, then we're going to add these objects to our model thanks to our model attribute annotations. Let's walk through this quickly just to review. So if we go to Resources Add, and then I go down and submit the form, and then we take a look at our console, let's talk about what's happening. So here we see the model attribute annotation get invoked. There we're putting the resource into the model. We invoke the add method to display the form, and then we post the form, and that causes the model attribute annotated method getResource to be invoked once again. So that's why we see this output to our console. We also then write the resource to the console via the toString method, and we've invoked the save method at this point. And then what you'll see is we will loop back in to display the form thanks to the redirect that we have established. So that's us navigating back into the form being displayed. And once again, when we do that, we are invoking the getResource method. So basically for every request, we are invoking these model attribute annotated methods. And really, we're getting a new object each time. We're not storing that state. So when we use the session attributes annotation, we are able to store a model attribute between requests. This can be very useful if you're developing a wizard-based approach where maybe you don't want to persist the information or the data as you walk through every step in the wizard and you want to wait to the end, or as we're going to demonstrate, if you maybe have some sort of review or confirmation at the end of your process. So in this demonstration, we're going to interject this confirmation page into the process of saving a resource. So actually, when we hit the save button on the resource form, we're going to display this confirmation page. And you'll notice this confirmation page does not have a form on it. All it has is these two buttons at the bottom where we can either save the actual data, and you'll notice it's mapped to the /resource/save URL, and that would cause the save method to be invoked on our controller, and that would eventually cause the resource to be printed out to the console. And then you can also see on this confirmation page, they can edit, which takes them back to the form where they're able to edit the resource they're working with. So in order to set this up, the first thing we're going to do is we're going to open the resource add.jsp page, and currently it is set up to post to the /resource/save URL. We need to adjust that so it posts to /resource/review. Once we've made that change, we'll go ahead and save that file. And now we're going to navigate to the resource controller where we will establish the review method. So we're going to create a new method and we'll just call it review. And that method is going to accept an argument that is annotated with the model attribute annotation. And the argument is going to be of type resource, and we'll name it resource as well. And then we'll add the request mapping to this method. And the request mapping is going to be to /review. And then we're going to navigate to the resource review page from this method. So we're going to return that view name so that the view can be resolved to our resource underscore review.jsp page. And then I'm also going to add a little bit of debugging here. We'll just say invoking the review method, and at this point we have it established. Now the final thing that we need to do in order to save our model attribute as we invoke each of these methods with different requests is to add the session attributes, and that's plural, to the resource controller type. And in this case, we're going to specify that we would like to make the resource a session attribute, and that will cause it to be available between requests coming in and being processed by the dispatcher servlet. Now, it's important to know that session attributes have to be on the same controller in order for them to work. So with this in place, let's relaunch our application. So we see our console taking off there. And the first thing I'm actually going to do here is clear the console, and then I'm going to navigate to the resources add page within the menu. And then let's create a simple resource, and we'll say it's material. It costs $100 per piece. It requires lead time, and we don't need any notes. Now let's go ahead and submit. So there you see we get the information about the resource we can review. And now we say we want to save. And at that point, you'll notice we've invoked our save method. The best way to see this is by looking at our console. So here you can see we invoke the getResource method. So if we take a look, that is the method that adds our model attribute to the model. If we take a look once again at our console, we only invoke that method once, and that's because it's stored in session after that first invocation. And then we invoke the add method, we invoke the review method. Here we're printing out the resource to the console, and then we're invoking the save method. And you notice we're never going back and invoking the getResource method. And that's all thanks to the SessionAttributes annotation and being able to store our resource in session with Spring MVC between these requests. In this lesson, we will work with the SessionStatus interface. The SessionStatus interface can be injected into our controller handler methods. Once injected, we can invoke a method on the SessionStatus interface to clear items out of session. So let's walk through a simple demonstration to see what we're talking about. If we navigate to our application, I can create a new resource, and I'll set it as material. We'll say the cost is $150. We're paying by the piece, and it requires some lead time. Now, if I go ahead and submit the form, it will take us to the review page where we're able to confirm the resource before it gets saved. If we take a look at our controller, you'll see that we have first invoked the add method on the controller to display the form, and then we have collected the parameters to build the resource within the review method. So when this controller handler method is invoked, we start to collect the data from the form and populate the resource. And now it's stored in session at that point. And then once we hit the save button on the form, we're going to invoke the save method on our controller. And that's going to cause the resource to be printed. And then we're going to display the form once again by redirecting to /resource/add. So let's see that in action. What you'll notice happens when we do that, we have redirected back to the form and it has retained the values because they are in session for that resource. So what we would like to do is clear out the attribute from the session so that we can start over. There's times when you need to clear session. So in order to do that, we use Spring MVC's SessionStatus object, and we just inject that into our controller handler method. And then once we have the status method injected, we can simply call its setComplete method. And that is going to remove any session attributes at this point. So then we can return to a fresh walkthrough of our resource form. So with this in place, let's go ahead, restart the application. And once it restarts, we'll head back over to the browser. And we're going to go into the add form. And we're going to create a new resource. Let's say it's a hammer. Hammer is going to be some sort of equipment. We'll say it costs $10 a piece, and let's say it requires approval. We're very selective about our hammers. Now you'll notice if we go to the review form, we can see information about the hammer. And then once we save, we no longer have that model attribute stored in session. It's in fact been cleared out, and when we re-enter the form, we have a fresh form to work with. In this lesson, we'll learn how to use the response body annotation within Spring MVC. The response body annotation allows us to provide the return value of our controller handler method as the body of the response to a request. A very common scenario for using the response body annotation is when returning a response to an AJAX request. Let's walk through this scenario as a demonstration. So I'm going to navigate to the browser, and here we see our resource form that has been updated to include this hyperlink. This hyperlink will allow us to send an AJAX request back to the dispatcher servlet. And the business case for this is if we would want to send a request for approval. We can send this AJAX request back to the server, and then on the server side, we would send out an email requesting approval to use a particular resource. So we're going to mock out the email part, but what we're going to focus on is how we provide the response to that AJAX request. So let's take a look at our resource add form to see how this works. You can see that we have added the anchor tag, and the anchor tag has a ID of request-link. Now, if we look within our project, you'll notice that within the source main resources directory, we have a resource.js file. And it's important to note the location of this JS file. It's within the static folder. By default, Spring Boot will configure Spring MVC to serve any static content within the static folder. So if we send in a request for resource.js, it will not go through the normal routing as a request would for the request processing lifecycle. We're just going to directly return this JavaScript file. So when we have static content like images or CSS, we need to include them within the static directory in our project, and Spring Boot will take care of the rest. Now let's take a look at our resource.js file. It attaches an event handler to the click function of our request link anchor. When the click occurs, we will send an AJAX request back to the server for the URL /resource/request. We'll send back the form data, and then as a callback, we're going to receive whatever data the server side returns, and we're just going to alert it. Now, currently, the resource.js file is not included within our resource_add.jsp. So all we need to do to put that in place is add a script tag, use the Spring URL, and then we're going to just change this name to resource.js. And because resource.js is found within that static folder, underneath the JS directory, we can make it available as a client-side resource for our page. Now we have the JS in place, we need to focus on the server side. So I'm going to navigate to our resource controller, and then within the resource controller, I'm going to set up a new method to handle this AJAX request coming back in. So I'm going to just create a method named request that returns a string, and we're going to accept the resource as a model attribute. So we'll just add an argument of type resource to the signature of our method, and you can see it's annotated with the model attribute. Let's just mock out like we're sending the email. So we'll just put some code in there. Maybe that's a to-do. And then we're going to return some content. So this would be the response going back for the AJAX request. And we'll just say the request has been sent for approval. And we're just going to return that string. Now, that's not a view name because of what we're going to do next. We're going to add the response body annotation, and we'll include that annotation on our page. We'll import it, and then we're going to add the request mapping, and we're just going to map to request. What's going to happen is the AJAX request will get routed to this controller handler method based upon the URL mapping we've established. And then we're going to return this string, and that string is going to go back directly as the body of the response. We're not going to go look for a view to render because we have specified we would like that behavior thanks to the response body annotation. So at this point, let's make sure everything is saved, and then I'm going to launch the application and navigate to my browser and go into the form. Once in the form, I'm not going to fill everything out. I'll just fire off the AJAX request. And there you can see that we were able to send the request, and we received the response back from our controller handler method. And that response was the return value that we specified And the reason we got that return value is because of the response body annotation placed on the controller handler method. In this lesson, we are going to look at Spring MVC's request body annotation. The request body annotation is the counterpart to the response body annotation within Spring MVC. So if you will remember, the response body annotation allowed us to return the output of our controller handler method directly as the response to an HTTP request. Here we see the response body annotation on the request method, which returned this string literal in response to the AJAX request that was made by the JavaScript found within the resource.js file. We can quickly see that in action, so let's create a new resource, special paper, and we're going to specify the cost as $1,000 a piece. And because it's so pricey, it requires approval, and we fire off our approval request, and that invokes our controller handler method. We're going to look at the inverse here. When we fire off this AJAX request, you'll notice we are serializing the form, so there's going to be data passed back as part of the request body. So when we look within our controller handler method for the request, what we can do is replace the model attribute annotation with the request body annotation, and then we're just simply going to change the type of our method parameter to a string, and then I'm going to output that to the console so we can see exactly what was returned. So here we're taking the body of the request, mapping it to our string, and then printing it out to the console. So I'm going to go ahead, restart the application, and once I do that, we're going to navigate to the browser. We will then select the Add option under Resources to bring up our form. And we're going to once again use the special paper. This time the price is increased to $2,500 a piece. We really need to get that approval this time. So let's fire off our request. And you'll see that we have returned the response from the controller handler method. So let's go look at the console. Here you can see that request body was mapped to our method parameter that we then printed to the console. Now let's go back, and I can open up some debugging, and if we take a look at our networking, I will fire off that request one more time, and we can inspect what's going back. If we come over, we can see the form data. If we view the source, this is really the request body that went over the wire. And that's what is reflected within our console. So returning to our controller, let's continue our discussion. Spring is able to make all of this happen thanks to the HTTP message converters found within Spring MVC. Right now, this doesn't look like a very useful feature. Why would we want to parse out that when Spring can data bind right to an object? But where this really comes into play is when we start looking at JSON. So imagine we pass back a JSON string with our AJAX request. Spring provides an HTTP message converter that can actually convert that JSON to an object. So what we can do is we can change our method parameter over to a type of resource. Now, when we receive that JSON string included with the AJAX request, the request body annotation can find the appropriate message converter for the resource type or JSON and perform the deserialization to our Java type. And that's really the biggest use case of the request body annotation. If you have any experience in the IT field, you know that things can and will go wrong. Users perform operations outside of what we expect. Sometimes there are just issues within our architecture. Sometimes there's a server down or there's a database down. Well, it's not our job to handle every possible thing that can go wrong within an application. But it is our job to present that information to the user in a way they understand, in a way that helps them work around the approach. In this chapter, we're going to look at validation, errors, and exceptions, and we're going to learn how to use Spring MVC to handle all of these items that can occur when a user is working with one of our applications. So let's take a look at our chapter objectives. First, we're going to look at how we validate our fields when we are data binding the information that's passed back from a form. Users do not always put the information into a form in the way we would expect. Sometimes we will see characters that shouldn't be there. Sometimes they are too long of a length. They don't match the format we would like. We're going to look at ways that we can validate user input. Spring provides validators to handle this, and there's also JSR 303, which is the bean validation specification within J2EE. Once we've learned to validate the data that we've received, we're going to look at how we can display those messages to our users easily. And Spring builds this right into the framework. So it provides us a mechanism to pass that validation error message back to the user and display it on the view. And having that built into the framework provides a lot of consistency, and we don't really need to reinvent the wheel and make our own approach to handling validation errors. After we get past looking at some of the validation, we're going to look more at some of the things that can occur internally within an application that are going to raise an exception. Exceptions need to be handled, and they need to be handled securely and gracefully. So what does that really mean? It means we're not displaying a stack trace to an attacker, which can provide them with more information about our system, and we're not displaying a stack trace to our user who really can't do anything with that. When we do have an exception within our application, we want to display some nice aesthetic message to the user, possibly directing them to a way to resolve the issue. Spring provides us with an exception handler annotation, and that can be used to indicate how exceptions should be handled when a controller throws an exception. There is also a more global exception handling approach built into Spring MVC, and this approach allows us to use a HandlerExceptionResolver to resolve all exceptions thrown from every controller, so we're more at that application level. To accomplish this, we specify a HandlerExceptionResolver, and we make it a bean within the Spring IOC container. Then when any of our controllers throws an exception, the exception is passed to our HandlerExceptionResolver, and we are able to resolve the exception, usually by displaying a view that presents a message to the user in a nice aesthetic manner. So in this chapter, we're going to see all of these different features of Spring MVC and how they can help us with validation errors and exceptions.
In this lesson, we will learn how to perform validation with Spring MVC. Specifically, we are going to see how to validate the model attributes passed into our controller handler methods. For example, if we inspect the save project method, we see that it accepts an argument of type project, and this argument is annotated with the model attribute annotation. We know this means that any request parameters passed in from a form will be data bound to the fields of the project. What we're going to see is how we can validate that project after it has been data bound to detect any validation concerns we may have. To do that, we need to build a validator within Spring. We're going to place our validator within a new package in the data package. So I'm simply going to create a package and I'll name it Validators. And then within that package, I'm going to build a new class, which I will call the Project Validator. And then I'm going to make that class extend the validator interface and make sure it's the org.springframework.validation package that contains that validator interface. And once you've done that, just go ahead and hit finish. and our new validator class will be built. The validator class contains two methods, supports and validate. Let's first talk about the supports method. What Spring is going to do when it starts to validate these model attributes, it's going to consult all the validators and basically say, hey, do you support this type? And they need to say yes or no. And the way we do that is by simply returning a Boolean, because Spring is going to pass in the class, so here's the type, and then we need to respond yes or no, do we support it? So we know we're going to support the project class, so we'll use the equals method on the class to compare it to the supplied class. And then we can determine whether or not we support a particular class for validation. Now, if we take a look at the validate method, this is where the real work is done. The first argument supplied is of type object, so it's very generic and abstract. And what we're going to do is actually cast that object directly to a project type. And we can do that because of answering this question. We know we're working with a project. Once we have the project, we can establish some validation logic. So I'm simply going to use an if statement and then grab the project name and check its length. If the project name is not greater than 5 characters, we're going to flag an error just to prove our example. Now, once we detect an error via our conditional check, what we can do is work with the errors type, and on this type, we find the reject value method, and we're going to use the form of the method that accepts 3 arguments. The first one is the name of the field, pretty simple. We're looking at the project name field. The second is if we would like to supply the error message from a property on a properties file. We're not going to do that. We're going to use a much simpler approach here because the third argument to this method is a default message. So if it can't find that property value, it's going to use the string we supply here. So we're just going to say the name is too short. And at this point, we've established our validator. The validator class has the supports and validate method. The validate method is going to get called once we have the model attribute bound. We'll see that a little bit later. But what we need to do now is register this project validator with our controller. So we're going to return to the controller and we're going to talk about an init binder. So the init binder annotation, it signals to Spring MVC that we need to register some specific beans for this controller. And normally these beans are things that handle things like formatting, conversions, or validation. So let's put the init binder in place, and it gets annotated on a public method that returns a type of void, and we can call it whatever we like. I like calling them init binder. And the init binder can accept an argument of type web data binder. And I'm just going to call this argument binder, so that'll be its name. And let's import those types. And then if we inspect the methods, we will see that we can add validators. And then all we need to do is supply an instance of our validator, and it's now registered with our controller. This is just the first piece of what we need to do. There's some additional work we need to complete, but just in the interest of time, we're going to break this lesson up into 2 videos. In the first part of our lesson on Spring MVC validation, we were able to build a validator for the project type and register it with our controller. In this video, we'll put the final pieces in place to demonstrate how validators work. Once we have the validators in place, we need to signal to Spring MVC that it needs to invoke the validation on our model attribute. So we're going to navigate to the save project method,
And in order to provide that signal to Spring MVC, we need to add the valid annotation. And this will indicate that we would like Spring to invoke our validation on this project object that is a model attribute. Now, when we put the validation annotation in place, we also need to include a new dependency within our project. So we're going to navigate to the pom.xml file, and we're going to add the validation API. In the list of dependencies, we want to make sure that we select the javax.validation group ID. So we want the artifact within that group ID. We just hit OK, and then we can go ahead and save our pom.xml file. I'll go ahead and close that file at this point. And now we can move on to our next task. Within the controller method, we need to determine if validation passed. We can do this by using an errors argument on our controller handler method. So I'm going to go ahead and add a new parameter to this method. It's going to be of type errors, and we'll name it errors. This errors type allows us to collect the results of any binding or validation and inspect it within our controller handler method. So let's work within the body of this method to do some detection on that errors object. So what I'm going to do is first I'm going to check if there were no errors, and I can do that very easily by invoking the hasErrors method, which is a Boolean. And it's simply going to say whether or not there's errors when we performed our validation. And right now I'm just checking if there were not errors. And what we'll do is we'll print out to the console that the project validated in this case. Then I'm just going to add an else statement to give us the inverse, and we can say the project did not validate. With that in place, what we can do is go ahead and restart our project. We can then navigate to the browser and go to the project's add form. Within this form, we're simply going to do some validation on the name field. So let's first start by just entering a letter. This should not pass validation. So when we submit the form, you see that we were able to invoke our validation, and it prints out the project did not validate. And that's because we inspected the errors object and found no errors. Now let's add a little bit more here. So Kevin, Bowersocks, and at this point, if we validate, we should pass because the length is greater than 5. We take a look at our console. Hey, we passed. That's exactly what we wanted. In this lesson, we'll take a look at another approach that can be used to perform validation within Spring MVC. We have seen how to create a validator based off of Spring MVC's validator interface, but now we are going to take a look at how to use JSR 303 validation. JSR 303 validation is actually the bean validation specification within the Java API. Spring allows you to integrate a JSR 303 provider into the framework. So to get started, we need to add an implementation of the bean validation API. Hibernate provides an excellent implementation of this specification, so that is the one we're going to use. In order to add that implementation, we need to open our pom.xml file so we can add a dependency within that file. So once the POM is open, just click on Add, and we're going to look for the Hibernate-Validator artifact. And once we get the list of results, you want to select the artifact with the group ID org.hibernate. So we can go ahead and pull that dependency into our POM and then close the pom.xml file. Now that we have the dependency in place, what we can do is annotate our entities. For example, let's say that I wanted to mark the description field as required. I can use the not blank annotation from the JSR 303 specification, and that will be used to validate the description field. Now, within the available annotations we have, we can specify the min or max of a number, the length of a string, and there's also a very powerful annotation that allows us to provide a regex pattern that we can use to perform almost any sort of validation on one of our fields on a bean. So you can look into JSR 303 annotations in order to find creative ways to validate the fields on an entity. In our case, we're just going to have this not blank annotation. So what will happen in this case is when we perform the post on our project form, we have the valid annotation on the project argument that we're passing into our SaveProject method. Because we are using JSR 303 validation and have the provider on our class path, Spring MVC is going to check that the description field is not blank. If it determines that the field is blank, it will cause an error to be flagged on the errors object, and we can then print out the console output that the project did not validate. So let's go ahead and we can restart our application, and then we'll navigate to the browser, and we're going to head to the projects form. And first I'm just going to enter a name. This is a simple project to satisfy our validation. And then I'm going to navigate to the description field. I'm not going to provide any value, and I'll submit the form. So if we take a look, the project did not validate, and that's thanks to our JSR 303 validation. And if we return and add a value, so let's say this is a value, and we once again submit the form, now you'll see that the project validated. When building validation into a web application, it's important to display feedback to the user about any validation errors that arise. In Spring MVC, we can use the errors tag within the form tag library to display messages to the user when validation issues occur. We'll run a demonstration that shows how to provide feedback to the user via the GUI. The first thing that we need to do is modify the project controller's save method. So currently, if we look at the save method, you see that we are just outputting information to the console when there's an error or when the project validates. We're going to change this up so that we return the project add view, and you'll remember this is mapped to our project form. So when there's an error, we're going to redisplay the form, and we're going to have the errors passed to the view to be displayed. Now let's talk a little bit about the validation we are performing. So if we look at our project validator, you see that we're validating on the name field, and when we create the errors by rejecting a value, you can see we are mapping to the name field, and we're actually able to access that error by using the name as a path. So we'll see that in a little bit. Let's also talk about the validation we're performing on the project. We have the bean validation occurring, and if we take a look at this annotation, you'll see that you can specify a message. So here, when our description is blank, we can display a message. Let's say you must provide a description, and that's the message that will go back to the end user. Over on the validator, it was the default message, the name is too short. So we have these two validation checks going on. Let's now talk about how we display them to the end user. So first, let's talk about name. When we have an issue validating the name, what we would like to do is display the errors. So we can use the form prefix, so we're using the form tag library, and you'll see the errors tag. And within this tag, you're going to find a path attribute. And as you remember, if we look at the validator, we supplied the field name, which was name. So all we need to do is go ahead and put that path name in there. And you can probably assume it's going to be very similar with the description. So let's go ahead, we'll add the description in here, and we just use the form errors tag, supply the description, and we are set up. So when we post to the controller and our save method gets invoked, if there's errors, we display the project add view, and that's going to cause our errors to be passed back to the view and rendered when the appropriate path is found within those errors. So let's restart the application, see this in action. So there we see our application starting. Time to navigate to a browser. I'm going to go to the project's add form. The first thing I'll do, I'll just attempt to send the post back. Here we see the name is too short, so our validation worked. And our description, we get the message, you must provide a description. Now let's enter a valid name, and then we'll submit the form again. And this time you see that the error message goes away. We should still have an error on the description. There it is. Let's supply a description this time, and we'll once again post the form. And now you can see that the error messages went away. So when we use the form errors tag, we are able to display the validation messages, and those messages can help the user when they input data into our system. It allows us to take those validation issues that we collect in the errors object and pass them over from our controller layer to the view layer so that they can be displayed. When building a web application, it's important that we have some mechanism to handle the exceptions that can be thrown by our application. It is not a great practice to just return a stack trace to the user through a view because it has security implications and it's not cosmetic. In this lesson, we'll learn how to use Spring MVC's exception handler annotation to handle the exceptions thrown by our application. This annotation can be used to handle those situations when an exception occurs within a controller method. The first thing we'll need to do is throw an exception. So within our resource controller, I'm going to force an exception to be thrown within the add method. Now you'll remember that this controller handler method displays our resource form. I'll create a conditional, and this is simply because I don't want the compiler to complain. And then within that conditional, 1 is equal to 1 is always going to be true. Within there, I'm going to throw a new runtime exception. And we'll just say this is an exception, and that will be the message. And now we have our exception forced. So let's see what happens here. Let's launch the application. Once it starts to launch, we'll navigate over to the browser. And now we're going to see a nasty stack trace when we display this message. Here you can see that we get the exception message. We're just getting this white label error page. We don't want that. Let's now add a more aesthetic way of presenting our error message. To help us out with that, I've added the controller_error.jsp page. And it's just a simple page that displays a message and replaces the default error page displayed by Spring Boot. We can style this however we would like. You see a lot of the whoops, something went wrong pages. Have some fun with it. So what we need to do in order to display that nice error page is to create a new controller method. And I'm just going to name this method HandleError. And then within the body of that method, it's just like returning any view name. We can say that we would like to return our controller error view, and that's going to map to the JSP that I just showed you. Now, the other thing that needs to occur is we need to add the exception handler annotation to our handler method. Now, if we take a look within this annotation's elements, we can specify the value annotation, and this can be either an array of exceptions that we would like this handler method to handle, or it can be a single exception. So in this case, I'm just going to go the single exception route and specify the exception class. So that's going to cover a wide range of the exceptions, in fact, all of them. Now, another thing about this handler method is that we can inject most arguments that we would supply to a regular handler method. So for example, we can send in the HTTP servlet request. The only thing that we cannot do within the handler method for exception handlers is do some data binding like with a model attribute. You can inject most other arguments, you just can't perform data binding here. Really what's going to happen is when that exception is thrown, Spring MVC has a simple mapping exception resolver that it puts in place, and it simply is able to route the execution of our request processing to any handler methods that have these exception handler annotations on them. And it determines how it routes by the exception class that we specify within the value element of the exception handler annotation. Now, one thing to know about the exception handler annotation is that these declarations only apply to the controller that we're working within. There is another approach that we can use to globally establish an exception handler, but when we annotate controller methods, as we're doing here, it only applies to the controller. The scope of this exception handling is only to those controller handler methods that have the request mappings within the resource controller. Let's go ahead and save our resource controller, and then we're going to go ahead and relaunch our application so that we can see our exception handler in action. So I'm going to navigate back, and this time I'll head into the resources add page, and there you can see our nice aesthetic error page that was presented by our exception handler. In this lesson, we will learn how to deal with exceptions using a global approach within Spring MVC. Spring MVC provides us with a handler exception resolver interface, and using this interface, we can handle all exceptions thrown within the application at a global level. So let's walk through a demonstration in order to see the handler exception resolver interface in action. The first thing we need to do is navigate to the Package Explorer, and within the Package Explorer, we're going to build a new package, and I'm simply going to call this package Handlers. Once the new package is in place, I'm going to create a new class. We're going to name this class Global Handler Exception Resolver. And then we need to make sure our new class extends the Handler Exception Resolver interface. So we can pull up that interface and hit OK, and then hit Finish to build out our new class. The first thing I want to do is annotate it with the component annotation so that it is picked up during component scanning and registered within Spring's IOC container and available for use. Now, if we further look at this class, we're going to see the resolve exception method that we need to override. It accepts 4 arguments, the first being the HTTP servlet request, the second the HTTP servlet response, the third is the actual handler, and then the fourth is the exception that's thrown. You'll also notice that this method returns a model and view, and that's going to be the model and view that we provide in response to the exception that we're handling. So let's build out the implementation of this method. So within its body, I'm going to declare a new object of type model and view, and I'll simply name it MAV. and then I'm going to use the new operator and the constructor to create that object. Now, what we can do with the model and view object is invoke its setViewName method. And here we can simply supply a view that we would like to be rendered. Specifically for this demonstration, I have built the global_error.jsp page. And it's just used to display a message that says basically an error was encountered and handled by a global exception handler resolver. We're going to display this view when we handle an exception at a global level. So all we need to do is provide the view name, and then the existing view resolvers will know how to route to that view. Finally, we just need to make sure that we return our model and view from our resolve exception method within our handler exception resolver. We have the handler exception resolver in place. Let's head over to our resource controller because we're going to run into a small issue. You can see that we have the handle error method established, and it has been annotated with the exception handler annotation. Currently, this is going to catch every exception. Now, because this is local to the controller, it's going to override any of the global exception handling we put in place because the local exception handlers are going to take precedent. We're going to change this mapping. So instead of resolving the very generic exception class and handling it here, we're going to change this to a null pointer exception, making it very specific so that within our demonstration, we're going to pass the exception that we throw here up to our global handler exception resolver. Let's save all of our work, and we're going to launch our application. And once we see the application take off, we're going to navigate to the resources add item on our menu, and this is going to cause the handler exception resolver to handle our exception at a global level. There you can see we displayed the view that we mapped to within our exception handler resolver. This was all possible thanks to the interface that Spring has provided. The handler exception resolver that we've put in place will be applicable to every controller. If we were to throw an exception, let's say within our project controller, it would also be handled using this approach. The title of our next chapter is View Resolution, so we're going to be looking at how we display views within Spring MVC. When processing a request, the framework will route the request to a controller method based upon some mapping. After that controller method has performed its logic, it usually returns a logical view name for the framework to resolve to an appropriate view. So I want to cover a few important points prior to looking at our chapter objectives. The first point is that views within Spring MVC are resolved using a view resolver. Both the view and the view resolver exist as interfaces within Spring MVC, and you'll find many implementations of the view resolver and the view interface. And using those different implementations, there's a wide range of views that we can display to the user. So we may be able to display a JSP that is rendered in response to a request, or maybe we'll display a PDF, or maybe we'll just spit back an object in JSON. So there's a variety of formats that Spring MVC can render in response to a request we receive. And loosely, we refer to all of these responses and their renderings as views. We've already seen a lot of this in action, having registered an internal resource view resolver to resolve our logical view names to our JSP files within our webinf directory. Within this chapter, we're going to take a look at a variety of topics that kind of surround view resolution. So we're going to go beyond that internal resource view resolver, which in most cases will handle about 80% of our workload. but you may encounter some situations where you need to perform a little bit more complex logic or have a little bit more of a complex configuration to handle view resolution. So that really leads into our objectives for this chapter. We're going to take a look at how we can register multiple view resolvers within our configuration file and order them. So there will be a precedence assigned to multiple view resolvers, and depending upon that precedence and what we receive as a logical view name, we will then render the appropriate view using one of those view resolvers. So in this scenario, we're going to take a look at the XML-based view resolver, and we'll see a different approach to resolving a logical view name to one of our resources that we would like to render as a view. We're also going to take a look at how resources can be presented as different formats. So one of the traps we want to avoid falling into is thinking that every view is like a JSP file, an HTML file, or a PDF. Those very graphic type of views that we present to the user. Because you can also return to the user something like JSON or XML, maybe in sort of like a REST API sort of situation, or even if you're just responding to an AJAX request that just needs some data and really doesn't need all that presentation surrounding it. I would consider the XML and JSON to also be a view, just a little bit more rougher of a format. And Spring MVC allows us to perform content negotiation. So this is a really neat part of the framework. It's a little bit complex, but it's going to look at the accept header on a request. So it's going to look at the content type that request is willing to accept, or it will look at a certain prefix on the request. So let's say I have a project and then I have .json after it. It's going to take that .json piece and it's going to know how to resolve our view based upon a particular content type. So it's going to see maybe that accept header has XML in it, and it's going to actually return then the content for a particular resource, so something like one of our objects in that format. You'll see the demonstrations we walk through in this chapter, and it's very flexible, especially for resolving multiple requests with multiple formats. And then finally, we're going to look at a variety of tools offered by the framework for processing form requests using the post redirect get pattern. So post redirect get is a very common pattern that you'll see put in place when we are handling input from the client side. So you'll post a form, so that's the post piece, and once we receive that request, we perform whatever logic in the controller, and then we actually send back to the browser a redirect. So I believe it's a 302 or a 301 code on that redirect, and that tells the client or the browser that it needs to perform a GET request to a particular URL. There's a lot of benefit to this because it's going to avoid things like double posting in a form. If you're not familiar with post redirect get, take a minute to just run a quick Google search on this and you'll pick up the concept of it very quickly. But if you're a seasoned web application developer, this is going to look pretty familiar to you. But the neat thing is, this common problem that we all face has really been supplemented by a number of tools that Spring MVC provides to allow us to transfer information kind of between the post and the get pieces of this. So we're going to take a look at two approaches there, RedirectAttributes and FlashAttributes, that really assist us when handling that post redirect get pattern. So this is going to be an exciting chapter. It's going to really tie together a lot of the things and the complications that you might see when resolving views.
In this lesson, we'll learn how to chain multiple view resolvers within Spring MVC. You will remember that view resolvers provide a mapping between view names and the actual views that are rendered. By configuring multiple view resolvers, Spring MVC allows us to combine several technologies and strategies for providing views to the end user of an application. The first thing we'll need to do is add some additional configuration to our application. So I'm going to create a new class, and I'm going to name this class Web Configuration. I'm going to annotate this class with the configuration annotation. That way it gets picked up and we can declare beans on this class.
we're going to establish a new method that returns a type of ViewResolver, and I'm going to name this method Resource Bundle ViewResolver. And that's because within this class, we're actually going to build a Resource Bundle ViewResolver. Before we do that, though, we want to add the bean annotation to the method, and now we can start working on building out that ViewResolver. So the Resource Bundle ViewResolver type can be used to create a new object, and I'm just going to name it ViewResolver, and we'll import that type and then use the new operator and the constructor to build our Resource Bundle ViewResolver object. Now, on the ViewResolver, what we can do is set the base name, and we're going to set the base name to views. Basically, this base name identifies a properties file on the class path we will use for view resolution. The next thing I'm going to do is on the ViewResolver, I'm going to set the order. So when we have multiple ViewResolvers in place, we can define their order so that when Spring MVC's dispatcher servlet is trying to map a view name to an actual view, it knows what order to consult these ViewResolvers. In this case, we're placing this ViewResolver first. And then from here, it's pretty simple. We're in the home stretch. We just return the ViewResolver. Now, I mentioned we need to build out our resource bundle that corresponds with this base name we set of views. So I'm going to return to our package explorer, and within the source main resources directory, I'm going to create a new file, and I'm going to name it views.properties. Within this file is where we provide our mappings. So what we're going to be doing is creating an alternate route for our home mapping. So let's go take a look at that. If we inspect our main controller, you see that we have /home, and then the base of that path is mapped to display the home view. So when the dispatcher servlet tries to resolve the view with the name home, we want it to be able to consult our resource bundle here. And the way we instruct it to perform the mapping is first by specifying the view name, and then we need to provide the class that we would like to use to display this view. So make sure you put class in parentheses. It's a little bit of an odd syntax. And then we need to provide the fully qualified name of the class we would like to use in order to display our view. So you want to be very careful here because it's not strongly typed. You're not going to get any sort of compilation error if this class name is off. So just take a minute, make sure you have everything spelled correctly. We're using the org.springframework.web.servlet.view.jstl Once we have that established, we need to provide a mapping that points to the actual view that we want to display. And you'll notice that within our project, I've built out another JSP, other_home.jsp. It's just a simple view that says this view was prevented by the resource bundle ViewResolver, just to indicate that we did use that ViewResolver. It's located within the webinf views directory, so it can be found sitting right next to what was formerly home.jsp. So we're going to map to that view and display it instead of home.jsp when we are performing view resolution using our new resource bundle ViewResolver. So what we'll do is just point to web-inf/views and then other_home.jsp. Once again, you want to check your mapping here. If this is incorrect, you're going to not render your view. The mapping's in place, and at this point, what we can do is restart our application, and we can test out our new ViewResolver.
So the first thing we'll do within our application is we'll go home. This should cause other_home.jsp to be rendered. And there we see the message. This view was presented by the resource bundle view resolver. Now, that was the only view we mapped. So when the dispatcher servlet can't find a view name within the resource bundle view resolver, it's going to then pass view resolution responsibilities off to the internal resource view resolver. So we can see that in action if we just go hit one of our normal pages. So we know that mapping to the project form was established via a URL-based view resolver, and that's with the request mappings we've established. In this lesson, we'll learn how to use a content negotiating view resolver to represent our model data via a variety of views. The content negotiating view resolver allows the client to specify or negotiate which representation of a view they would like to receive using a file extension in the URL. Let's run a demonstration to see the flexibility of the content negotiating view resolver. The first thing we'll do is inspect our project controller. And you'll notice on the project controller, there's been a new controller handler method added. That method is the findProjectObject method. It's annotated with response body, so we're going to directly write the content of the return value to the response. Now you'll notice we're returning a project object. So that object is going to be written or serialized within the body of the response. You'll notice we're mapping to /API / and then the project ID as a path variable. We're going to be invoking this controller handler method and getting a variety of representations of our project. We'll be able to see the project object within a JSON format and also an XML format. In order to support that, we need to add a dependency to our pom.xml file. We're going to use the Jackson data format -xml dependency. So we'll put that in place and save our POM, and then we can go ahead and close our POM file. Now, in order to be able to make this happen where we can display different representations of our project object, we need to add a content negotiating view resolver within our configuration. Now, luckily for us, Spring MVC provides us with a web MVC configurer adapter. This class is a way that we can easily customize Java-based configuration. So it's kind of a shortcut they provided so that we can quickly customize the configuration of a web application. If we look at the methods on this class, once we extend it, we can go into the source and then look for methods to override. And we are particularly interested in the configure view resolvers method. So we're going to select that method to override it. And within that method is where we will configure the content negotiating view resolver. So we get this view resolver registry, and within that registry, we're able to define some of the view resolvers we would like to use to render our views. The first one we're going to put in place is the JSP resolver, or the internal resource view resolver. So we just need to provide the prefix, which is going to be web inf /views / and then a suffix. So here we're just going to specify .jsp. So really, we're establishing the internal resource view resolver here in order to be able to display our JSP files. Now we're going to move on to the content negotiating view resolver. So you'll see the enable content negotiation method, and we're going to invoke that method and then supply it with the views that we would like to have available for content negotiation. So here's where that library we added comes in. We're going to use the mapping Jackson to XML view. So that's the view that will be able to display XML within our application. And then we're going to add a similar view, the mapping Jackson to JSON view. And that's going to allow us to render JSON from our application. That's all we need to configure our content negotiating view resolver. The configuration within Spring Boot and Java config is extremely simplified compared to XML config. With that in place, what we're going to do is restart our application. I'm going to go grab this mapping, and what we can do is go place that mapping within the destination bar in the browser. So here we can specify that we would like to view a project, and there you can see we're viewing project 1 and we're getting an XML representation. So that's the default representation, and I can switch that over to JSON, and you'll notice now I'm able to view the project object in the model in JSON. So if we navigate back to the home page, you're going to be able to do this with a variety of views now. So for example, when we view this JSP that displays all of our projects, if we were simply just to put .json after it, it's going to take all the model attributes that were supplied to this page and turn it to JSON. So using the content negotiating view resolver, we are able to get different representations of our view in multiple formats such as XML or JSON. You can even put things like PDF in place if required for your application.
One of the challenges that we face when building web applications is that when a form is submitted, a user can repost that form simply by pressing the F5 key or hitting refresh. Luckily for us, within Spring MVC, they have provided a redirect functionality that can actually perform an HTTP redirect that prevents a form from reposting. The redirect functionality can also navigate to another controller handler method based upon a URL that we provide. Taking a look at the project controller, you'll find the save project method. This is the handler method that handles the form post on the project form. You'll notice that at the bottom of this method, I've modified it to return the home view name. So we're going to display the home view when we post this form. So let's just go ahead, restart the app, navigate over to the browser, and load the project's form. And we can walk through and we'll add a simple project. I'm going to omit all the other fields except for the description because of the validation on it. And then I'm going to go ahead and post the form. We're going to get the home view rendered. And now I'm just going to hit F5. You'll notice that we get this warning that we're about ready to repost the form. We want to prevent that because it could result in persisting an object again. There's a lot of consequences to that. Let's talk about how we can avoid that. If we navigate back to the project controller, what we can do is add the redirect prefix, and now we need to specify a path to redirect to. In this case, we're going to redirect to /home/. And if we take a look at our main controller, you'll see that this will invoke the greeting handler method that renders the home view. So that's where we'll perform our redirect to, thanks to the redirect prefix we've established. So at this point, I'm going to go ahead and I can restart the application for these changes to take effect. Back in, projects add, and then just add a simple project once again. Then we'll provide a description, and then I'm going to post the form. And now I'm going to go ahead, hit the F5 key. You will notice that we did not get the message about reposting the form, so it prevents that from even occurring. We're also able, via this redirect method, as you've seen here with using the /home path, to navigate to other parts of our application. So for example, we have the project path on our controller, and then we are able to find all of our projects and go to the projects list. What I'm going to do is modify this redirect path in order to go to project, and then we're going to find all of the projects. So that will cause this controller handler method that is mapped to /find to be invoked. We're going to add all the projects to the model and then display the projects view. So let's just go ahead, restart the application. There it goes. We'll go back to the browser. We are going to then rebuild our simple project. I will now add the description, and then we're going to post the form, and we will be redirected to our projects page. I hit the F5 key, and there's no problems with a double post. Let's walk through that one more time, and we'll turn the networking on, and we'll take a look at what occurs network-wise. Going to add another description, and then I'm going to clear the networking, go ahead and submit the form, and you'll see that when we do the add, you get the 302 redirect. And that's exactly what we wanted, and it's thanks to that redirect prefix that we were able to include when we return our string from the Save Project Controller Handler method. When performing a redirect within a web application, it is often useful to send some data to the next controller method that will be handling the URL we are redirecting to. Within Spring MVC, we use RedirectAttributes to accomplish this. So let's walk through a demonstration. If we take a look at the Save Project method on our project controller, you'll see that we are posting to this method and we are data binding the project object. What we're going to do is first remove some of this validation just to simplify things, and then I'm going to modify the redirect to navigate to /home/. Now, within the body of this method, I'm going to first set the project ID, and I'll just set it to 55, just an arbitrary number. And then I'm going to use our project service to save the project. So we're just kind of persisting this project object within a data repository. The next thing we're going to do is add an argument to our controller handler method. So we're going to add an argument of type RedirectAttributes, and I'm going to name that argument attributes. There you can see we added the new argument to the signature of our method, and then we're going to use this object to add an attribute to the RedirectAttributes object. And it's very much like adding something to the model. We supply a name, so I'm going to call this the project ID, and then I'm going to grab the project object, get its project ID, and convert it to a string. When we invoke the Save Project method, we're basically going to mock persistence of the project object, store the project ID within our redirect attributes, and then perform a redirect to /home/. That redirect is going to be handled within our main controller. So the first thing we're going to do within this controller is we're going to create a field of type project service, and we're going to add the auto-wired annotation so that the Spring IOC container injects a project service bean into that field. The next thing that we need to do is declare a new method that returns a type string, and we're going to call this method goHomeAgain, and then we'll build the body of that method, And we're going to add a request mapping to this method. And first, we're going to supply the path, and it's simply going to be /. And then we're going to set the params element so that this method only gets invoked for requests that have a project ID parameter. Now, within this method, we're going to pass the model as an argument, and then we're also going to use the request param annotation to pull the project ID from the attribute supplied. And we're going to assign that to an argument of type long that is named project ID. And then what we'll do is we'll use the model to add an attribute, and the attribute is going to be named current project. And this is very similar to what we're doing within our greeting controller handler method, except that we're going to be pulling this project from our project service. So I'm just going to use the project service and its find method to grab the project by its ID. So we'll go ahead, import the request parameter annotation, and then finally, we need to tell it to display the home view. So we're going to be grabbing this project ID from the request attributes that are supplied from when we have invoked the save project controller handler method and then perform that redirect and have established our redirect attributes. Let's go ahead and relaunch our application, and then we're going to navigate to the browser, and we're going to head to the project's add form. So let's just create another simple project. The sponsor will be NASA, and we'll just provide a simple description. And from there, we're going to post the form, which will redirect to our home page. And you'll see that we were able to pass our redirect attribute, which was the project ID. You can actually see that on the URL here. And that was able to then be passed to our find method on the service. And that's how we get the project we just created to display on this form. In this lesson, we are going to learn about FlashAttributes within Spring MVC. FlashAttributes are a component that supports the post-redirect get pattern that applies when we do a redirect. First, let's walk through the post-redirect get pattern and then discuss how FlashAttributes fit into that picture. When we look at the save project method, you can see that we are redirecting to /home/, and then we're adding the redirect attributes via the attributes object. This causes a parameter to be added to the query string that we can then obtain within the method we're redirecting to. So that's the post-redirect get pattern. The problem here is we can make this much simpler. Why, instead of passing just the project ID, why don't we pass the actual project object? And that's where FlashAttributes come into the picture. We can go ahead and add the Flash attribute using the addFlashAttribute method. This method allows us to specify an attribute name, and I'm going to modify the name of the attribute to be just project. And then I'm only going to supply the project as the value of that Flash attribute. In this case, the Flash attribute is going to be wrote into session, and then when we invoke the go home again method, we are able to pull that session attribute out using a model attribute annotation on a method argument. So I'm going to add the model attribute annotation, and I'm going to supply the name of project, and then I'm going to switch over to an argument of type project named project. And then all we need to do is replace this call to the service with our project, and we can actually get rid of the service that we auto-wire. We're going to be pulling this object from the session attributes, and then after this controller handler method finishes its processing and returns the view, the project object will be taken out of session. That's why it's called a flash attribute. It's supporting the post redirect get pattern just in a different manner. We're using the session attributes on the server side for flash attributes, where when we use the redirect attributes, we are passing the parameter via the request. Now, the one thing that we have to be aware of here is we have created duplicate mappings because we're going to have to remove this params element from our annotation because we're no longer passing that. So at this point, the request matchings map. For our demonstration purposes, I'm just going to comment out the greeting method so that we don't have any complications there. Let's see this thing in action, and we'll step through the post redirect get pattern with flash attributes. So I'll navigate to the application. It's going to be a simple project. We'll put a number on there. We'll say the sponsor name will be the Olympics, and we'll add a description. This is another simple project. And then we're going to go ahead and post our form. And you'll notice that we were able to display the information about the project on the home view thanks to the flash attributes, allowing us to pull that project out from the session attributes stored by Spring MVC. In this chapter, we're going to cover a wide array of advanced components that are available for you within Spring MVC. These components may not be used in 100% of the projects that you will develop, but it is important to know these components so that when you encounter a use case, you don't try to reinvent the wheel and you rely upon a trusted Spring MVC component. So let's take a look at our chapter objectives, and the big one here is to learn how to customize that request processing lifecycle. And we're going to take a look at certain components within Spring MVC, such as interceptors, controller advice, converters, bean scopes, that really allow you to manipulate how request processing occurs. And this can be very beneficial to you because a lot of the times it saves you from doing unnecessary work. You'll see a lot of the times that there is a global approach to a problem that you could actually handle individually within each controller or each controller method. But using one of the components provided by Spring MVC, you're able to achieve a more simple, centralized approach to those types of problems. We'll also take a look at adding additional support for JSON. So we'll learn how we can use Jackson to help us. So we'll use Jackson in combination with the response body tag. And that provides for a very simple configuration that allows us to serve and accept JSON. And then finally, we'll take a look at how we can process file uploads. Spring MVC provides great support for uploading files. It makes it very simple, especially when you're in the Servlet 3.0 environment. So we'll take a look at how we can upload files to our Spring MVC applications. So after we're through in this chapter, you're going to have a good knowledge of some of the finer points of Spring MVC. In this lesson, we'll focus on handler interceptors and how they allow us to modify the request processing lifecycle within Spring MVC. Handler interceptors, or interceptors for short, are very powerful tools that allow us to add functionality to the request processing lifecycle at 3 different points. The first point is before a controller handles a request that has been mapped to a handler method. The second is after the handler method has finished performing its logic within that method. And the final point is once the view has been rendered and the response is about to be sent back to the client. Let's take a look at how we build and register an interceptor in a simple demonstration. We're going to start out by creating a new package, And I'm going to simply call this package interceptors. And we'll hit finish. We have our new package, and then I'm going to place a new class within it. The class we are going to create, I'm going to name Global Interceptor, and then we need to make sure our new class extends the Handler Interceptor Adapter superclass. So if we take a look once our class is built, we can see that the Handler Interceptor Adapter is an abstract class that extends an async handler interceptor, and eventually we get down to this handler interceptor interface that needs to be implemented by all interceptor classes. So I'll go ahead and close these classes. So if we take a look at the methods that you can override on this type, you will see that we are able to interject at certain points. So we have pre-handle, post-handle, and after completion, which are the main 3 points we can interject with our interceptor. We're going to focus mainly on pre-handle. So we'll go ahead and provide an implementation of that method. You'll notice that the pre-handle method accepts arguments of type HTTP servlet request, HTTP servlet response, and an object argument. That object argument, in this case the parameter named handler, is the actual controller method that will be invoked. So it's the controller handler method. You can use reflection within this method to do all sorts of inspection of your controller handler method to determine how you would like to perform your logic when intercepting a request in the request processing lifecycle. We are going to have very simple logic. I'm just going to grab the request, and on the request, we are going to use the setAttribute method. And we're going to set an attribute named current date, and then we're just going to assign this attribute the value of a current javautil.date object. What we'll do is grab this attribute name, and we're going to navigate to our header, and within the header, the last list item that we will provide is the current date attribute. So we're going to end up displaying the current date on our page. The view is now modified to display our attribute. We need to register our interceptor within the Spring IOC container so that it can take part within the request processing lifecycle. To do this, we need to work within a class that extends web MVC configure adapter. And once again, we're going to leverage the methods on that superclass by overriding them. And the method that we would like to override is the add interceptors method. And this is going to allow us to easily add our interceptor via Java configuration. We get the interceptor registry, and what we want to do is grab that registry, invoke the add interceptor method, and then we're going to establish a new instance of our global interceptor type. And then once that instance is established, we could leave it as is, and this would apply to every request coming in, but we also have the option of adding a path pattern, and this is just defining a URL pattern that we would like this interceptor to apply to. So this is a way to conditionally apply your interceptor. We are going to go ahead and only apply this to requests that contain /project/ within the URL path. And you'll notice here we're using ant style wildcards so that we would get not just the preceding part of the URL, but if there were other /, we would be fine here. With this in place, let's restart our application. The first place we're going to go is home. We do not expect to see the date displayed, and we don't. Now, if we go into projects, you'll notice that now the date gets displayed. And that's thanks to our handler interceptor providing that attribute that we're displaying on the view within the header. If you are familiar with Spring, you know that beans can have a variety of scopes. For example, within Spring Core, we are able to create beans with a prototype scope or a singleton scope. However, within Spring MVC, we add additional scopes because we are working with a web application. The additional scopes are the request scope, the session scope, and the application scope. In this lesson, we will run through a demonstration on how to use these different scopes. Within the Package Explorer, you'll see that I have created a hit counter class. The hit counter class has a field that's exposed through accessors, and that field is of type int. It's simply going to be incremented as different hits come into our pages. And then you see we provide some console output when the hit counter is instantiated. What we need to do in this class in order to scope it is add the scope annotation, and then once that annotation is added, we need to specify the scope name. And we can reference the scope name by using the web application context class, and on it we will find the scope underscore request field, and we can set our scope to the request scope that way. This will cause the hit counter bean to be scoped to every request that comes in. So there's going to be a thread associated with every request that comes in, and that's where our bean will be associated. The other thing that we need to do is we need to set the proxy mode element. To do that, we can use the scoped proxy mode class and then use the target underscore class. This is going to cause a proxy to be injected for the hit counter. Now, we are going to add the hit counter into the project controller, and we'll use that project controller to count the hits that come in to this specific controller. So we're just going to auto-wire the hit counter. And then what we can do is within our add method. So let's say we want to count all of the hits to the add project method. So we are simply going to use the hit counter, and we're going to invoke its set hit methods. And then we're just going to grab the number of hits and increment it by 1. And then we'll just output the number of hits to the console. We'll say something like the number of hits is, and then we'll grab the hit counter and get the hits. You see, we're just tracking the number of hits coming into the add project method. Let's restart the application and we can see things in action. First, I'm going to navigate to the project's add method. You'll see that our number of hits is 1. I'm going to navigate back into the form. You'll notice number of hits is 1. And that's because the hit counter is scoped to the request. So each request is a new request, and it's only going to record that 1 hit per request. Let's change this up a little bit. So we're going to navigate back to the hit counter, and we're just going to adjust the scope. So instead of request scope, we're going to move to session, restart the application, and now it should count more like we expect it to. So here we are, projects add. We counted 1 hit. We're going to count another here. We're up to 2. Now we are counting the hits per session. Let's say that we wanted to come in via another browser. Here I'm in Firefox, and you'll notice now we're back to 1 because that's a different session. And if I would come back in via Chrome and hit it, we're going to go to 3. And you can see how it's counting by session. And then let's just go one step further. If we wanted to scope this to the application, this will count every hit that comes in to that controller method, no matter whether it's in one session or the other. It's counting everything for the application because the bean is scoped to the app. So here we come in, we hit the page, we got one hit. I'm going to come in via another browser. We're going to get 2 hits. And there we see in our console, there's the second hit from the other browser, which came from a separate session. Spring MVC provides us with great support for JSON. If you've been building web applications, you know that more and more functionality is moving into the browser. As we move functionality to the browser, we are relying upon the server side to provide us with data in a JSON format to service our AJAX requests. So within Spring MVC, the Jackson library is leveraged to provide some great JSON support that is easy to configure. In this lesson, we'll run a demonstration that shows how we can quickly serve JSON from our Spring MVC controller handler methods. Let me walk you through a few changes I've made to the setup of our application. If you navigate into the application and hit the Resources Find option within the menu, you'll see that you're presented with a list of resources. These resources have hyperlinks established for them that are mapped to /resource/ and then the resource ID. What we're going to do is return JSON from these links. To do that, we're going to modify our resource controller. Within the resource controller, you'll notice that I've added a resource service type. And this is simply a mock service that can find a resource, and it can find all resources. Returning back to the controller, all we're going to do is establish a new controller handler method that is mapped to the /resource/ and then the resource ID as a path variable. And then we're going to add the response body annotation onto this method. And the method is going to return a type of resource, and we're going to name the method findResource, and then we're going to add the path variable, and we'll name the path variable resource ID, and then we're going to assign that path variable to an argument of type long that is named resource ID. And then within the body of this method, we're simply going to invoke the find method on the service and pass in our resource ID, and that will return the resource. And what you'll see is that we will render this resource within a JSON format. So I'm going to go ahead, restart the application, and now we can navigate to the resources find menu option. And now when I click on one of these resources, you'll notice that I get a JSON representation of that object. Some of this is thanks to Spring Boot. In the past, we needed to include some of the Jackson libraries. Those are pulled in by default by Spring Boot, so it reduces some of the configuration. And then it's really as simple as just annotating our method with the resource body annotation and making sure that we return an object, and that object will be serialized to JSON. In this lesson, we'll take a look at Spring MVC's controller advice annotation. Controller advice allows us to increase the reusability of a few of the handler methods that we can place on controllers. It allows us to specify exception handlers, init binders, and model attributes throughout all of our controllers by placing those definitions in a central class that applies to every controller. The first thing we'll need to do is create a new class within our controllers package. This class is going to be our controller advice, so we're going to name it Global Controller Advice.
and then simply hit the Finish button on the new dialog. And it's really easy to set one of these up. You just need to add the controller advice annotation and import it. And then you'll see within the annotation, there's the annotations element. And here we can specify what type of annotation this class will apply to. Here we are saying that we would like this global controller advice we're going to specify to apply to every controller. So classes like the project controller or the resource controller that are annotated with the controller annotation will be able to access all of the logic we place within this class. The first thing we mentioned that you can add into global controller advice is model attributes. So we're going to create a new handler method that's annotated with the model attribute, and we're going to name it current date and return a date from this method. And then for the model attribute, I'm going to set the name of the attribute to current date, and then we simply return a new date from this method. And what we're doing here is actually replacing some of the logic that is established within our global interceptor. So you can see within the global interceptor, we are adding this current date attribute to every field. We're just going to remove that from the interceptor, and we can go ahead and handle that within our controller advice. Now, I also mentioned that we can place init binder methods within our controller advice. So let's go take a look at the project controller, because within this controller, we do have an init binder method that adds a validator for the project model attribute. And we're just going to move that to a global level so that it's established within our controller advice and available for all controllers. And then finally, we can add exception handlers into our controller advice. So if we take a look at our resource controller, you'll notice that we have an exception handler at the top of this class. I'm going to pull that out. And then what I'm also going to do is throw a new null pointer exception from the find method. So we have some testing fodder here to work with. So throw new null pointer exception, and we'll use that method to test out the exception handler that we're going to place within our controller advice. There you see it. We have a controller advice class annotated with the controller advice annotation. It's able to provide model attributes, init binders, and exception handlers to every controller. If we restart our application, we can begin to walk through this demonstration. I'm going to navigate to the browser now. The first thing we're going to do is navigate to the add form. You'll notice there's our current date displayed, and I'm going to submit the project form. You'll notice our validator worked, and now let's go find a resource, and we should have gotten an error. In this lesson, we are going to discuss converters and how they can help us when data binding within Spring MVC. So when data binding, it's pretty cut and dry when you are dealing with primitive data types such as int, long, or simple types such as string. However, when using custom types, it's more complex, and we need to instruct Spring MVC on how to perform conversion to an appropriate type. All of the request parameters that get passed to a controller handler method are basically strings. So when we provide a name, that request parameter is going to be a string that goes back to the controller handler method. If we take a closer look at our form, you'll see that we have added the start date field, which is specified as a Julian date. Navigating to our project object, you'll see that we have added a field for start date, and the field is of type date. So the question is, how are we going to take that string containing the Julian date and convert it into an actual date object? And the answer is we're going to use a converter provided by Spring MVC.
we're going to first create a new package within the com.O'Reilly package, and I'm simply going to call this package converters. And then inside of this package, we're going to create a new class. The new class will be named Julian Date Converter, and we're going to make this class extend the converter interface. Make sure you choose the org.springframework.core.convert.converters package. And on that interface, we need to specify the type we will be converting from, and then the type we will be converting to. So we're going to convert from a string to a date. And once we provide that information, you'll see that our class is built and we're able to implement the convert method. So the convert method is going to be responsible for taking our string to a date object. What I'm going to do within the body of this method is just provide some output, converting to a date from a string, so we can see that it gets invoked. And then the next thing we'll do is we'll declare a date object, assign it to null, and then we're going to assign the date object to the result of using a simple date formatter, and we're going to specify the Julian date format, and then we're going to invoke the parse method and pass in our date string, and then we're going to have to wrap this in a try-catch, and then we'll simply return the date from this method. There's our converter. We have that in place. Let's now grab this class name, and we're going to navigate to our web configuration class where we will register the converter. With Spring MVC's Java config, this has become much easier. So you just need to override a method on the web MVC configure adapter class. And we can do that by going to source and then override or implement methods. And you want to select the add formatters method to be overridden. And within this method, we're going to do a few things. The first thing, grab the registry and use the add converter method. And then we specify a new converter of type Julian date. And actually, that's it. At this point, we have registered our converter with the Spring IOC container. And what will happen when performing data binding? Data binding will look at the project. It's going to match up the request parameter and the field names. And then it's going to say, hey, I need to convert from a string to a date. And it's going to see if it has any converters that can perform that conversion. Luckily for us, we created our Julian date converter, and that will be used. So let's restart our application, and we can walk through a simple example. There's some console output within the save method of our project controller that's going to help us see this process in action. So we're just going to start filling out the form. We need to have a name for a project. We have to provide a description. And then here's our Julian date. So I'm going to say the 111th day of 2017. And now if I submit the form, we can go look at our console output. And there we see that we invoked our converter method, and Spring MVC took care of that during data binding. And then if we look at the project class, we'll see that start date has been assigned to April 21st. So the 111th day of the year must be April 21st. We have seen how to use converters to assist with data binding. In this lesson, we'll take a look at converters from another angle. We'll see another area of Spring MVC where the converters are consulted in order to turn something like a string data type into one of the objects within our application. If we navigate to the Resources Find menu option we are going to see a list of our resources. If we click on one of the hyperlinks in the name column, you'll notice the URL that we consult is /resource and then /the resource ID. If we navigate to our resource controller, you'll find that this mapping will invoke the findResourceController handler method. The path variable is extracted from the URL, and then we use that path variable to consult our service and invoke its find method in order to retrieve a resource. It can be a lot easier than that. I'm simply going to switch the parameter type over to a type of resource, and then I'm going to just return the resource from this method. At this point, what will happen is Spring MVC will realize it needs to turn a string into a resource, and it's going to consult the converters that we have within the system. So what we're going to do next is build out a new converter. So I'm going to create a new class in the converters package, and it's going to be the resource converter. And this converter class needs to extend or implement the converter interface. We're going to convert from a type of string to a type of resource. So we provide the generic type arguments. And now once we're in the class, we can go ahead and import our types. And then we're going to add the method we'd like to override. And this is the convert method, where we will convert the string to the resource. To help us out here, we're going to auto-wire the resource service. So I'm going to add the service as a field within the class that's auto-wired. And then it's pretty simple. We're just going to use the service. We're going to invoke the find method, and we're going to turn that string into a long and pass it into the find method. The other thing we're going to do is add the component annotation to our resource converter. And that's going to allow us to auto-wire the resource service. We're going to register this a little bit differently than the last converter. So within the web configuration class, we have our handy add formatters method that allows us to add our converters. But what we're going to do is within this class, we are actually going to auto-wire the resource converter. So I will declare a new field, and I'll name it resource converter, and it's of type resource converter. And then what we can do is grab this new field, which is our converter, and then I'm going to invoke the add converter method on the registry. And from there, that will register the converter so that we can convert strings to a type of resource. So with that in place, let's go ahead and restart our application. There it went. So let's go into our form. We will find the resources. Let's go in, get a coder. And there you can see that we were able to return the resource object, which got converted to a string thanks to our Jackson support. The capability to upload a file is pretty common within web applications. And within Spring MVC, you will find some great support that will assist you with handling file uploads. Spring MVC support for file uploads centers around a multi-part view resolver. The multi-part view resolver parses multi-part requests such as file uploads. Thanks to Spring Boot, we don't even need to touch this resolver because it's configured by default. Let's run through a quick demonstration to see how easy it is to support file upload within Spring MVC. We're going to start by looking at our resource_add.jsp. So this is the resource form, and it's where we're going to perform the file upload. You'll notice that I've added a new form to the page, and this form will perform a post to /resource/upload. The encoding type on the form has been set to multi-part /form-data. And this is important because it's necessary when uploading files. Within the form, we have a file upload input that will allow us to select the file, and then we can click on our upload button to upload it. With the form being prepared, all we need to do, thanks to the configuration Spring Boot has put in place, is provide a handler method on our controller. So we're going to build out a new handler method that returns a string, and I'm going to name it handleUpload. And we're going to start by annotating this method with the request mapping annotation. And we're going to specify that it is mapped to /resource/upload. And then we're going to use the method element to indicate that this handler method only handles post requests. Next, we're going to annotate this method with the response body annotation because we're going to provide the response directly within the controller. Next, we need to add the request param annotation to a method argument of type multi-part file, and we're going to name that argument file. Then we're going to specify that the parameter is file because that matches the parameter that we placed on our file upload input. With that in place, we are able to use the multi-part file type to check if the file is empty. And if the file is not empty, what we're going to do is just return that the file size is, and then we're going to read the size of the file. And if the file would be empty, we're just going to return the file is empty. So you can see how easily we can upload a file within Spring MVC. Basically, we are relying upon the multi-part resolver to data bind the file that's uploaded to the multi-part file argument that we are passing into our controller. So you can think of this just like data binding, except with a more complex type because we are working with a file now. So let me go ahead and let's run through a demonstration. I just restarted the application, and now we're going to navigate to the resource form, and at the bottom of the form, we're going to see the controls. So we're going to choose a file. So let's just grab this link to Safari and open it. And you can see that the name of the file is displayed. And then I'm going to upload the file, and it tells us that it is 44 kilobytes. All of this took place thanks to Spring MVC's support for file uploads via its multi-part resolver. The Web Security Features chapter focuses on how Spring MVC can be used to secure web applications in two specific areas. In the chapter, we'll do a deep dive on enabling cross-origin resource sharing, or CORS, and preventing cross-site request forgery attacks, or CSRF attacks. These two security features are just a subset of those found within the Spring ecosystem. However, to keep our course focused on MVC, other security topics are left to be covered in a full-blown course on Spring Security. So let's take a quick look at our chapter. As I mentioned, we'll focus on enabling cross-origin resource sharing, which is a mechanism that allows a browser to access resources on a different domain than the site was hosted from. This topic is very important given the popularity of APIs and content delivery networks. Then we'll move on to talk about how to prevent cross-site request forgery, which allows a malicious site to leverage authentication that was performed with a valid site. So that we have a good foundation, I'm going to go into these topics in more detail. Cross-origin resource sharing allows legitimate interactions to be exchanged between a server and its known clients. Under normal conditions, browsers enforce the same origin policy which is a security concept used by browsers to prevent requests from being made from one domain to another. The trouble is that sometimes sending requests from one domain or origin to another is a valid capability. CORS allows us to specify what traffic is permissible cross-origin and what is not. If you take a look at our diagram, you will see the somedomain.com domain has rendered a page that would like to access resources on the manage.com domain. The manage.com domain hosts our project management application that we've been building throughout the course. When the request is a post or is modifying data, we will see a pre-flight request exchanged between the browser and the target domain, in this case manage.com. Manage.com will respond with a pre-flight response that indicates the types of methods that can be used to make requests to that server from somedomain.com. The browser will then inspect those methods, and if permissible, it will allow somedomain.com to make the actual request against manage.com, and then manage.com will respond with the actual response. If somedomain.com is not included or whitelisted on manage.com, the request will not go through. We'll see in this chapter how Spring MVC facilitates this type of CORS configuration between servers. Next, I'm going to walk through cross-site request forgery. Cross-site request forgery is an attack where a user is forced to submit a request to a site they are currently authenticated to by a malicious site they've visited. The malicious site attempts to leverage the authentication cookies that were used to access the legitimate site. Imagine you sign into your bank. So here we go to bank.com and we're doing some online banking. In another tab, I then open up hack.com. Now, hack.com is a malicious site, and it actually has a form on it that causes me to perform a post to bank.com that initiates a transfer. What will happen is that my authentication cookie can be sent from hack.com to bank.com, and that can initiate a transfer because it's leveraging my authentication cookies. Spring MVC can prevent all of this with its CSRF token that protects us against cross-site request forgery. We will also learn how to put this in place throughout the chapter. In this lesson, we're going to install two Postman extensions into our Chrome browser. If you're not familiar with Postman, it's a tool to construct HTTP requests to test APIs or web applications. We'll be using Postman to work through several of our demonstrations. All you need to do is click on the options and then go to More Tools and Extensions. If you're using another major browser, you'll just need to navigate into your extension manager. I have for Chrome here, and all the way at the bottom, you'll see the Get More Extensions link, and that's going to open the Chrome Web Store. We're simply going to search for Postman, and this will bring up the Postman interceptor. We want to go ahead and add that to Chrome, confirm we want to add the extension, and then you'll see we get this new icon. If we click that icon, we can access the Postman Chrome app. Since I don't have it installed, it's going to take me to the Chrome Web Store and allow me to add it to Chrome. I'll have to confirm I want to add the app once again, and then it will begin to install. Once installed, it will display within my Chrome apps, and I can go ahead and launch it. Now, as it's launching, I'm going to go ahead and just size it up. You'll see within the sign-in screen, there's several options. Right now, they want us to register for a new account. You can sign up with Google. It's probably the quickest way. I've already done that, so I'm just going to sign in and then sign in with Google. And I can just select my account, provide my password, and I'm good to go. Here you see Postman, and we can use Postman to construct HTTP request, you'll see a variety of request types that we can build, and we can also add headers. And when doing something like a post, we can add parameters to the body of that post to mimic like a form post. We can even use things like Ajax. There's all sorts of options with Postman. It's an excellent tool for testing an API or a web app. Now that we have the app installed, we can use it within our demonstrations. In this lesson, we'll learn to configure cross-origin resource sharing, or CORS, at a global level within our Spring MVC applications. Thanks to Spring MVC's handler mappings built-in support for CORS, configuration of CORS at a global level is a breeze. Handler mappings, which help map requests to handler methods, have baked-in support to restrict requests that originate from other origins or domains. Let's take a look within a simple demonstration at how to configure CORS support at a global level. The first thing that we're going to do is navigate to the Postman app, and I'm going to enable the interceptor using this icon at the top of the screen. Then I'm going to construct a request that hits localhost on port 8080, and it's going to be mapped to /app/project/API, and then our project ID of 1. So if we take a look within our project controller, you'll see that we are invoking the findProjectObject method. So here is the controller handler method that handles this request. It returns a project that's going to show up in a JSON notation. If we fire off this request within Postman, we get the project object back that corresponds with the project ID 1. You'll notice that we were able to run this request, and we can even run it from another origin by adding the origin header. We're just going to make up a domain here. So we're going to say this request is coming from http://somedomain.com. And you'll see it is successful. The reason these requests are successful is by default, Spring MVC's support for CORS allows all origins, and the get, head, and post methods are all allowed by default. We're going to go ahead and lock this down now. And the way we do that is by modifying our web configuration class, which extends the web MVC configure adapter class. On that class are a number of methods that we can override in order to dictate the configuration of our Spring MVC application. So if we right-click, go to Source, and then override implement methods, we see a list of those methods. We are interested in the add CORS mappings method, so we'll just select that method by clicking the checkbox and then hit OK. This adds the method to our class, and we can modify it. So I'm going to go ahead, remove the calls to super, and then I'm going to work with the registry object, and you'll see it's of type CORS registry, and it provides us with the add mapping method. So the add mapping method allows us to specify all of the requests this CORS configuration will apply to. In this case, we are specifying every request within the application. And then what we're going to do is set the allowed methods to basically an empty string. So we're saying we do not want to allow any cross-origin resource sharing for other domains. We don't want to allow them to be able to send any requests for any method. Let's restart our application. And the first thing I want to show you is that the web app is not impacted because all of these requests originate from localhost on port 8080. And that's the origin that our application is requesting from. Now, if we go over and specify that we are coming from
a different domain, so http://somedomain.com, you'll see that CORS stops that request. And that's because of the CORS support in Spring MVC prohibiting it. In fact, you'll see we get a 403 forbidden status back. What we can do in order to allow requests from some domain is go in to our configuration, and we're going to modify it by adding the allowed origins, and we do that via a method on the CORS registry. And here we just provide a string specifying those origins we'd like to allow. So we're going to add somedomain.com to the allowed origin. From there, we can specify that for this origin, all methods are allowed. Now we could list out something like post, get, put, but it's much easier if we want to allow all methods to just provide an asterisk within the allowed methods method as an argument. And now if we navigate to Postman, we can run this request and replay it. Now we want to make sure that our origins match up, so I'm going to go ahead and remove that / because it's not specified here. Once we replay that message, you can see we now get the project because our CORS configuration allowed it. If we were to come from some other domain, and this origin parameter or header is going to be added by the browser, so it's not like we're going to have this sort of control over it when navigating in the page. But let's say we're coming from otherdomain.com, you see that our CORS configuration rejects it. We're able to configure the allowable domains using Spring MVC's CORS support. Another option we have is to fire off an options request against Spring MVC. And you'll notice we didn't get anything back because our controller handler method doesn't support the options type of request. But if we look at these headers, it does provide us information. This is normally called a pre-flight request. And you can see that it tells us that somedomain.com is allowed to perform these requests against our Spring MVC application. So it provides the browser with information about what that domain is allowed to do. Spring MVC allows us to configure CORS at both the global level and at the controller level. In this lesson, we'll see how to provide more specific CORS configuration within our controllers using the cross-origin annotation. The cross-origin annotation allows us to provide that more granular configuration for CORS within our controllers at both the class and method levels. Within our project controller, we're going to apply the cross-origin annotation at the class declaration for the project controller class. So we'll go ahead, import the annotation, and then we'll take a look at the elements on the annotation. You'll see that we are able to restrict methods that can be used when we fire off the request. We can also restrict the origins or domains that can access the handler methods on this controller. There's also elements to specify a max age, so how long this information will be retained at the browser in order to reduce pre-flight requests. For this first demonstration, we're going to stick to specifying the origins annotation, and we're simply going to specify that otherdomain.com can access any controller handler method. So with that configuration in place, I'll go ahead and restart the application, and then I'm going to navigate to Postman. Right now, we're configured to fire off a get against the /app/project/API/1 URL. If we take a look, that will map to the find project object method, and that's going to cause a project to be returned in a JSON format.
So if I fire off this request from somedomain.com in Postman, you'll notice we are able to access controller handler methods on the project controller that has the cross-origin annotation. And that's because we have our global configuration in place. So global configuration and more granular configuration do work in tandem. If we return to Postman and we specify otherdomain.com, you'll notice that we can successfully complete that request as well. And then let's switch it up to anotherdomain.com, and this will reject. So we were unable to process the request because of our course configuration. Now let's navigate back to the project controller, and we're going to duplicate the cross-origin annotation, and now we're going to apply it at the find project object method level. And what we'll do is we'll switch it up to allow anotherdomain.com to access this method. And then we're going to specify that you must use a post request in order to access this method. And we do that by setting the methods elements on the cross-origin annotation. So with that in place, I'm going to restart our application and we can take a look at the behavior. So we're going to head over to Postman, and the first thing I'm going to do actually is fire off this request as a get from anotherdomain.com. You'll notice it fails. You'll also notice that a get request from somedomain.com fails. So because of the cross-origin annotation, we need to be using a post. So I'm going to switch over to a post and first send the request from anotherdomain.com. It was successful. And then you'll notice using a post, somedomain.com is also successful, as well as otherdomain.com. You need to be aware of the impact of adding the cross-origin annotation and specifying these different elements when you're configuring cores for your Spring MVC applications. In this lesson, we are going to talk about how to protect our applications from cross-site request forgery. A cross-site request forgery attack, or CSRF attack, occurs when we are logged into a legitimate application on the web and then visit a malicious site. The malicious site submits a request to the legitimate site in an attempt to leverage our session ID to gain access to the legitimate site. Normally, that request will be executed transparently via a script that will attempt to do something malicious on the legitimate site. Luckily for us, Spring Security provides a CSRF token that can be added to our Spring MVC applications. In order to get started, we're going to need to include a dependency within our pom.xml file. So simply navigate to the pom, hit add, and then we're going to look within the org.springframework.boot group ID. And within this group, we're going to find the starter POMs, and we are looking for the security starter. So if we scroll down, there is the spring-boot-starter-security artifact, and we can go ahead and include that within our POM in order to pull the appropriate libraries into our application. Next, we're going to navigate to the Spring MVC boot application, and we're going to add the Enable Web Security annotation, and this will apply a bunch of security by default thanks to Spring Boot. At this point, we restart our application, and then we navigate to a browser. We can access the application, and you'll notice that we are prompted for a password. This is because of the default configuration by Spring Boot. We can go ahead and enter a password, or if we would like, we can disable the authentication requirements. So what I can do is create a new class, and I'm going to name this class Web Security Configuration. And we're going to make this class extend the Web Security Configure adapter provided by Spring. And this is another one of those classes where you can just override methods in order to provide configuration. We're going to annotate this class with the configuration annotation. And then we are going to override the configure method that accepts an argument of type HTTP security. So with that method in place, we can go ahead and disable the HTTP authorization that's required. So we're just going to authorize any request and permit any request to be accessed by everyone. So this is not related to the CSRF token, but it will allow us to access the application now if we restart it. So once we restart the application, we can now navigate to our home page, and you'll see we can access the application. Now here's where the CSRF token comes into play. If you'll notice on our project's form, if we inspect the form using the developer tools within Chrome, we're going to find a special div that's been added that has our CSRF token. So let's talk a little bit about how the CSRF protection works with Spring MVC. It uses a synchronizer token pattern. Basically, each request is going to have this unique ID or hash associated with it. And that's going to be known to and expected by the server. And if the server does not identify this token, it's not going to accept the request and it's going to treat it as malicious. In the scenario we described earlier, the malicious website would not have the CSRF token because the site would not have been rendered by our application. So it wouldn't have had this token embedded within this form. And you'll notice that if we were to fire off this request, so let's go to the Network tab, I'm going to submit this request, and if we take a look, you'll see that the CSRF token is added as a parameter on this request going back to the server. This is all made possible by the form tag. So if we take a look at our project add.jsp page, anytime we use Spring Security with the Spring form tag library, it will embed the CSRF token within our forms by default. So if we look at the bottom of our form, it's not like I had to explicitly define that CSRF token. It was just added to the form by default when our Spring MVC application rendered the view for the project's add form. In the Spring MVC testing chapter, we'll focus on strategies for constructing unit tests of Spring MVC applications. These strategies allow us to establish tests that ensure the quality of our applications while being mindful of the resources consumed by the tests. The features we'll discuss in this chapter will provide all of the tools required to perform test-driven development. Within the Spring ecosystem, we'll find several projects that leverage Spring's dependency injection for testing purposes, primarily Spring Test and Spring Boot. Within the Spring Test project, there is specific support for testing web applications in the Spring MVC Test framework. This framework provides resources for integrating the Spring IOC container with JUnit and mocking key dependencies needed for running tests. For the most part, the Spring MVC test framework aims to eliminate the dependency on the servlet container. Instead, it mocks key container objects. Spring Boot provides additional support for testing, which is necessary for testing boot applications quickly. It further promotes Boot's principle of convention over configuration and allows you to quickly establish tests with minimal configuration. We'll mix and match features from these projects to provide a good overview of the available options for testing Spring MVC applications. The primary goal in this chapter is to learn several strategies that are made possible for testing by the Spring ecosystem. So we'll see how to configure a simple test case and run the tests within it. We'll look at this test REST template object, which can be used to send requests for processing by our dispatcher servlet, and see how it supports testing by allowing us to perform things like assertions. We'll also see the Fluent API provided by Spring Tests that provides us an alternate way to send requests to the dispatcher servlet when mocking some web infrastructure. As we work through our demonstrations, we'll also be running with different test configurations. In some cases, we'll be running against the actual server and its full stack. In other cases, we'll configure Spring Tests to mock key servlet container components, reducing the resource expense of running our tests and relying solely on the Spring IOC context. From there, we'll even see how to limit the context to a specific set of beans necessary for our test, further reducing resource consumption. By the end of this chapter, you will have a firm grasp on how to build unit tests to ensure the quality of your Spring MVC applications. In this lesson, we will learn how to configure Spring Test MVC to test web applications built with Spring MVC. Thanks to Spring Boot, configuration of Spring Test is extremely simple. Using Boot configuration, we can quickly begin testing our web application by performing requests and generating responses through the dispatcher servlet that tests our controllers. By automating these quality assurance tests with JUnit, we can ensure that our controllers are properly handling requests. Let's walk through configuring a test that leverages the full servlet container for testing within Spring Test MVC. We're going to open the pom.xml file, and we just want to ensure that we have the appropriate dependencies in place. I see that the spring-boot-starter-test dependency has been included. This dependency is included with every Spring Boot project. If for some reason it were not to be there, you would need to add this dependency through the Add button on this page. Since it's there, we're just going to continue with configuration. So I'll go ahead and close the POM file. Then we're going to navigate to the source test Java source folder. And within this source folder, we're going to create a new JUnit test case. So we can name our test case the full stack tests. And that's because the tests we're going to run will leverage the full servlet container and the full Spring IOC container. Sometimes we may run tests that do not implement the entire stack in order to save some time or to increase performance. These, however, are going to perform a very thorough test with the full servlet container and IOC container. We can go ahead and build out our class, and then we need to add JUnit's run with annotation and specify our class runner, which is the springrunner.class. And this will allow us to use Spring within JUnit. The next thing we need to do is add the Spring Boot test annotation to our class. Let's talk a little bit about this annotation. It's used for preparing test cases or test classes within a Spring Boot application. Normally, we are accustomed to using something like a context configuration annotation or a configuration class on our tests in order to establish our context. Using the Spring Boot test annotation causes Spring Boot to use a search algorithm that looks for classes annotated with the Spring Boot application annotation. And when it finds them, it instantiates and builds out the context associated with that class and that application. Spring Boot is going to start testing our package structure to find our main class, which is the Spring MVC boot application. And from here, it's going to identify that this class is annotated with Spring Boot Applications annotation and determine that it needs to build the context from this app. And that's how we're going to be able to perform things like dependency injection within this test class. So what I'm going to do is add the project service, because that is a bean that we do declare within our IOC container. And then within our test case, we're simply going to assert that the project service is not equal to null. And that's going to be our simple test that we've established. Primarily, we were focused on the configuration here. So now we can save our test class. And then if we right click on the class, we can go to Run As and then JUnit Test to initiate our test case. There you see Spring Boot kicking off and launching the servlet container. You'll see that our test runs and passes. So it was a very simple test, but it did show, if we take a look at the console, that we are establishing our Spring MVC application and building out the context associated with that application. And then if we look at our test itself, you can see we're able to inject beans that were declared and instantiated within that IOC container. When we run a test that uses the full server, we have that entire context available for testing. And this is an extremely thorough way to ensure our application's controllers are performing the behavior they should when invoked. In this lesson, we will learn how to use Spring Boot's test REST template to test controller handler methods within our Spring MVC application. Using the test REST template, we will be able to perform requests and inspect responses sent through our dispatcher servlet to our controllers. Let's walk through a simple demonstration to see the test REST template in action. The first thing that I'm going to do is within the full stack test class, I'm going to auto-wire a field of type test REST template. I'm going to name this field REST template. It's going to be available for auto-wiring because we are running a Spring Boot test. There you can see we've pulled in the test REST template. And let's talk a little bit about this type. If you're familiar with the REST template type in Spring, the REST template is able to fire requests off, and then it's able to process responses that it receives from issuing those requests against a server. In this case, we're going to be using the test REST template to send requests to our Spring MVC applications dispatcher servlet for processing. The test REST template is a special type of REST template in the fact that it will not throw any errors or exceptions, so it makes it a little bit cleaner for testing. It's basically a way that we can interface through HTTP with our Spring MVC application while running our JUnit tests. In order to do that, we can provide some logic within our test method inside of the class. First, we're going to construct an endpoint, and we're going to be hitting the project/API/1 endpoint. So this is the URL that we will contact. And as you'll see in a minute, this URL gets passed to the test REST template to tell it what URL to contact. And we do not need to provide any host or port information when running inside of a Spring Boot test class, because we will automatically connect to our embedded servlet container thanks to some of the support provided by Spring. So when we send this request to the dispatcher servlet, you'll see that it's going to map to our find project object method within our project controller. We've used this in the past. This method returns
an object of type project in a JSON format that we're going to be able to inspect within our test. So let's go ahead and send a request to that controller handler method using our test REST template. And we can do that by invoking the getForObject method on the template. And it simply requires that we pass a URL, so we pass in the endpoint, and then we pass in a class that denotes the type of response that we expect. And since we expect a string, I'm going to assign the value returned from this method to a string called value. And then what we can do is within a JUnit assert statement, we can check to see if the string, which is going to be in a JSON format, contains a particular property and value that we know is within the project returned by our controller handler method. So I know that there is a name property that is on this object that has a value of Java project. So I'm going to specify that JSON property and its value within the contain statement so that we can search our string for that specific property and value. And you'll notice that we have to escape all of our double quotes within our string literal. The final piece of configuring a REST template is to specify what port we will be using. And thanks to the Spring Boot test annotation, it's pretty simple. We're going to use the web environment element, and we're able to say that we would like to use a defined port. So it's going to be a static port. By default, it will look in our application.properties file to determine which port to use when running this test. And that's how the test REST template is going to get a piece of the information it needs to submit this request. Just to quickly walk through, we establish an endpoint, we pass that endpoint to the getForObject method on the test REST template. That causes the request to be passed to the dispatcher servlet. The controller handler method that is mapped to this endpoint processes the request and returns a response. And then we're able to do our assertion to confirm that we did get the value that we expected, and we're able to pass or fail our test. So with this in place, I'm going to go ahead and run our JUnit test. And you can see there the servlet container being started as well as Spring Boot. And we're on our way to running through our tests, and we can see the test successfully passed. In this lesson, we'll take a deeper look at Spring's test REST template and how it can be used within our test cases. We know that the template can be used for sending GET requests to our test server. We've seen it in action. So now we'll take it a step further and learn to perform posts against our dispatcher servlet. Posts are a little bit more complex than the GET, but once we're able to post, then we can test the functionality of some of our more advanced controller methods. We're going to be posting to the save project controller handler method on our project controller. You'll notice there's some output to the console within this method, and we also do some validation of our project model attribute before we perform the save of the project. If there's an error, we return the project form to the user. Upon success, we will redirect to /home/, and that's going to cause our main controller to have one of its controller handler methods invoked, which displays our home page. This is important because it's how we're going to determine the success or failure of our test. So let's navigate over to the full stack tests, and we're going to build a new test case. I'll just copy this test case and we'll change its name to the post test, and then we're going to work from there. We need to change our endpoint to /project/add, and then we're going to have to build a multi-value map to handle the request parameters that will be sent over
in our post. So we're going to create a multi-value map, and this map is generically typed. So we say the key is of type string and the value is of type string. And I'm just going to call it our data map. And then I'm going to use the new operator and the linked multi-value map constructor, as well as the diamond operator, to instantiate our multi-value map. And that allows multiple values to be stored under that same key. Within the map, we're going to add a new entry, and the key is going to be name. And then we're going to set the name to simple project. When the REST template performs the post, this will end up as one of the parameters. It will have a name and a value of simple project. So we have added an entry to our multi-value map. And then what we can do is create a new HTTP entity, and it's going to accept a generic type of multi-value map. So I'm just going to copy our multi-value map and its generic type, and then put that in place as the type of this new object. I'm going to name this new object request data, and then I'm going to use the new operator. I'm going to once again borrow this type to invoke the constructor. Within the constructor, we need to provide our data map, and then the next thing is an instance of our HTTP headers. Now, we're not going to be sending any headers within this test, so I'm just going to instantiate that object right there. You can see that we're building out this HTTP entity, which contains the request parameters as well as the HTTP headers. So we're really building out a request at this point that's going to get passed to our dispatcher servlet for testing. When we do this, we're going to change the method that we invoke on our test REST template. And that's because we want to perform a post. So we're going to invoke the post for location method, and that requires us to provide an endpoint as an argument. It also requires us to provide our request data, so that HTTP entity. And then we need to provide the string class that tells us what to expect for the response coming back. The post for location method actually returns a URL, so we can see where we navigated to once the post was successful. So we're going to grab the path out of the URI that's returned from this method. We're going to check whether the path is equal to /app/home, because that would be the URL that we would navigate to upon successful posting to our save project method, because it does the redirect over to the main controller. Let's save our method, and then we're going to go ahead and test, and you'll see that it fails. And the reason it fails is because we did not validate the project. So you could have this be one test case where you purposely fail validation, and then in another test case, we're not going to build it, we'll just modify this one. You could go ahead and pass validation. So the reason we failed validation is because we did not have a description within the information that we sent back to the server. So with that in place, we will now pass our test case. You'll actually see that the project validated. And if we take a look at our JUnit test, we have green, so that means we passed. In this lesson, we will learn how to configure Spring's test support to conduct tests using only an application context as opposed to the full server stack. This will allow us to test processing of requests without the cost of starting up the server. Instead of starting the server, Spring will hand off the requests to our controllers, similar to if a real HTTP request were being processed. So let's check this out with a simple demonstration. We're going to need to create a new JUnit test within our source test Java folder and the com.o'reilly.mvc package. So I'll just open the new dialog, and then we create a JUnit test case. And I'm going to name this test case context only tests. And then go ahead and we can hit finish. And then we'll need to add our familiar configuration in order to integrate Spring and JUnit. So we add the run with annotation, and then we're going to add the Spring boot test annotation. And then here's where we're going to get into a new annotation. We're going to use the auto configure mock MVC annotation. This is going to signal to Spring that we are not running with the full server. Instead, Spring is going to only start up our IOC container, and when we process requests in this test, we're only going to be handing them off to the controllers and not processing them through the full stack of the server. In order to do that, the auto configure mock MVC annotation then allows us to auto-wire a very important object named mock MVC. So we're going to go ahead and build a field that's auto-wired so that the mock MVC object can be injected into our test case. Mock MVC is the main entry point for server-side Spring MVC test support. It's going to allow us to fire off requests against our controllers for testing. Let's walk through an example within our test method. So within this method, we're going to use the mock MVC object to perform a new request against our controllers in order to test out their functionality. When we use mock MVC, we use Spring's Fluent API. So what you're going to see is that we have to issue our appropriate type of request. So we invoke the perform method, and then we're going to say we're performing a get. Then we provide the path we would like to have invoked. In this case, we're going to have the get request be sent to the /project/API/1 URL. And that's going to map to a controller handler method on our project controller. We've seen it before. It returns a JSON representation of a project. So once we have established our GET request, we can then chain on the mock MVC object and invoke the AND_DO method. And this allows us to once again use that Fluent API to include one of these static methods, in this case print, and that will cause our response to be printed to the console, as well as a lot of other information about the request that we are making. We'll then chain the AND_EXPECT method. The AND_EXPECT method is going to allow us to use the Fluent API to access our content. And then we're going to take the content to a string type, and then we can use the contains_string method. And this is another method on that Fluent API. And here we can check that our response body, which is represented by the content method we're invoking and the string that we're taking it to, we can check that it contains a particular value. So I'm going to check that it contains simple project because I know that the first project, or the project with the ID 1, is going to have the name simple project. So we put all this in place using the Fluent API and the mock MVC object, and then we need to throw our exception, and now we are ready to test. Last thing I'd like to point out before we do test is this AND_EXPECT. This is pretty much performing the assertion on your test case. So I'm going to go ahead and kick off our test, and we can first see whether it passes or fails. And here you can see that our assertion was off. So I was wrong. It's actually Java project. So let's switch that up and we'll run our test case again. And this time we should be successful. We got green. Now let's take a look at our console because that's really the important part. Notice we are creating a test dispatcher servlet. And you'll also see if we look towards the bottom, we are using the test dispatcher servlet once again. And when we continue to look at our output, we see all these indications that we are no longer running within our actual container. Here you can see we're using a Spring Boot mock servlet context. So we are definitely not starting up the server, but we do get this nice output that tells us about the request we performed. And this is thanks to the print method that we had placed in the AND-DO method. So it's telling us the type of request. It also tells us information about the controller that was used and the handler method that was invoked. There you can see we invoked the findProjectObject method. And then we get some more information. We get to see the headers of the mock HTTP servlet response. So we get all this great information that can help us when testing our Spring MVC applications. That's thanks to the configuration provided by the Spring Boot project and our ability to use this mock MVC object to mock out some of the aspects of our server when testing our controllers. In this lesson, we'll take a look at how to perform posts within our test cases using Spring Test's Fluent API. Performing a post request will be necessary in order to test our controller handler methods that respond to that type of request method. We're going to work within our context-only test class. We'll just duplicate our test method, and then we're going to change the name to test2 so that we can distinguish between the two methods, and then I'm going to remove any code from the body of that method. Within the body of this method, I'm then going to use the mock MVC object, and I'm going to invoke its perform method and specify that I would like to perform a post. We're going to post against the /project/add URL, and that is mapped to our controller handler method we've seen in the past that saves a project. Now, we'll have to go ahead and import these static methods, and from here, we can begin building our post. What's nice about chaining in this instance is that we can supply parameters using the param method that chains off of the post method. So I'm going to first provide a name for the project object that we're going to post, and we will name it Java project. And then we're going to also chain another parameter, which will be the description. So here we're just getting past validation required by that controller handler method. This requires us to provide over 5 characters. There we have our post set up, and then we can start chaining about what to do once this request is received. We'll use the print method in order to get more information about the request that we fire off. And then we're going to invoke the AndExpect method. And from here, we're going to use the redirect URL and check that we get redirected to /home/. And we'll have to import this redirected URL. So with that in place, let's format our code so we can take a look at it. Here you can see the entirety of the statement we just wrote. We invoke perform on mock MVC. We pass in the result of our post method to /project/add. Then we start chaining on these parameters. And then when the response comes back, we print it out as well as some other debugging information. And then we check that we were properly redirected to the /home URL because that's where we would navigate upon successful posting of this method. So let's go ahead, we'll test it out, and we'll see what happens. We see we were green in JUnit, that's always good. And then we can just take a look at what happened. Once again, you can see that we are using a test dispatcher servlet, so we're not running in that full container. And we can see our first method get called, and let's take a look specifically at our post. So there we see the post. We see the parameters that were associated with that post. We see the controller and the method that were invoked. And then we get a look at some of the response, as well as we can see the model and view and the flash attributes that were added to the response to this request. And we can use the Fluent API to inspect all of these attributes of the response to determine whether or not it was successful. In this lesson, we'll see how to further reduce the cost of running tests for our Spring MVC application by using the Web MVC Test annotation. The Web MVC Test annotation allows us to run tests without a full Spring context, and it allows us to selectively choose the controllers to put under test. This reduces the costs of running tests by reducing the amount of infrastructure needed to run them. So to get started, we are going to copy one of our test cases within the source test Java source folder. So we're going to grab the context-only test cases, and we're just going to copy and paste it. And then we're going to rename this test case to limited context tests. And that's because we are not going to be running with a full Spring IOC container. The Spring IOC container is going to be limited to those beans that support our web infrastructure. So now that we have a copy of our previous test case, let's add some modifications. So the first thing we're going to do is remove the Spring Boot Test annotation, as well as the Auto Configure Mock MVC annotation. Then we're going to add the Web MVC Test annotation. The Web MVC Test annotation auto-configures the Spring MVC infrastructure, and it limits the beans that are registered and instantiated in the Spring IOC container. The only beans that will be instantiated inside of the IOC container are those that have the controller annotation, the controller advice annotation, the JSON component annotation. It also includes converters. It's only those beans that are part of Spring MVC's web infrastructure. An important point to note here is that beans annotated with the component annotation are not scanned and instantiated in the Spring IOC container. So let's talk about some of the consequences of this. If we take a look at our project controller, we see that the controller is annotated with the controller annotation. So the controller will be instantiated in the IOC container, but you'll notice that we have the project service auto-wired. And if we take a look at the project service, it's annotated with the component annotation. Normally, this class would be component scanned and turned into a bean. But because we are using the Web MVC Test annotation, that's not going to occur. The way we need to handle this within our test case is by creating a mock object. So we're going to create a new field of type project service, and I'm going to name that field service. And then we're going to add the mock bean annotation. Within the Spring Test project, there is support for creating mock objects using Mockito. So we're going to see how to put that in place by replicating our test method test case. So here you can see that we are performing a get to /project/API/1. we can see if we look at the project controller, that corresponds with this method that's going to return a project object in JSON notation. And we see that it is using the project service. So we need to use our mock. And the way we do that is by using the when method. So we can go ahead and import that method from Mockito. We just simply say when the service.find method is invoked with the long of 1, then we want to return a new project. So I've created a new constructor within the project class that accepts the ID as a long, the name of the project, which I'll name Java project, and then the description. So this is a simple description, and there we go. We have created our new project object that will be returned by our mock bean when the find method is invoked by the URL causing the controller handler method to be invoked. Here we can see that we're using the mock MVC object to perform the get, and then we're going to check that we do have Java project within the contents of the response body that is returned. With this in place, we're going to run a test, but it's going to fail. And I'm just doing this to prove a point. Our console tells us that the IOC container cannot start, and let's find out why. So if we take a look at it, we notice it's trying to auto-wire a resource service. Well, the reason is because there are other controllers that are being instantiated. So one of the neat things that the web MVC test annotation allows us to do is specify the controllers under test. So I'm going to specify the project controller, and that will help limit the amount of beans that need to be instantiated by our IOC container, keeping our test lightweight. The other thing that we can do is we can turn off security if we're not interested in testing it within this test case. With those two elements on the annotation, I'm going to go ahead and kick the test off once again, and then we can take a look at the response we get back. So there I can see we got a 200 response, so that's good. We should see that our test did pass, so there we get some nice green from JUnit. The async and streaming chapter will introduce two approaches that Spring MVC controllers can use to process requests. We'll see how to process requests in an asynchronous and streaming fashion. Within this chapter, we will learn asynchronous request processing, which allows processing of a request to be delegated from a container thread to a worker thread for execution. This allows the container thread to be returned directly to the container for additional request processing while the other thread handles the logic for the request. When processing requests asynchronously, we'll see how to leverage Spring MVC's deferred result and callable objects. We'll review the differences between the two objects and show you how to perform asynchronous request processing with both of them. Next, we'll see how to stream HTTP requests by asynchronously providing multiple values that are written to the response for a request. When streaming results, we'll leverage the response body emitter and its subclass, the SSE emitter, or server sent events emitter. These types will allow us to send multiple values back to the client in a streaming fashion. Additionally, you'll see the server sent events operate a little bit differently than what we're used to with AJAX, allowing the server to actually push information to the browser. The topics we'll cover in this chapter will teach you some useful tactics for processing requests within Spring MVC and set the stage to talk about the reactive stack. In this lesson, we will learn how to execute asynchronous requests that return a result to the client using Spring MVC's Deferred Results object. By using a Deferred Results object, we can delegate processing from the thread associated with our request to a worker thread that returns the result at a later time. This frees the server's thread to handle additional requests coming in from users. Let's walk through a simple demonstration to see how this works. So we're first going to navigate to our application, and you'll see on the resource form, I have added this getPrice method. If we take a look at getPrice, you'll see currently that it is mapped to /resource/pricing. Now, we do not have a handler method set up yet to handle this request. That request will get sent to the server by the resource.js file. So if we take a look at our JavaScript, you'll see that I've established an event handler on our hyperlink, and it submits a GET request to /resource/pricing, and then we grab the information returned and display it within the text box with the ID of cost. Right now, we have the client side built out to basically ask for this pricing information and place the information within the text box. We're going to work within our resource controller to build a controller handler method that returns a deferred result. While we are going off and fetching that pricing information, we're not going to tie up a thread on our server. So let's see how we put that in place. The first thing that we need to do is create that new controller handler method. It needs to return a new deferred result with a generic type of string, and I'm going to name this method getPricing. We'll import the deferred result type, and now we'll start to annotate our controller handler method. The first thing we want to do is add the request mapping, and we said it's going to be mapped to /pricing. From there, we're going to add the response body annotation because we want to return the result of this method directly as the response body to the client. Now within the method, we need to do a few things. So the first thing we're going to do is actually write some information to the console. We're going to notify the console when we've invoked this method, and we're also going to write to the console when we have finished invoking this method. And this is going to give us some insights into how asynchronous processing and the deferred result work. Now we need kind of the star of the show here, the deferred result. And it needs to return a generic type of string. I'm going to name this object deferred result, and we can simply use the new operator and the deferred result constructor in order to establish this object. And then we are going to return the deferred result at the bottom of our method. So we have everything in place to build a deferred result. Now we need to create a new thread that is going to perform the call to get the price in another thread than the one that's being used by our server. So here's where we kind of delegate that execution to a new runnable. So we're going to go ahead and add the runnable in the thread constructor. And at this point, I'm also going to invoke the start method on our thread. So if we import the runnable type, we'll need to add the run method for this interface. Within the run method, this is where we are going to get our result to return via the deferred result object. But let's first add some console output so we get more insights here. So we're going to say the runnable has been invoked, and then we're also going to note when we are returning the result. So I'll just put returning result,
and we get a little bit more insight into how our runnable is executing in relation to our overall controller handler method. The next thing we're going to do is sleep the current thread just to add a little bit of a delay, so about 3 seconds. And when we do this, we will need to surround that method with a try catch. And then we're simply going to return via the deferred result a random integer. So I'm going to use string.valueOf to build a new random integer with the next random object. Basically, I'm just looking for a small integer here to return as a string, and that's going to be our price. So we randomize the integer we choose, convert it to a string in order to satisfy the generic typing of deferred result, and then the setResult method is going to cause that value to be returned to the client. And what we're going to see when we look at the console is we're going to invoke the pricing method, and then we're quickly going to jump down and finish the invocation of the pricing method while our deferred result gets collected within this new thread. So we will see that we return the result after we have actually completed the invocation of this method. And that's because we're doing it in a different thread and we're freeing up that other thread for our server. So with these changes in place, I'm going to restart the application. We can navigate to the browser, and I'm just going to go ahead and refresh a few times to make sure we're not cached. And then what we can do is invoke the getPrice controller handler method. We get a price returned. Now, let's go look at our console. So here you can see exactly what we expected. We invoked the method then finished its invocation, and then we see our other thread doing the work to return the deferred result, which comes back at a later time. In this lesson, we'll take a look at the callable object, which is another option for performing requests asynchronously. The callable object is very similar to the deferred result object with one key difference. When using the deferred result, we were responsible for managing the thread because it was unknown to Spring MVC. When using a callable object, Spring MVC is responsible for completing the processing in a separate thread that it manages. We are actually going to recycle the deferred result method that we established within our resource controller. Here you can see that the getPricing method is returning a deferred result. The callable is pretty much interchangeable with deferred result. We just have to make some modifications to our method. So here you can see I switched the return type of the method over to callable, and now we're going to return a callable object from this method. So I'm going to create a new callable. Within this block, we will define the implementation of this callable object. So you can see that the callable has one method, which is call, and inside of this method, we need to return a string, which is what will be returned to the client. The first thing we're going to do is just add our console output. So you can see that we're putting this getPricing has finished message right above our return statement. And now we're going to provide the body of the call method. So we can get rid of all of the thread code that was used to handle the deferred result. And then if we just copy the code that was within the runnable, so this is the actual logic that we wanted to perform, and we put that within our call method, it makes it pretty easy to switch over to the callable. You'll notice we're not doing any handling of threads. That's all going to be deferred to Spring MVC as it performs this callable and its call method
within its own processing via another thread. So we can print out that the callable has been invoked, and then we're going to sleep, and then we can print out when we are going to return the result. We no longer have to set the result on the deferred result object. We can simply return it straight from our callable object. So let's take a look at this in its entirety. We have a controller handler method that returns a callable that has a generic type of string. The generic type is what will be sent back as the return value from the getPricingController handler method when the processing has finished. Now, when we are strictly looking at this from a method perspective, we are returning a callable. But what goes back to the client is going to be this string once our processing finishes in another thread. And then the processing that's going to occur is the logic within the call method, and we provide our return value in the body of the call method so that we can dictate what goes back to the client. So I'm going to go ahead and save our resource controller, and we can clean up the imports. And then if we relaunch our application, we can wait for it to start up and then navigate over to our browser. And I'm just going to refresh. And then we click on Get Price, and you'll see we get the new price of our resource. And if we take a look at our output, here we can see the pricing method finished its invocation, and then the callable was invoked, and we were able to return our price. In this lesson, we'll learn how to use Spring MVC's response body emitter to produce multiple asynchronous values from a controller handler method. The response body emitter is used to return a stream of objects that are written to the response. Within our resource controller, we are going to add a new method that returns a response body emitter, and we're going to name this method sendStream. We'll need to import the response body emitter type, and then we're going to add the request mapping annotation, and we'll map the method to /stream. And then we're going to add the response body annotation as well. The next thing we'll do is within the body of this method, we're going to build a new response body emitter object, and I'm just going to name it emitter, and then we'll use the new operator and the constructor to instantiate the object. And then we'll just go ahead and return the emitter. The next thing we'll do is create a new thread, and we'll go ahead and start the thread. Inside of the thread constructor, we're going to create a new runnable, and then we will provide an implementation for the run method in the runnable. Inside of the run method, we're going to create a simple for loop that is going to loop 20 times. And within the body of that loop, we are going to use our emitter to just send a random integer to the response, and we'll just send a number over. And then we need to add the try catch block around this call since we're using the random. And then within this, we're also going to sleep for roughly a second. And I'll just switch up the catch block here to handle thread.sleep. And then what we need to do is close the emitter once we have ran through our for loop. And we can do that by using the complete method, which will complete our response. So here you can see the emitter gets instantiated, and then within this new thread, we are able to asynchronously send these numbers over to any consuming client. Let's go ahead at this point and run our demonstration. So I'm going to relaunch the application, and once it starts up, we're going to navigate to /app/resource and then stream. You'll notice that we start to have the numbers streamed to us by our response body emitter. If we take a look within our network tab, we would see that when we send this request, we'll send it again, that we are constantly getting updates to the response body that are coming from that emitter. In this lesson, we will learn to push data to the browser using Spring MVC's support for server-side events. Server-side events push data to the browser over an HTTP connection as opposed to the browser requesting the data from the server. This is all done asynchronously. We're going to work within our resource controller, and what I'm going to do is actually create a copy of the sendStream method. So we're going to name the method getPricing, and we're going to map it to the /pricing path. And you should probably notice that we've already defined this method within our controller. So here we were responding with the pricing information in our controller handler method that returned a callable. We're going to update that. Let's say the price of a resource is extremely volatile and it changes very quickly. So we need to return that price via a server-side emitter. So we're going to swap out the response body emitter with an SSE emitter, and that stands for server-side emitter. We will then need to change the emitter object that we are instantiating to be of type SSE emitter, and we need to use the appropriate constructor. So at this point, if we import that type, we are set up to use the server-side emitter provided by Spring MVC. Now you might be saying that was a pretty easy swap, and that's because the SSE emitter is a subclass of the response body emitter. With that in place, what we need to do at this point is change up our JavaScript that is contacting the /resource/pricing endpoint. We can no longer just use AJAX because we need to leverage a different technology in the browser. So what we need to do is establish an event source. So when we're using server-side events, we need to use an event source in order to be able to consume those responses from our SSE emitter. So we're going to provide a path to the event source constructor, and it's going to be /app/resource/pricing. So we are invoking that controller handler method that we just established, and then what we do is we add an event handler to the onMessage property of the event source, and here we can specify a function that will be invoked every time we receive information from the server-side event. So within the parameters of the function, we're going to receive the event, and then what we can do is take the data associated with that event and place it within the cost text box. That's the text box that contains the pricing information for the resource. At this point, we can get rid of our AJAX call, and let's go ahead and save our resource.js file, and we're going to launch our application. Now let's navigate to the browser, just hit F5 a few times to kill any caching, and then we're going to go ahead and hit the getPrice method. And there you see that the price is continually updated as we are sending the events down to the browser from the server side, actually. So it's kind of the inverse of AJAX, where we are reaching out to the server to send a request and get a response. Now the server is pushing this information to the client. Now, one thing I have to point out here, this awesome feature is not available in Internet Explorer. So if you want to use this feature in IE, you will have to put a polyfill in place, and that will backfit the capability into Internet Explorer. In this chapter, we'll introduce the Spring Web Services project. This project helps developers quickly establish or consume SOAP-based web services. So at this point, you might be wondering why we are taking time to cover SOAP when most organizations are moving forward with lightweight services. When consuming data, we often don't have the luxury of specifying the approach. It's often dictated for us via a take-it-or-leave-it proposition. Many organizations still rely upon XML-based services, and if we want to consume their data, we need to deal with the complexity that accompanies XML or SOAP. Luckily for us, Spring WS, or Spring Web Services, performs the majority of the heavy lifting when working with a SOAP-based web service. We're going to establish our own web service, and this web service is going to provide bids or quotes on a project. We will send a message to the service with a particular project name, and then the service is going to respond with how much it would take to complete that project. So it's pretty simple, but we'll work through the configuration of that service and see how it's built using Spring WS's contract-first approach. And that means that we're going to define the schema for our service and then build out the objects that will back the service from that schema. We'll see how to use some JAX-B plugins within Maven in order to generate those classes or objects for our web service. Once we have them generated, we'll work through establishing an endpoint to handle incoming XML messages to the web service. One of the neat things with establishing these endpoints is we're pretty hands-off with the XML. The Spring WS project handles the marshalling and unmarshalling of the XML coming into the service, and we work with POJOs. Once we have established our web service, then we're going to move to the other side and look at consuming a web service. In particular, we're going to consume messages from the web service that we just established. So we're going to take the Spring MVC application we've been working on that performs project management and set it up so that it can send a message to our quote or bid web service and then get back a quote or bid on a project. So we'll see how to configure a consumer of a web service and put the appropriate dependencies in place in order to perform the consumption of messages from a web service. This chapter is really going to provide you with a lot of skills to easily work with web services in Spring. Dealing with XML-based services can be notoriously complex and cumbersome. However, Spring WS greatly lowers the difficulty level. As we work through the chapter, stay on the lookout for how Spring WS shields us from having to work directly with XML messages. You'll also notice how it allows us to maintain the flexibility provided by Spring when dealing with web services. In this lesson, we will build out an XSD file that will describe the objects used for our web service. The XSD file will contain a schema for the objects that depicts and represents the characteristics of those objects we'll be using in the system. Once created, this file can be used to generate the underlying objects that back our service. Let's walk through a simple demonstration that details how to build an XSD file. So the first thing that we're going to do is create a new Spring Starter project. So just open the New dialog and then select Spring Starter Project and hit Next. Within the Spring Starter Project dialog, we're going to specify the name of our new project, and I'm going to name this project Spring-Web-Service, and then we are able to specify the group ID, which in this case I'm providing com.o'reilly.ws. And then we also want to make sure that we have a package ID set, which I'm also setting to com.o'reilly.ws. So with these things in place, we can proceed to the next step in the configuration. And from here, we're going to add the web dependencies as well as the web services dependencies. So there we see web services. And with those two in place, we can go ahead and hit finish. And Spring will automatically start building our Spring Boot project. So here we see the new project has been created. And the first thing that we're going to do is within the source main resources directory, we're going to create a new XML file. So we'll use the new dialog to select an XML file. And we're going to name this file bid.xml. And then just go ahead and hit finish. Now within this file, we're going to define a bid object that is really going to underlie our entire web service. The bid object is basically going to be a response to a project proposal for how much they believe they can complete the project for. So this would be like some vendor proposing they can complete a project in a specific dollar amount. Basically, you're getting an estimate. So within the bid object, we're going to have a quote. So let's just make a quote there. And then the other thing that we're going to find in the bid object is a date that the quote is valid to. So we're going to go ahead and just put a simple date in there. Really, this is going to be the underlying object returned by our service. And we need to define the XSD for this object and several others that will be important to the service. So we're going to turn to an online tool to help us take this sample XML document and turn it into XSD. So here I'm visiting liquid-technologies.com, and they have an online XML to XSD converter. You'll find several of these out there on the web. This seemed to be a particularly nice one. I just enter my XML, tell it to generate the schema, and then you'll see that I get this nice schema that I can bring over to STS. And at this point, we're going to create an XML schema file, and we're going to name this XML schema file bids. And with that in place, let's go ahead and just arrange that. We can take the content we got from the online generator and place it into our bids.xsd file. And I'm going to remove some of these duplicate headers. We don't need the XML version. We already have the schema defined. And at this point, we're good to go. We also do not need to use this XS prefix on everything because schema is defined as our default namespace. So I'm just going to go ahead and remove all of those prefixes. So here we have defined our bid in XSD. And the other thing we're going to do at this point is change our namespace. So we're going to put this within the O'Reilly namespace. So I'm just going to switch this up to o'reilly.com/bids in order to have a unique namespace for our project. So we have a start on our XSD file. One thing you'll need to do a lot of times with the online generators is do some tweaking as we're already doing. So we're going to remove this element and we're just going to define a complex type of bid. So we were able to shorten up the bid type that we created. So the next thing we need to do is create two other objects that are going to be important for our web service. And the first is going to be an object that corresponds with the SOAP request that comes in to our web service. So we're going to be building out an object of type bid request. It's going to be a complex type. And within that complex type, we are going to have a single element
and that element is going to be named project name. So essentially, the service is going to receive a project name of type string, and from there, it's going to build the bid or the quote for completing that project. So the bid request will be the object that is sent into our web service, and then we're going to have a bid response that is returned from the web service. And that bid response is going to have one element. Its name will be bid, and it's actually going to return a type of bid. So we reference this namespace, and then we point to our bid object. So at this point, we have created our XSD file, and I'm going to go ahead and validate the file and make sure there's no errors. So we are getting a false alarm here from Eclipse, but you'll see that we have this XSD file. It defines 3 schemas for 3 objects that are going to be used within our web service, and we can actually take this file and generate objects from it.
In this lesson, we'll learn how to generate Java classes for a web service from XSD files. The generated classes can then be used to back the web service that we'll establish. To generate the files, we'll be using a JAX-B plugin with Maven to generate Java classes from XML schemas. The plugin uses XJC, which is a tool in JAX-B to generate the classes. Let's take a look at how this is achieved through a simple demonstration. Within our pom.xml file, we are going to navigate down to the plugins section within the build tag. Inside of the plugins tag, we're going to go ahead and add another plugin. And when we add that plugin, we need to specify the Maven coordinates to that plugin. So we're going to provide the group ID of org.codehost.mojo. And then we're going to specify the artifact ID, and that's going to be jaxb2-maven-plugin. And then we need to provide a version. So the version we're going to use is 2.3.1. So we have the coordinates to the plugin. Now we use the executions tag in order to specify the goal within the plugin that we would like to execute. So we provide the plural and then singular execution tag, and inside of the execution tag, we need to specify an ID, which is going to be XJC, and then we need to say that on the XJC plugin, we would like to execute the XJC goal. So it's important that you watch the singular and plural form of these Maven tags. That can always be a little bit tricky, and you don't want to have to debug that for the next hour. Let's now add the configuration for this plugin. And within the configuration tag, we can specify the sources. And the sources tag is going to specify the files that we would like to convert from XSD to a Java class. And we can leverage the expression language. So we're going to say the project base directory, and then we're going to say /source main resources, and then bids.xsd. And if you take a look within our project, there you see within the source main resources directory, the bids.xsd file. So we've specified our sources. Now we can say where we'd like to place the generated class files. To do that, we can use the output directory, and I'm actually going to just grab this value that we provided for source, and we're going to paste that within the output directory and then change the resources to Java. And from there, we can remove bids.xsd. So that's going to cause our generated classes to be placed within the source main Java folder. And from there, we can specify the package name. And the package name is going to be com.o'reilly.ws, and then I'm going to specify generated as the package that will contain them. So underneath this com.o'reilly.ws package, we're going to see another package named generated be created, and that's where the plugin will place our class files. And then the final thing we're going to do is tell it to not clear the output directory, just in case we had other files in there that we would like to preserve. So we have the plugin configured at this point. Just to take a final look, we specify the coordinates of the plugin, the version, the goal that we'd like to execute, and then we're able to provide this configuration that will determine the behavior of the plugin. At this time, we are ready to run our Maven command. So we're just going to go and right-click on the project and then go run as and Maven build. It's going to bring up this dialog that allows us to specify our Maven goals. The first thing we should do is check that we're using a JDK and that it's installed on our operating system. And then we're going to specify the goals of clean and package, and we'll hit apply and then hit run. So there it looks like we should now have these files. So if I navigate into this package and refresh, you will see that we have created Java files based upon our XSD. So there's bid.java, and if we take a look at bid.java, you can see we did have quite a bit of code generation completed for us. And there's the class bid, and we're basically defining a bunch of annotations on this class that will help it get serialized and deserialized. So there we see our quote field, our valid to date field. And now if we look at bids.xsd, you can see those are the elements that we defined on this complex type. And then you're also able to see our bid response. So you can see that was generated, as well as the bid request. So we have these objects created by JaxB and the Maven plugin that we installed, and we'll be able to use them to back our web service. The Spring Web Services project provides us with several classes and annotations that we can use to establish and configure a web service. These supporting objects expedite web service configuration and make it easier for developers to build a service. In this lesson, we'll take a look at these objects and annotations in order to see how we can configure Spring WS. The first thing that we need to do is add a dependency to our pom.xml file. So I'm going to open that file and then click on Add, and we're going to add the WSDL4J artifact. There we see WSDL4J with the group ID WSDL4J, so we can go ahead and add that to our POM and then save our POM file. The next thing we'll do is add a new class within the com.o'reilly.ws package. We're going to name this new class Web Service Configurer, and we need to make sure that this class extends the WS Configure Adapter class. With that class established, we can go ahead and create it. And then the first thing we do to this class is add the Enable WS annotation. This annotation configures some adapters for processing requests with annotated endpoint methods. Now, endpoint methods are very similar to a controller handler method that we see on our controllers. Next, we'll add the configuration annotation to this class, which allows us to declare beans. And we're going to declare a bean of type Servlet Registration bean, and we're going to generically type this object with the servlet type. The name of this method is going to be the message dispatcher servlet, and we're going to inject the application context into this class. So we'll go ahead and import these types and then annotate our method with the bean annotation so that we can have this bean registered in the Spring IOC container. Now within the body of the method, we're going to create a message dispatcher servlet, and we're just going to name this object servlet, and then we'll use the new operator and the constructor to instantiate this object. So the message dispatcher servlet is kind of like a dispatcher servlet that's been outfitted to specifically support web services. It's going to process the requests coming into our web service and then route them to the appropriate endpoints. It knows how to handle some of the annotations associated with our endpoints in our web service. So we're going to pass the servlet a handle to the application context. So we can do that using the setApplicationContext method. And then we're also going to invoke the setTransformSchema locations. And this accepts a Boolean, and we're simply going to specify that it's true. And this helps us handle relative paths within our WSDL and schema. So it resolves them for us. And from there, then we're going to build a new servlet registration bean, and we can use the diamond operator. And then we're going to use the constructor that accepts the servlet, then allows us to map to a particular URL mapping. For any request that has /ws/, we are going to use our message dispatcher servlet to handle that request. So that's basically how we're going to get requests into the web service. Now, the next thing that we're going to do is establish another bean, and this bean is of type default WSDL 11 definition. This method is going to be the default WSDL 11 definition method, and we're going to inject the XSD schema object, which we will name schema. Let's go ahead and import these types and then add the bean annotation to this method. And we're also going to specify a name for this bean, and the name will be bids. This is important because what our default WSDL 11 definition does, it provides the definition of our WSDL, and then our message dispatcher servlet bean can generate that WSDL and make it available within our web service. What will ultimately end up happening is a WSDL with the name bids.WSDL will be generated. So when we specify this bean name, we are specifying the name of our WSDL. Now let's instantiate a new default WSDL 11 definition. And I'm just going to name this object the definition, and then we'll use the new operator and the constructor to instantiate that object. And then on the definition, we're going to set the port type name. This is kind of like the interface for your web service. And we're just going to name that bids port. The next thing we'll do is invoke the setLocationURI method. And we're going to specify the path that our web service will reside at. And then from there, we're going to set the schema using the schema that was injected into our method. And then we're going to go ahead and return that definition. And then finally, what we're going to do is declare another bean. And this bean is going to be of type XSD schema. And we're going to name this method the bid schema. And all we need to do within this method is return a new simple XSD schema object. And we're going to actually grab that schema from our class path. So if we take a look here in a minute, we have the bids.xsd file out there. So let's import these types, and then we'll go out to our package explorer, and you'll see the bids.xsd file. That's going to be the schema that we create here for this bean, and then we inject it into our WSDL definition, and our WSDL definition has its set schema method invoked, passing in that schema. And then to tie it all together, the message dispatcher servlet's able to generate that schema. So if I was building this class out for something other than this example, I probably would have started with this method at the top of the class and worked my way down. So with that in place and our POM configured, I'm going to go ahead and relaunch our application. Now we're going to navigate to localhost at port 8080. And then remember, we're mapping to /ws, and then our WSDL name was bids.wsdl. And there you can see our newly generated WSDL, which Spring WS was able to help us build based upon our configuration. In this lesson, we'll learn how to establish an endpoint for a web service. An endpoint is similar to a controller in the fact that it can be used to handle requests. However, the endpoint is specifically for web service requests. The methods on an endpoint function similar to controller handler methods, except that they often expect to receive and will return an XML message when handling an incoming request. To see this in action, let's create a new class within our com.o'reilly.ws package. We're going to name this class bidEndpoint, and once we have the class established, the first thing we do is add the endpoint annotation to the class. This signals that this class will be handling requests coming into our web service. We're going to use methods on this class to handle those requests. So I'm going to establish a method that returns a type of bid response, and I'm going to name the method getBid, and it's going to accept an argument of type bid request, which we'll name request. Now, if we take a look at these objects, you can see that bid response is one of the generated objects from our XSD file, as well as bid request is one of those generated objects from the XSD. Now we're using those types that we build out. At this point, we're going to add the payload route annotation to our method. And this is similar to like a request mapping, except we map a little bit differently. We map by the namespace on the incoming message. And in this case, this method is going to handle messages from the www.o'reilly.com/bids namespace. Now we also need to specify a local part element on the payload route annotation. And in this case, it's going to be the bid request local part that we specify. So when the message comes in, we're going to inspect the payload of the message. And if we find this bid request, we know to invoke the getBid method. So the next thing we'll do is on the method signature, we're going to add the response payload annotation. And this is very similar to like response body. What it's going to do is indicate that the value returned from this method, the bid response, should be bound to the payload of the response that we're sending from our web service. The next thing we're going to do is bind the payload on the incoming message to our bid request argument. And to do that, we use the request payload annotation. And it's pretty simple. We just add that annotation to our method signature. And now we're ready to build out the body of our method. So we're going to start first actually by outputting some information to the console, just so we can see the processing of this message coming into our web service. So I'll grab the project name from the request and just write it to the console. And then we're going to start working on building our response, which is of type bid response. So I can use the new operator in the constructor to create the bid response object. And then I'm going to start building a new bid. The first thing that we need to set on the bid is the quote. The quote is of type big decimal, so we can use the big decimal constructor. We're just going to return a static value of $1,000. The next thing that we'll do is set the valid to date on our bid. So this says how long the bid is valid to, and it's using an XML Gregorian calendar. In order to build one of those, we need to use a data type factory, and we create a new instance of that data type factory, and then we can create our new XML Gregorian calendar. Now, the one thing you'll see is that we need to perform some exception handling, so I'm just going to surround that within a try-catch block, and we're not going to handle any exceptions for our demonstration. Now we're going to set the bid on our response object. So I'll just pass that bid into the setBid method. And then the next thing we'll do is return our response. And at this point, we have built out our endpoint. So using the payload annotation on a class annotated with the endpoint annotation, we're able to specify a mapping to our method that's going to return the response for our web service. In order to test this out, we need to restart our web service. And once we see it start, we're going to head to Postman. Within Postman, we have a post request that's going to go to localhost on port 8080/WS. That's where we have the message DispatcherServlet mapped in order to handle requests for our web service. So we're sending a request in, and on that request, we need to set the content type header to XML so that we can supply our SOAP message. Now, let's take a look at two things. You'll notice that we have specified this namespace on our SOAP message in the envelope, and we've also specified within the payload body that we are using the bid request tag. So if we take a look at that, and then we navigate back to STS, you'll see that corresponds with the two element values that we had to provide in order to map this message coming into our web service. With that in place, we have our constructed SOAP message. We're passing in the project name, and that's going to correspond with that bid request field. We can send our message over to the web service, and if we take a look, you'll see that we get back our quote. In this lesson, we'll configure our Spring MVC application to act as a client of a web service. This configuration will set the stage for the web application to send and receive messages from the web service we have previously built. In order to get started, we're actually going to start within our web service. Because we're going to be running this web service and our web application, we need to modify the port that the web service is going to be running on. So I'm just going to set the server.port property to 8081 on the web service. So I can go ahead and close that file. And then if I start the web service, we can confirm that it is running on port 8081. So let's watch it start up. There we see the web service is on 8081. That's exactly what we want. Now we're going to move to our Spring MVC application, and within its pom.xml file, first we're going to add a dependency, which is the Spring boot-starter-web services dependency. So we'll go ahead and add that to our application, and then we're going to take a look at the pom.xml file. you'll find that I have already established a new plugin within our pom.xml. So it's the maven-jaxb2- plugin. You'll notice that we have configured it to execute the generate goal. And then what it does is it reaches out to the web service. We need to modify the plugin to access the web service on port 8081. And you'll notice we just had some traffic to the web service that we can see in the console. And that was actually from our project. Because what this plugin does is it reads the WSDL and then it generates the classes that it finds within the schema for the web service. So you'll notice now our web application has the bid request, and the bid response objects. And that's thanks to this plugin. You can see I've specified the directory to generate these classes within, and I've also specified the package name to place these packages. Very much like the plugin that we used to generate classes from our schema, it's just now we're doing it on the consuming side. You can just reference the working files to see the configuration of the plugin, and we know the operations it performs. While we're working through configuration, we're going to establish a marshaller. Using JAXB, we can leverage its capability to marshal and unmarshal XML. Within the configuration of our application, so here I'm in the web configuration class, we're going to declare a new bean, and this bean is going to be of type JAXB2 marshaller, and we're going to name this bean marshaller. And then within the body of this method, we're going to first create a marshaller object using the JAXB2 marshaller constructor. And then we're going to set the context path on the marshaller to point at the package containing our generated classes. And this is where it will look to marshal and unmarshal XML. And then we simply return the marshaller from the method, and now we have it established for use within our Spring MVC web application. In this lesson, we'll use the Spring WS web service template to consume messages from a web service. The web service template can be accessed by extending Spring Web Services Web Service Gateway Support superclass, which exposes the template. We'll walk through a demonstration that uses this support to send and consume messages from the bid web service that we've established. The first thing we're going to do is within our com.o'reilly.mvc package, inside of our Spring MVC application, we're going to create a new class, and we're going to name this class the bid client. And we want to make sure that this class extends the web service gateway support class provided by Spring. That's how we're going to get a handle on the web service template. So once this class is established, the first thing we're going to do is add the component annotation so that it's detected by component scanning and turned into a bean in the IOC container. Then we're going to declare a new constructor for this class, and the constructor is going to accept the JAXB2 marshaller that we have established. So you'll remember that within our web configuration, we established this JAXB2 marshaller as a bean. Now looking at this, we need to make sure the context path is correctly set. It should be com.o'reilly.ws. So let's make that adjustment, and then we can close out our web configuration class. Now, with the marshaller being auto-wired into our bid client constructor, we can take the injected marshaller and invoke the setMarshaller method on the Web Service Gateway Support superclass. So this is actually coming from the parent. And then we can also set the unmarshaller, and in this case, they are going to be the same object. So there we have a marshaller established that is going to be able to convert from an object to XML, or it's going to be able to unmarshal from XML to an object. And with that in place, we can continue working on our bid client. So what we'll do is add another method. It's going to be a public method that returns a bid response. So you're starting to see us use those generated classes. And this method is going to accept a string named project name. Within this method, we're going to create a new bid request, which I'll just name request. And we can create that with the new operator and the constructor. And then we can set on that request the project name. So we'll just say it's a simple project. And from there, we can now start to work with our web service template. So we'll add the template, and we can create it by using the superclass and invoking its getWebServiceTemplate method. And then once we have the template, we can work to return a bid response by using the template and its marshal send and receive method to send a message to our web service. So we specify that we want to contact localhost on port 81, and then we specify the /ws/path, and we provide our bid request as the second argument to pass over as the message. So here we're going to be sending a SOAP message over to our web service, but we're never actually touching any XML. And that's thanks to all the marshalling and unmarshalling that gets performed by the template. The web service template allows us to contact a web service from a client, and that's thanks to all the support provided by Spring WS. The template is really the core class that drives all the communication from the client side. Now that we have the bid client established, what we're going to do is navigate to our project controller, and within the project controller, we're going to auto-wire a bid client, and we'll just call it the client. And then we can establish a new method on the controller that will return a bid response, and we'll just call this method getBid. And the method will use our client, which has been injected. So we can say client.getBid, and we'll pass in the name of our project to the getBid method. And that's going to cause the web service to be contacted through the client. Now, the other thing we'll do is add a request mapping so that we can send a request to this new controller handler method. It's just going to be /bid. And then we're going to add the response body annotation so that we can see the results of invoking this method in the browser. So if we take a look, we are invoking getBid on the client, passing in a project name into our setProjectName method. The web service template initiates the contact with our web service, and we should get back a bid response. We have our web service already running, so what I'd like to do now is just restart our Spring Boot application. So at this point, let's navigate to the application. So I'm just hitting localhost at port 8080. And now I'm going to the application and then project and then /bid. And that will invoke our new controller handler method. And there you can see that we were able to contact the web service that we had stood up from our controller handler method. This chapter will focus on Spring Webflux, a project within the Spring ecosystem that allows us to build reactive web applications. At this point, you may be wondering what I mean by reactive. First, reactive is a pretty loaded term. Many of the technologies in the reactive paradigm in Java are a derivative of the reactive streams specification, or they leverage a reactive stream implementation. The Reactive Streams initiative is focused on providing asynchronous stream processing for Java and the JVM. This explanation is only brushing the surface of reactive Java, and we'll keep it that way throughout the chapter because the space would require several full courses to cover thoroughly. So the focus of this chapter will be to quickly build your knowledge on the important reactive concepts used by Spring Webflux, and then work through some demonstrations of the core Spring Webflux components. Let's talk about this in a little bit more detail. We'll start out by learning some of the key concepts behind reactive applications. We'll talk about why they are necessary and their underlying interfaces and patterns that are used in reactive solutions. From there, we'll take a closer look at the Spring Webflux project to give you a quick primer on what to expect. This discussion will segue into a demonstration that focuses on Project Reactor. Project Reactor is a key dependency of the Spring Webflux project because it provides the reactive streams implementation. Once we have that reactive foundation established, we'll build out a Flux project and start doing some demonstrations of key components. Specifically, we'll see where the Mono and Flux fit into the Webflux framework and learn an alternative way of processing requests with the router function and handler function. By the end of this chapter, you will have a solid introduction to the Spring's reactive stack that will set you up to dive deeper into the reactive space. In this lesson, we'll discuss some of the key principles of reactive applications. Reactive programming is a concept that has recently been reinvigorated and brought to the forefront. Like any trending concept, there's a bit of mystique and confusion surrounding the space. Some of the ideas and terminologies associated with reactive are ambiguous, yet they have subtle nuances that make establishing a concrete definition extremely difficult. Depending on the source, you may get different explanations or find defining some terms to be like splitting hairs. With that said, it's quite amazing what can be achieved with limited server resources when using a reactive approach. So let's start there. A major driver for moving to a reactive application is scalability. In the past, when a system faced resource limitations, we scaled out or scaled up. So we built a bigger box or we got more boxes. Unfortunately, this approach has limitations, both technically and financially. Many systems have reached a point where they are up against these technical limitations due to the number of concurrent users they must support. Java web applications, which use a servlet container, are especially vulnerable because the container leverages a thread per request style that is blocking. In other words, when we run out of threads in the pool, we need to wait for one to become free in order to process the next request to our server. This problem has caused some developers to give up on scaling using the traditional approach. Instead, they have decided to go reactive in order to use existing resources more efficiently. That brings us to the underlying concepts behind reactive programming as they are declared in the Reactive Manifesto. Similar to the Agile Manifesto, the Reactive Manifesto is a public declaration by developers to build systems that are responsive, resilient, elastic, and message-driven. Systems meeting those criteria are referred to as reactive. I would highly recommend reading the manifesto. It's rather abstract, but will give you a high-level overview of the goals of reactive applications. Basically, reactive systems aim to respond in a timely manner, handle failure gracefully, stay responsive under load, and use an asynchronous message passing style. That last part, regarding message passing, is pretty loaded. It's also where the complexity of reactive applications is introduced. So we're going to dive a little deeper into that area to get a better understanding. This diagram should look semi-familiar if you have ever worked with Spring integration or any other messaging technology. Basically, it describes how a message is sent from a producer to a consumer. When talking about messaging, we also add in a channel that is used to move the message from one to the other. Reactive applications follow a similar paradigm. A pipeline is established between the publisher and consumer that messages or events can be pushed over. Within the pipeline, a publisher pushes data to the subscriber, which decides what to do with the processed data. Reactive applications also introduce the concept of back pressure to this pipeline, where the subscriber can provide feedback to the publisher, telling it to slow down and send fewer items. This seems simple. However, the pipeline is also asynchronous and non-blocking. These are key principles of reactive. The asynchronous nature of the pipeline means we don't know when the pipeline will send processed data to subscribers. Since the pipeline is non-blocking, we are not going to hold up work or a thread while the pipeline does its processing. These concepts are where some of the paradigm shift occurs when going reactive, but it's also what delivers the performance gains that allow us to operate on a highly performant level on very minimal resources. Additionally, we can choose to execute some of these operations in this pipeline concurrently or in a parallel fashion, just in case things were a little bit too simple. Now, we've only skimmed the surface of reactive applications, introducing some of the key theories and concepts, but we're going to stop here. That way we can transition to some more concrete examples that better illustrate key reactive principles. In this lesson, we'll introduce the Spring WebFlux project and talk about some of the underlying technologies that support it. Spring WebFlux was added to Spring in version 5.0, so it's a rather recent addition to the framework. Its goal is to provide a non-blocking alternative to the servlet container so that we can handle more concurrent requests with fewer threads and less hardware. Remember, reactive applications deviate from the thread per request approach adopted by the Servlet API. In order to use reactive applications, you need a server that supports non-blocking and asynchronous request processing. This limits our options to Netty, Undertow, or any container that is Servlet 3.1 compliant. When writing reactive code, you will see that the code uses a functional style. So we are often passing data from a source to an isolated function or lambda. This lambda performs operations on the data before passing them to the next operator via chaining or passing them to the final consumer of the processed data. We'll see some functional code shortly. So let's talk about the technical foundation that underlies the Spring WebFlux project. The first pillar we'll discuss is the Reactive Streams specification. The Reactive Streams specification defines how data elements are passed asynchronously between components in a non-blocking way. The API seems very simple, consisting only of 4 interfaces. Let's go ahead and take a look at them. So I'm going to navigate to the Reactive Streams specification website, and on the website you will see the Java API. If we take a look at the API, we will see the 4 interfaces involved. We have already seen the publisher and subscriber and discussed them. The two new ones are the processor and subscription. The processor is an operator that we can use to perform operations on data that flows from the publisher to the subscriber. If we take a look at the subscriptions, that's simply a representation of a subscription from a subscriber to a publisher. Now, anytime we have a specification, we need an implementation. And that's where Project Reactor comes in. Project Reactor is the reactive streams implementation that is favored by Spring Webflux. So we'll be using Project Reactor code throughout our examples demonstrating how to use Webflux. Let's take a look at some code for Project Reactor. Here I've put two snippets of code on the screen. The first is from Reactor and the other's from jQuery, just for comparison because they're kind of similar. They're not a one-for-one or identical or anything, but it's a good way to use something familiar to learn something new. If we take a look at the Reactor code, you'll notice we have a Flux object, and that is a producer. The producer will pass values to our map operator. The operator implements the processor interface that we saw within the specification. Basically, it's going to perform some operation on every value passed to it, and then it's going to pass the modified value on to the next leg of the chain. In this case, it's going to be going to our subscriber, which is specified as an argument to the subscribe function. So here you see I've just used a lambda function to print out the value being passed through the stream. The first thing really to highlight here is that we are using a Fluent API when working with Reactor, and that API relies heavily upon method chaining to build out these pipelines that we use for processing data. I would recommend investing some time into learning that Fluent API if you want to become proficient with Reactor. Reactor is providing implementations for those interfaces that we saw within the reactive stream specification. So we've seen how the producer, the operator, and the subscriber interfaces are implemented by Reactor. As we look at this code, you see the functional approach. Map is defining an operation, and then we're passing values to that operation, and that's similar to the functional style of programming we see in jQuery. So that's why we have jQuery's invocation of map up here for comparison. Basically, we are trying to declaratively perform operations as opposed to imperatively directing the execution of our program. So both of these examples could be achieved using a for loop. However, when we adopt the functional approach, we simply provide the function or operation, and it operates on objects that are passed into it. As we work with Spring Webflux, it will be important to know some of the basics of Project Reactor and functional programming. The Reactive Streams library has a heavy influence on applications built with Spring Webflux, and knowing these concepts will help us be successful. In this lesson, we'll walk through some simple demonstrations with Project Reactor. These examples will give you a glimpse of how a functional programming approach can be used with a Fluent API and give you hands-on experience with Reactor. Let's get started by creating a new Spring Starter project. We're going to name this new project the Spring-Reactive-Demo, and then we're going to adjust the group ID to com.o'reilly.reactive, and we'll do the same thing for our package structure. And then we're going to go ahead and hit next. And then when we search for the dependencies to include, we're going to look for the reactive web dependency. At that point, we go ahead and hit finish, and our new project will start to be built. So let's just take a quick look at our POM. We can see within the dependency hierarchy that we are indeed including the reactive core from Project Reactor. We're just going to use the unit test to run a variety of demonstrations with Project Reactor. So what we'll do is create a new test, and I'm going to name this test Reactive Test. So within the body of the test, I'm going to just output which example we are running. So we'll say example 1, and we're going to be running 3 different tests. So I'll just take this opportunity to duplicate our test methods, and then I'll rename them and change our console output. So now let's get started with our first test. This test is pretty simple. We are going to work with an array of characters. So I'm going to establish a character array that I'll call letters. And the letters array is going to basically spell out hello world. And now we have our character array. And what we're going to do is actually feed that into the Flux object using the fromArray method. So here we are establishing a publisher that we are going to use within the reactive stream that we set up. So we have the publisher. Now let's add the subscriber, and I'll just add a simple lambda. So here we're going to say assign each item to V and then pass V into our console output. And that's our first example with reactive. So it's pretty simple. We can go ahead and run the test, and we'll take a look at our console output. And once everything loads, there we see we get each character being printed out on a new line. You'll also notice that we have the other tests being ran. So let's go back, and now we're going to set up our second demonstration. So for this demonstration, we're going to go ahead and introduce an operator. So I'll grab the code from the first demonstration, and between the producer and the subscriber, I'm going to introduce the buffer operator. And what this will do is it will buffer the values passed into our subscriber from the producer into sets of 3. So we're going to see HEL get bundled into one value, and then LLO into another. So we can just run the example, and we can see how we can interject these operators to modify the flow of our reactive stream and to perform operations on the values that are flowing through it. So let's go ahead and we'll take a look at our output here. So we'll first run example 1, and there you see in example 2, we have modified the values passed to the subscriber based upon the buffer operator. And there are a ton of operators within Project Reactive that you can leverage in order to perform different operations on the values in your stream. Okay, now let's return to the console for our final test. And this test will demonstrate how we can execute our operations in parallel with concurrency. So what we're going to do is first add some console output that says we have finished the examples. If we grab our current example and place it within Reactive Test 3, what you'll see is that this will execute sequentially. You'll notice that we get the first console output, then we execute our asynchronous processing, and then we print out the finished examples console output. We want to now do this with concurrency in parallel. So the way that we can do that is by using the parallel operator. So we're going to get rid of the buffer operator. We'll use some different examples here. And we're going to say that we would like to use, if possible, 10 threads in order to execute our reactive stream in a concurrent fashion. Then we're going to invoke the runOn method, which allows us to specify a scheduler for our threads. And what we can do is look at the schedulers, and we're going to grab the elastic scheduler. Instead of buffering, we're going to use the doOnEach operator in order to help us out with our example. So within doOnEach, we are going to pass the value to our Lambda function. And within that Lambda function, the first thing we're going to do for demonstration purposes is print out the name of the current thread, just so we can see the multi-threading in action. And then I'm going to grab the current thread and tell it to sleep, let's say for a second. And then we're going to have to add a try-catch block to our code so that we can handle the interrupted exception. And then you'll notice we are still printing out the value as it gets passed and processed through our reactive stream. Now let's quickly run this demonstration, and I'm going to point out a very common problem that can occur. If we take a look at this demonstration, you'll notice that we never output any of the values going to our subscriber. And that's because the current thread that we're running our program on, the thread that our test is running on, it just finishes the execution and then exits our test method before the threads that we've created within our asynchronous processing ever get to finish their operations. So you can truly see the asynchronous nature of Project Reactor here. So what we need to do in order to make this a little bit more understandable and we can see that output, we need to actually grab the current thread that we are using to execute our test. We'll say that's the main thread, and actually sleep that thread. I'm just going to sleep it for 20 seconds. That should be enough. And of course, we'll need to handle the interrupted exception. I'm just going to throw it, and we can catch it on our test method. And now I'm going to go ahead, execute our tests, and this will be the final execution. And let's check out the output. Let's walk through this. We ran example 1, example 2, then we see example 3, and immediately we finished the examples. And that's because we're running our reactive stream asynchronously, so it did not block, and it allowed us to drop down to that console output. And then you actually see the doOnEach method start to work, and it's actually printing out the names of the different threads that it's using to process the operations within our asynchronous stream. And then we start to print out the different characters as our thread.sleep method expires. So there you can see now we're not getting them in the order we would expect, and that's due to the concurrency and the asynchronous nature of how we're running things. In this lesson, we'll learn how to use Reactor's monotype from a Spring Web Flux project. Mono is a reactive type that represents a single element or empty result. It is a special implementation of the publisher interface that can emit only one item. Let's walk through a simple example to see the mono in action within a Spring Web Flux project. So the first thing we're going to do is create a new Spring Starter project, And I'm going to name this project Spring-Flux, and then I'm going to make sure it's within the com.o'reilly.reactive group ID and within the com.o'reilly.reactive package. From there, we're going to include the reactive web dependencies and then go ahead and hit finish. That's going to cause STS to begin to build our project, and shortly we should see the source folders get produced. Let's take a look. There they are. Now within the com.o'reilly.reactive package, we're going to create a new class, and it's going to be a class named project. The project class is going to be very simple. It's going to have a name field, and it's also going to have an estimated hours field. And then we'll generate accessors for these fields. And then we're also going to build out the toString method so that we could print this object to the console. So we have our project, pretty simple. Two fields, a name and estimated hours. Now we're going to build a service that we can use to access the projects. So I'm going to create a project service. And within that service, the first thing we're going to do is add the service annotation, and we'll import that. So this will cause this class to become a bean. And then we're going to create a list of projects within the class as a new field. So there we're just using the new operator and the constructor to create a new list. And then we're going to add a populate method. So within this method, we're going to populate the list, but I'm going to add the post construct annotation to the populate method so it's called after the construction of our project service. And then what I'll do is I will assign our projects list. We're going to use the stream class, and then we're going to say this is a stream of, and we're just going to provide some project names. So let's say it's a software project, a hardware project, and a network project. And then what I can do is map each one of those options. And to do that, I just need to create a new project from the name. And then for the estimated number of hours, I can create a random integer. Now we'll have to build that constructor within our project. So let's navigate into the class. And there's our project constructor that accepts a name and an estimated number of hours. So at this point, we're building a project object for every one of these strings within our stream, and then we're just going to go ahead and collect those objects into a list. And that's how we're going to populate our projects. Okay, from there, we're going to now build out a method that is going to return a mono. So this method is going to have the mono type with a generic type of project listed as its return type. And then we're just going to call this method find by name. It's going to accept a string as an argument. And then we're just going to return a mono using the just method. And what we'll do is reach into our projects list, we'll stream it, and then we can use the filter in order to whittle down the project that we will return. So within here, we can just check that our name is equal to, and I'll use equal ignore case so we don't have to worry about casing, equal to the name of the project. So they pass in the name of a project to the method, then we iterate through all of the projects in a stream and check whether or not the name matches, and then we can return the matching object. from our stream, and we'll just get the first one so that we give it what it expects, and then we return it. So here the method is returning our mono, and now what we can do is build out a controller. So let's create a new project controller, and we're going to add the controller annotation to this class. We are then going to Autowire the project service, and we'll import that annotation. And then at this point, we're going to create a new method that returns a mono with a generic type of project. We'll call it getProject. And this method is going to take a string as an argument, and then we're going to use our service and its findByName method to return our mono. Now we need to add our request mapping to this method so that we can invoke the controller handler mapping. So we're actually going to use the get mapping annotation, which is a quick way of saying that we're going to allow this controller handler method to service get requests. And then we're actually going to use a path variable. So you can see that when dealing with Spring Web Flux, you're able to use many of the annotations that we can use when working with regular Spring MVC. In fact, we can use the path variable annotation in order to data bind our argument. And then the final thing we're going to do is add the response body annotation, another carryover from Spring MVC. And at this point, we are set up to run our demonstration with a mono from Spring Web Flux. So the first thing I'm going to do here is just right-click on our Spring Flux application, then go to Run As, and then Spring Boot App, and we can watch our console. You'll notice it's using the Netty web server, and it started very quickly. So at this point, we should be able to navigate to our browser, and from localhost, we should be able to navigate to /project, and then we're going to look for our software project. And we had an error. So let's just go check that out quickly. We forgot to add the request mapping annotation here to the project controller. So let me add that, and I'm going to restart the application. And now we should be able to invoke our controller handler method, and we get back our project object, and that object is returned by Spring Web Flux as a mono. So it's our first example working with Spring Web Flux and its support for reactive types. In this lesson, we'll learn how to use Reactor's Flux type from a Spring Web Flux project. Flux is a reactive type similar to mono, however, it can emit 0 or more elements. Let's take a look at using a flux within a Spring Web Flux project by working through a simple example. So the first thing we're going to do is create a new class within our project, and we're going to call the class Project Status. Within the Project Status class, we're going to create two fields. The first being a name field, which will have the project name, and then the next field will be the status field. I'm then going to generate a constructor for these fields in order to build the project status object, and then I'm going to create accessors for the project status object, and then finally I'm going to add a toString method. Okay, so we have those in place. Let's go ahead and save our project status, and we can close that class. The next thing we're going to do is add a method into our project service in order to return our flux. So I'm going to create a new method that returns a type of flux, and the flux will have a generic type of project status. And then we're going to name this new method getStatus, and it's going to accept a string, which will be the project name. And from here, we need to return projects. So what we're going to do is first handle setting the status of these projects. So I'm going to create a new string array, and this string array is going to contain our project statuses. So one will be started, another will be in progress, and then another will be completed. And with those in place, we have project statuses that we can use in order to build our project objects. Now, in order to build our project objects, we're going to use the generate method on the stream object. And this will just continuously generate objects that we instantiate. So we're going to create a new project status object. The first thing we'll do is pass in the name that was supplied to our method. And then we're going to just assign null to the status at this point. So we have our stream, and what we can do is pass this stream into a flux. So we're going to generate a flux from a stream, and that's how we're going to get our stream established, and it's what we'll be returning from our getStatus method. Now, once we have our flux established, we can set the status on each of the items in the flux. So we're going to use the doOnEach method, and we're going to set up a lambda here where we pass in the project status object, and then we're going to get the actual object and set the status on that project status object. So we'll assign a value to the field, and what I can do is just grab the status types array, and from here I'm going to grab a new random integer up to 3 so that we can grab one of the values in the status types array there. And then we can just return that from our service method. So when working with these lambdas and combining them with chaining, you always want to be careful that you're nesting everything properly. So just take a second to make sure you have everything syntactically correct within your getStatus method. Then we're going to move to the project controller, where we're going to establish our handler method. So the handler method is going to return a flux of project statuses, and we're going to name this method getProjectStatus, and then we're going to supply an argument to this method named name that will be of type string. You'll notice I use the path variable annotation, and that means we're going to be pulling the value for that variable from our path that's mapped to this controller handler method. So we're first going to pull out the name, and then the path is going to be /events. The other thing we need to do, since we're going to be continuously emitting values from this flux, is set our media type. And we need to set that to a text event stream value. And that's going to set up the server set events. And then we're going to add the response body annotation to our method. And now we can actually fill out the body of the method. And what we're going to do is return the invocation of our getStatuses method on our service. And then I'm actually going to use the delay elements method on the flux. And this allows me to specify a duration of how long between the elements being processed by our Flux and sent to the invoking client. So here we have established our project controller. And now what we're going to do is run our application so that we can see our Flux in action. So I'll just run this as a Spring Boot app, and it looks like we're good there. And here we have /project/software, and I can take a look at the events. And there you see the events that start to stream in from our Flux. In this lesson, we'll see how to use WebFlux's router function to route requests to handler functions in our project. A router function has the same purpose of the request mapping annotation. It routes requests based upon the path segments found in the URL. So a router function can serve as an alternative to annotations when mapping requests to handlers. Let's take a quick look at the router function in action. We're going to be working within the Spring Flux application class, and within the body of this class, we're going to create a new bean of type router function. And in order to create that bean, we need to add a method to this class I'm going to call routes. And then within the body of this method, we will work to return our router function bean. Now I need to add the bean annotation to the routes method, and now we're able to provide our code within the body of that method. Now in that method, we're going to be working with several methods that we need to statically import. So we're going to import static and then org.springFramework. And then we're going to be looking in the web.reactive package. And then we're looking for a function, and it's within the server package. And then if we take a look at the request predicates object, we're going to use the get method on the request predicates object. And then our next import is in a similar package. So I'm just going to copy that line. And then we're going to look within the body inserters object, and we're going to be using its from object method. So we'll see those in action here in a minute. Now from this method, we need to return a router function. And Flux provides us with an object that can help us there. It's the router functions object. And you'll see that it has the route method on it. There's also other methods that allow us to chain once we do return our route. So you'll see that we can provide a chain of different routes to these handler functions and actually specify multiple mappings to these handler functions. Now let's talk about this route method. You see that it accepts a predicate. A predicate is basically a conditional where we're going to specify a path and possibly a request type that the handler function passed in as the second argument to the route method will handle. So if we satisfy the predicate, then we will invoke the handler function. The handler function, you can think of it a lot like a controller handler method, except this one's going to receive a server request and return a server response. We're going to build a very simple one using a lambda, but first, let's focus on our predicate. Using the static import, we can easily invoke our get method, and this is just saying we're only going to handle methods of type get that come in from the request. And then we can go ahead and provide a path. So I'm just going to provide a simple path of hello. The next thing that we need to do is specify a handler function. So we're going to use a lambda here, and we're going to pass in the server request to our function, and then we can use the server response object So we'll import that type, and then we can invoke the OK method on the server response object to say that the response status for this request is OK. And then what we can do from there is build out the body of the response that we're going to provide. So from here, I'm going to use the from object method, which we have imported, and I'm simply going to specify hello world as the body of the response. There we can see that our static import for get was removed. So let's go and add that back in. Import static org.springframework.web.reactive, and then it's within the function server, and then from here request predicates, and then get. And then we also need to make sure that we import the router functions. So you can see, looks like some of our static imports are getting dropped. So we're just going to add those back in. We have to add in the from object once again, and now we should be good to go once we import the server response. So lots of imports going on here, but let's take a look at what we did produce. We built a router function that will service any requests that come in for the /hello path. And it's simply going to return a server response that states hello world. And we can now run this demonstration. There we see our server starting. Now we're going to navigate to localhost on port 8080 and /hello. And there we see the response from our router function. In this lesson, we'll learn how to build more advanced handler functions. Handler functions are used to service incoming HTTP requests. They receive a server request object and respond with a server response object that is contained within a mono. So in order to get experience building more advanced handlers, we're going to walk through a simple demonstration. The first thing I'll do is create a new class, and I'm going to name this class the project handler. Now there's no superclasses or interfaces to implement, so we just go ahead and create the class. And the first thing we need to do is add the component annotation to the class so that it is picked up during component scanning and made into a bean. We're then going to add a project service object to this class, and we'll then build a constructor based upon our project service field being injected into the constructor and assigned to our service field. From there, we're actually going to define our handler method. So we're going to create a method that returns a mono that contains a server response, and we're just going to call this method findProject. It will accept a server request object that we're going to name request as an argument. So let's import those types. And now what we can do is work to define the body of this method. So we're going to first start out by retrieving a project and putting it within a mono. So we can do that by using our service and its findByName method. Now, one of the neat things about using the server request, you'll notice that it has access to path variables as well as different attributes. It can also access the request body, turning it into a mono or a flux. It can access the headers of the request. So it has a lot of access where we can pull information from the request in order to determine how we'd like to process it. In this case, we're actually going to pull a path variable named name. And that's going to be the name of the project. We'll pass that name into our service's findByName method, and that's going to return a mono containing a project. And then what we need to do is build out the response. So we're going to use a server response object. We will set the 200 status to indicate it was successful. And then we can also set many of the data points that are found on an HTTP response. So here you can see we're setting the content type, and we're going to set that content type to JSON. And then we're going to actually provide the body of the response, and it's going to be our mono containing the project. And then we need to specify what the type is inside that mono, so we can say it's a project. And there we've built our first advanced handler function. Just remember, you need to return a mono containing a server response, and you're going to accept a server request that you will use to perform your processing. And then there's all sorts of objects with chaining that are available to you within Spring Web Flux that will facilitate you as you build out that response. Now let's take this find project method, and we need to navigate to our router. So let's take a look in our Spring Flux application class where we are establishing our router functions. And what we can do from here is we can call the and route. So once again, you're seeing more of this chaining that we can do. And we can now provide another predicate. And the predicate for this router function is going to be a get, and it's going to map to the path project /name. And notice how I'm defining that path variable within the path. So we'll be able to pull that out. And then what I can do is I can pass in the handler to our routes function. So we can specify an argument of type project handler, and I'm just going to call it handler, and it will be injected into our routes method when we're building out our router functions. And then I can just take the handler and invoke the find project method on our handler. Now, one thing we have to be aware of here is we're creating a conflict. You'll notice that our predicate specifies the path /project /the name. If we navigate to our project controller, we do have a conflict with this method. So what I'm going to do is, just to neutralize our project controller, I'm going to remove the controller annotation so that we can only utilize our router function when running this demonstration. So we're going to make sure everything's in place, and then we're going to go ahead and run our application. So I'll just kick it off as a Spring Boot app. So there we see that it has started, and then we can navigate over to our application, and we're going to hit the /project /software URL, and that's going to cause our router function to route the request to our handler function that we've just defined. Congratulations! This is the last lesson within our course. So we're going to take a minute to reflect upon what we've learned and talk about other areas that you can explore, which are kind of a natural extension of Spring MVC. Looking at some of the key takeaways from this course, you should understand that Spring MVC is really there to facilitate your development of Java web applications. You really should not be writing your own framework to handle Java web applications or your own MVC framework. Spring MVC provides you with a well-tested and proven approach to developing Java web applications, and it contains many features that really handle all of the use cases you will experience when developing a web application. If you were to pursue developing your own MVC framework, chances are it would be a lower quality than Spring MVC, and you would end up recreating a lot of the functionality already contained within the framework. So it's a best practice to use a MVC framework such as Spring MVC that has been well established and well tested, as well documented by a lot of experts out there. You should have learned that the framework revolves around a dispatcher servlet, which implements a front controller pattern, and that dispatcher servlet integrates with the Spring IOC container. So this allows us to use all of the great features that we find in Spring Core, such as dependency injection. And using this approach, we're allowed to build in a lot of components just by auto-wiring them up, and we don't really need to code all of the injection of those dependencies within our classes. So having Spring as the backbone of our MVC framework really makes our coding a lot more flexible and robust. You should also be familiar with the key features of Spring MVC that help us with request processing. So some of the big ones here are data binding, view resolution, and just generally controllers and all the richness that they provide for our development. We saw a bunch of areas where we can customize the request processing approach that Spring MVC takes. So using things like the request mapping annotation, and also things like our handler interceptors, our controller advice, also using things like SessionAttributes and the response body annotation, we can really manipulate the framework because it's coded in such a flexible manner. So with these newfound skills, you're going to find that you're able to develop web applications that are easier to maintain and much easier to work with and understand. The code will be very intuitive. You'll know the architecture of the application, and there's not a lot of surprises. You really know what to expect when you're working with an application that follows the Spring MVC architecture. So let's talk about where you go from here. What do you do with this newfound knowledge? Well, the first thing I'm going to recommend is to just start using the framework in your daily work, maybe in your career, or just maybe on side projects that you're working on. And as you continue to work with Spring MVC, you're going to become more familiar with it, and you're going to explore some of the very remote areas of the framework, and you'll really master using Spring MVC. So once you are comfortable with Spring MVC, you may want to look at securing your web applications using Spring Security. Spring Security is another library within the Spring umbrella that provides us with a Spring approach to securing applications. So we're talking about authentication and authorization here, and there is a great approach that Spring takes that really uses the dependency injection as its core and as its foundation. You can also move on to looking at building an application using microservices, and this is really cutting edge. People are looking to divide up web applications into smaller parts, really following the single responsibility pattern. And these smaller parts are used together to form a complete application. There's a lot of heavy client-side use invoking the different microservices, and they're all kind of tied together on the client through invoking microservices. So that's an area you can look at. And Spring MVC really lays the groundwork for building microservices if you're going to follow the Spring approach. Another thing you might want to look at is switching over your view layer to Thymeleaf. And Thymeleaf is a new view framework that's out there. It gains a lot of traction. It's very good for templating. If you're looking to kind of move away from JSPs, that is one option you have. Finally, I'd like to say thank you, because folks like you that are interested in improving their coding skills and their Java development skills really allow me to do what I enjoy, which is building these courses and sharing what I have learned about different Java technologies. So I really commend you for going the extra mile and continuing your education in the field of Java development and programming in general. It's a great and exciting field. Once again, thank you for watching.